Questions from a very important chapter, concentration. So increasing concentration. Hello, assalamu alaikum, dear students. Hopefully all of you are well and all right. Today I'm going to solve questions from a very important chapter, which is chemical change. In our today's masterclass, we will at first know about the topics that are present in the chemical change chapter, which is very, very important for medical admission test as well as all other admission tests. And later on, we will be solving questions from some selected topics. First, I would like to mention that from there, how you can easily remember all the catalyst that you need for solving MCQs in the medical admission test. Moreover, you have to have the expertise to solve pH-related mathematical problems without a calculator. So pH of solution, buffer solution is another crucial topic from this chapter. This topic is also very important, but this is such a topic which can be solved or which can be tackled easily if you have clear concept. I mean, which one is strong acid, which one is a weaker base. This is a question that can be easily formed and that can be easily obtained in our admission test as well as any competitive exam. So you have to have the clear idea regarding determination of strength of acid and bases. Moreover, rate of reaction. Actually, we require only units regarding this rate of reaction and rate constant and all. Anyway, out of all these topics, the star marked by me, and also I have forgotten to mention this Lachatel principle is also very crucial. So from my side, I would recommend you to study a bit more regarding these 4 points, which are, I think, very much important for your admission test. But in this lecture today, I'm going to solve questions from rate of reaction and activation energy, as well as chemical reactions and green chemistry, reversible and reversible reaction, catalyst, and also bicatalyst, which is also known as enzyme. From this topic, the first one, which is chemical reactions and green chemistry, not very frequent appearance in our medical admission test. You see, it has appeared in prehistoric era. In fact, 2002 to 2003 is much more. It is much more older than your birth year. Anyway, for this topic, I would like to recommend you that just focus on your basic conscience. You do not have to recall or remember all the 12 principles of green chemistry. The 12 principles all are aligned with the greener environment. For better environment, we need to choose one technique which is actually falls under the guidance of green chemistry. So while choosing the options, which one is the principle of green chemistry, you have to remember the 12th principle. Actually, it does not happen this way. You have to just apply your conscience and you have to apply your common sense, in fact, to determine which is better for the environment. And thus, you will be guided in the right direction. Anyway, let's see what questions are there or how many questions can be in different writers. How many internationally acknowledged principles of green chemistry are there? This is a very easy question, which is 12. In this regard, I would like to mention that green chemistry can also be termed as clean chemistry, can also be termed as benign chemistry, and most favorably, it can be termed as environment friendly. Environment friendly. The concept of green chemistry was proposed by 2 scientists, which are Paul Anastam and W.G. Warner. Warner and Anastam. These 2 scientists came together with this proposition, which is called green chemistry. Actually, this is something that directs the chemical process to an environment-friendly approach. There are lots of chemical processes which are continuously harming our environment and harming our future. That's why they are concerned and they planned some principles. They came out with some principles. If we follow those principles, then it would be possible to chemically sound and environmentally sound altogether. Anyway, let's move on to the next question. Which of the following is not correct among the 12 principles of green chemistry? See, I was mentioning about this type of question for which you do not have to remember all the principles. Right? Let's check it out. First of all, prevention of waste material would certainly be a principle of green chemistry. Next, highest atom economy. You may not know what is atom economy. I would like to say that atom economy can be easily stated as a ratio of desired product divided by total product. So if your desired product is generated more in comparison to the total product, then that means you are successful. That means the amount of waste or unwanted substance is less. In this case, the atom economy would rise, right? So a better atom economy is always our target. Again, healthcare of workers. Actually, healthcare of worker is not a matter of consideration regarding green chemistry. Green chemistry mostly involved with the process. It is not involved with the man or person behind the process. It is only related to the process. So this is not going to be the principle of green chemistry. On the other hand, prevention of accident would certainly be beneficial for everyone in the environment, not just only workers. It will also help us from some potential environmental hazards. That's why prevention of accidents is included in the 12 principles of green chemistry. In the next question, which is a green solvent? In this regard, I would like to mention that in our book, they have provided some criteria regarding green solvent. Which are those? These are, and what are those? These are first, non-aqueous ionic solvent. This is the preferred one. Again, in case of covalent solvent, you have to ensure that the solvent is non-volatile. So which can be written as non-volatile organic solvent. Lastly, the water-based solution or solvent can be applied over here as a green solvent. So we can add up using this, that water-based solvent. Anyway, these are called green solvent. Moreover, there is also another example of green solvent in our GOSAR book, which is supercritical fluid, which is carbon dioxide at its critical temperature, that is 31.5 degrees Celsius, and critical pressure, which is 72.9 atmosphere. At the critical temperature and critical pressure, any gas can become liquid. So this liquid carbon dioxide would act as supercritical fluid. Actually, the value over here would not be 31.5, it would be 31.1 degree Celsius. Anyway, now let's figure out what are the options. Solid carbon dioxide is also known as dry ice. It is not used as a solvent. Moreover, the gaseous carbon dioxide is known as actually, it is nothing to be known of, but it is a common gas that is constantly emitted from our nostrils and all the living beings as a part of or as a product of respiration. Carbon dioxide below 31.1 degrees Celsius would certainly falls under the criteria to become critical fluid, but only temperature lower than 31.1 degrees Celsius is not enough. It is also required to put a pressure of around 72.9 atmosphere to this compound to make it a solvent or to make it liquid at that temperature. Anyway, carbon dioxide 72.9 degrees Celsius would not certainly be the case here, so our option C is the correct one. In the next question, we are saying that which of the following is not correct. It is asking about not correct among the 12 principles. Okay, again, there is a potential or area to apply our common sense. First of all, safer solvent would be everyone's choice. Next, prevention of waste material is also our goal. Least derivative would certainly align with our targets. And last one is natural chemical plan. Basically, no such thing is there in the principle, and actually it doesn't get any significant sense that how is it going to contribute in green chemistry or greener environment. So this option is the incorrect one, or which is not included in the green chemistry principles. Which of the following is not correct? Is not correct among the 12 principles. So similar situation here, we can see that use of safe solution. Actually, this was not in the option. If you notice the previous question, you would find that there is a statement regarding the usage of safer solvent. Notice that what is written here. Here it is written that solvent. If it was solution, then it would not be included in the principle. So in this case, we have found the correct answer at the very outset, which is use of safe solution. This is not correct. What should be the correct one? The correct one would be solvent instead of solution. Monitoring pollution in real time, application of catalyst, use of minimum risk approach. All of them are included in the green chemistry principles. Again, we obtained similar information. Actually, with solving this question, we have gathered enough data to at least recognize the principles of green chemistry. I mean, look at this question. Here, one option is not included within the 12 principles, but remaining 3 are principles. So with reading all the options, you'd be able to know at least 3 principles and one which is not principle in the green chemistry. Anyway, use of less raw. This is not mentioned in our green chemistry principles. In case of green chemistry principles, it have stated that you have to use some renewable materials renewable raw materials, which can be or recyclable materials in the chemical process. So in this case, less raw is not a thing actually. So the option A is not correct. Use of safer solvent is also mentioned in our previous question. Monitor pollution, application of catalyst, all of them were included in the previous question. Anyway, let's move on to the next question, which is not correct. According to Husserl, atomic economy is equal to mass of product divided by mass of reactant percentage. This is a bit correct because in terms of total reactants, how many reactants are converted into total product? The ratio would certainly give us an idea about the desired product. So in this case, option A is correct. E factor is another ratio which actually demonstrates the amount of waste generated in the process in comparison to our total product. On the other hand, the higher the value of atomic economy, the greener the production process is certainly true. So let's move on to the last option, which is here that the higher the E factor, the more environment friendly it is. This is actually the opposite. Instead of the higher the E factor, we have to mention that it should be lower. Once the E factor gets low, it becomes environment friendly because here the ratio corresponds with the total mass of waste. Okay, so which one is the correct answer? The correct answer is D, not C. Anyway, let's move on to the next question. Which one is the green solvent? As we have already solved this question, we can easily mark option D as the correct one. Next question, before going to next question, we actually jumping into the next topic, which is irreversible and reversible reaction. In the latest admission test that carried questions from this topic happened around 10 years ago, not 10 years, in fact 14 years ago. Anyway, what kind of questions can be there in our admission test? You may find questions regarding the rate, regarding the delta G value, regarding the conversion techniques. I mean, how can you convert a reversible reaction into an irreversible reaction? Such questions can appear in our admission test. Okay, which one is the condition for irreversible reaction? For an irreversible reaction, the reaction is unidirectional. I mean, it ends completely ends the reaction. In this case, let's just read out the options. First one is reaction taking place in a closed container. In a closed container, usually reversible reaction takes place. Actually, Barthollet, there was a scientist named Barthollet who provided us the concept of reversible reaction. According to him, or his principle, that all of the reactions that occur in our chemical world are reversible, but some do not show reversibility because of the environment they are into. So the system may not allow reactions to become reversible, but the situation or the aim of a reaction was to become reversible. So if we can provide such an environment in which the reversibility ensures, we can prove a reaction that they can happen in a reversible fashion. Anyway, reaction taking place in a closed container would certainly indicate reversible nature. The next option, as we can see, mentioning that occurrence of precipitate. Once a precipitate is formed, then it means it is no longer participating in the reaction, which enables them to go backward. So in this case, option B is the correct one. Since no backward reaction is possible, only forward reaction is taking place. So this one is irreversible reaction. Incompleteness of reaction. As the reversible reaction never ends, so this one will also be true for reversible. Again, reaction existing in an equilibrium. This is also applicable for this reversible reaction. For reversible reaction, the delta G value is equal to 0. The delta G value represents change in free energy. Change in free energy. Since some reactants are becoming product and some products are becoming reactant, so the change in energy gets equal. The change in free energy is actually 0. That's why this is a reversible. In case of irreversible, the energy available in the system gets consumed. That's why the free energy gets decreased. Anyway, let's move on to the next question. Which of the following reaction is reversible? The first one, in this case, there is a solid. If there is anything solid, it would not certainly be a reversible one. Anyway, the next option mentioned that lead nitrate reacts with potassium dichromate. Also, we got another solid. That's why it won't be the case here. Option C, here we can also find that there is a solid one. So basically, this one is incorrect too. Lastly, as we can see at option D, here no such reactant or compound is present which is solid. So this is possible in both ways. That's why it is reversible reaction. Anyway, let's move on to the next question. Here it is asking about which one is irreversible reaction. In this case, the nitrogen tetroxide generation is a reversible reaction. Let's just correct the version. So this one is a reversible reaction. This one is a reversible reaction. This one is also a celebratory reversible reaction. This one will never be a reversible reaction because the sodium is a solid, chlorine is a gas. Together they react to become another solid, which is sodium chloride. Anyway, this is not going to be an example of a reversible reaction. Rate of reaction and activation energy. As you can see from this topic, we found questions in our recent admission tests. That's why I would recommend you to read or get the clear ideas regarding this topic. And I think it would be helpful from this class also that you try to learn how we are approaching the questions. Like this one, which of the following is the unit of reaction rate? So basically, what is the reaction rate? Reaction rate means rate of change of concentration with time. It can be determined in the perspective of reactant, or it can be determined in the perspective of a product. Let's say this is a question, this is a reaction where AA reacts with BB. That means A mole A reacts with B mole B. In this case, C mole C along with D mole D is generated. Now, for this reaction, if I try to determine the reaction rate, then what will be our approach? The reaction rate R will be equal to minus, for a smaller time dt, if the change of concentration becomes dA. So for a mole reactant, the rate would be dA by dt. But for determining the rate for 1 mole reactant, we have to divide this with the mole number. So the rate actually will be minus 1 by A dA by dt. Similarly, we can consider or we can determine the rates for different reactants this way. Now you may wonder, for reactants we have added the sign negative. Will that be the case for the product? I think you certainly know that reactants decrease or products increase in a reaction. So in this case, the negative sign actually represents the decreasing nature of reactant. So this minus sign is not a very significant one, and it is not applicable for the product side too. For product side, we write class 1 by C, dC by dt. Along with that, for another product, we have to mention that 1 by d, dd by dt. Here the capital A, capital B, capital C, capital D, these are basically concentrations. Anyway, now if we are asking about the unit of rate of reaction, so we can easily determine the concentration can be expressed in mole per liter. This can be expressed as mole per liter. And again, the time can be demonstrated or represented as second. So the unit becomes mole per liter per second, which is present in option A. So A is the correct answer. You should remember that the rate of reaction is something that is very easy to calculate. I mean, for every reaction, the rate unit, the unit of rate of reaction is similar for any reaction. But for determining the order of reaction, you have to be considerate about the powers of reactants concentration according to which the rate increases or decreases. I will clarify this again in our upcoming question. Now let's move on to the next question. How is the reaction rate related to temperature? Here I should mention that reaction rate is dependent on different factors, which can be remembered this way: A, T, P, C, L. Here you can see that I have written these letters in two different colors. Basically, the green ones are very important or most important in these four factors, which are responsible for influencing reaction rates. With A, I meant area, that is surface area. Once the reactant shows higher surface area, the potential to react becomes more. So as you know, in our case, the lipid digestion does not take place without any bile. Bile is responsible for the emulsification process, which results into higher surface area of the lipid molecules that enables the enzyme lipase to work on that. In that case, we have demonstrated the proposition of surface area increase regarding facilitating reaction. Similarly, as we can see here, area or surface area is also a factor that influences the rate of reaction. The next one, which is T by T, we meant temperature. The temperature issue was described by a scientist named Arrhenius. Arrhenius mentioned that if you increase the temperature of a reaction by 10 degrees Celsius, then the rate becomes twice or thrice of its initial value. So Arrhenius, the scientist Arrhenius, who is also responsible for the ionic concept of the acid base, has provided us an important data regarding the temperature affecting reaction rate. The next option here is pressure, which is only applicable for the gaseous reactants. Once you apply more pressure, then the rate of reaction will certainly increase. Do not fall for the trap of Lashkar principle if you are asked regarding reaction rate. I mean, for an exothermic reaction, if you increase temperature, what will be the rate of reaction? Will it increase or will it decrease? Then you may wonder that why do we have to worry about this one? We have already solved such questions in our HSC syllabus that in case of exothermic reaction, if you increase the temperature, then it is what you are doing, what you are not supposed to be doing, which is why the reaction will go backward. But here the question is not about the direction of the reaction; it is rather about the rate of reaction. You have to think this way: once you increase the temperature, the concentration does not get affected, but the molecules try to move faster, and moving faster would compel them to collide. So as per the collision theory, more amount of molecules would get activation energy. Hence, the reactants will much more be available for the reaction. As a result, the rate of reaction would go high. I mean, would increase. That's the way temperature affects the reaction rate. It also happens for both of the isothermic and endothermic reactions. The temperature, the enthalpy change does not affect the role of temperature regarding the reaction rate. Rather, it influences the direction of the reaction. I mean, in which way the rate will increase, forward or backward. What will be the amount of product, increase or decrease? In that situation, you will apply the Lashkar principle. Anyway, C is corresponding to concentration. Regarding concentration, we found another scientist, which is Wilhelmy. He graphically demonstrated that increasing the concentration would result to increasing rate of reaction. But you should know that this is not the case for every reaction. Not all the reactants do matter in determining the rate of that reaction. Sometimes a reactant may not influence anything about the rate of reaction. In that case, if there is no reactant which influences the rate of reaction, then that reaction can be termed as zero order reaction. So there comes the new word, which is order. Order is basically a power. Power to which? Power to concentration. So basically, the degree or power of concentration to which rate depends is basically termed as order. Suppose I'm saying that R is proportional to C naught. What does it suggest? It suggests that it does not depend on the concentration of any reactant. So in this case, the R value would be equal to what? K. Since you need to put a constant to remove the proportionality sign, in this case, we got R equal to K. Again, for first order reaction, this one is for the zero order reaction, and this one will be for the first order reaction. For the first order reaction, as we can see, R is proportional to C. That means no power means there is a power 1. In this case, R will be equal to Kc. Anyway, these are the rate constant equation of different order of reaction, and we are not considering the rate constant here, we are considering rather concentration. So increasing concentration in the reactant side would certainly propel the reaction in the forward direction. C stands for catalyst. Though it is mentioned late and in different colors, still it is very crucial for our admission test. Catalyst can fasten the reaction, can slow him too. I mean, if you have a positive catalyst, it will certainly increase the reaction rate in the forward direction. On the other hand, the negative catalyst would do the opposite. And catalyst is a molecule that influences the reaction, but they do not participate in the reaction. And lastly, some reaction is dependent on light. Suppose photosynthesis, it would not be possible without any sunlight. Again, sunlight or light, it would not be possible without any light. I can also say some about some free radical reactions that happens in the atmosphere, which is also not possible without any light. Anyway, now from this question, how is the reaction rate related to temperature? We can say that this will be proportional. This will be proportional. But to what amount this is proportional is a different entity, which is also known as order of a reaction. Which one is directly related to the determining activation energy of a reaction? Concentration of reactant, nature of reactant, temperature, collision rate. You have to know that the activation energy can be obtained from the temperature. Okay, from the Arrhenius equation, we can easily say the fact that temperature influences the activation energy of a reaction. Which one is correct for first order reaction? Now, this is a question that appeared long ago, but all the information mentioned here is included in your book, so you have to read very carefully to have a clear idea regarding your admission test. The first option is asking that the unit of relative rate of reaction. Actually, what is the relative rate of reaction? Relative rate of reaction is also known as rate constant, which is also known as rate constant of a reaction. The rate constant unit is solely dependent on order of the reaction. Let me show you. R is proportional to C1 for the first order reaction, so we can easily say that R will be equal to Kc. Now we have to determine the unit of K, which is C by R. Now, if you consider this way, that concentration can be expressed in mole per liter, and the rate can be expressed as mole per liter per second. So the unit here will be per second mole per liter. So basically the writing got wrong here. It should be R by C. R by C. So we have to just mention the per second over here and remove the per second from the bottom. So ultimately our unit will be per second for the first order of reaction, which is mentioned here as liter per mole per second. Liter per mole per second. Let's determine the order. Let's determine the order for such unit. I mean, if you go for the second order reaction, what would be the case? You have to mention that R will be equal to Kc square. Yes. So in this case, since it is Kc square, so we have to mention that K will be equal to mole square liter inverse 2, and at the bottom there will be mole, not mole square liter inverse 2, it will be mole, since the R will be at the top, so it will be just mole per liter per second, but at the bottom it will be mole inverse, not mole square, it will be mole square liter inverse 2. Okay, now let's figure out the total situation here. So if we divide it, we'll get mole inverse 2, mole inverse 1, since there is a mole and here is mole square, so if we divide, it will be mole inverse 1, it will be liter, it will be per second, which is mentioned here. So as we can see, this option is for second order reaction. For the first order reaction, the answer would have been per second. Okay, now so this is not correct. Relative rate of reaction K is equal to 1 by Tx divided by A by A minus x. No, this is not the case too. This is wrong. Now here it is mentioned that T half does not depend on the initial value of concentration. So I have to mention that the T half here is equal to T half. T half means half life. T half for a first order reaction is equivalent to ln 2 by K. Since ln 2 and K both of them are constant, so we can easily say that the T half of a reaction is basically constant. So in this case, it would not be dependent on the initial concentration of the reactants. So the option C here is the correct one. Here the correct option is option C. And the last option is asking that concentration increases linearly with time. In case of first order reaction, the concentration does not increase linearly with time, rather it decreases. I mean, it's not mentioned here about what concentration we are talking. Is it of reactants or products? This is not clear here. So the answer C is the correct one. Anyway, let's move on to the next question. Which factor does not? You first notice the negative thing in the question to be aware that you do not mistakenly mark anything. Which factor does not influence the rate of reaction? In this case, as we can see, absence of light would not be an option, as we have already learned that ATP-CCl, surface area, temperature, pressure, catalyst, all of them are capable enough to influence the reaction, but absence of light would be the case. Light would be able to influence some reaction. For decreasing rate of reaction, which one is true? To decrease in rate of reaction, we need to increase in concentration of reactants. No, it would certainly increase the rate. Increase of temperature, 10 degree rise of temperature can double or triple the rate of reaction. Again, increase of activation energy. Increase of activation energy, actually true. Why? Because when the activation energy gets increased, the energy hill that it needs to cross for a reaction for making a reaction happen, I think becomes higher. So it would be difficult to cross that energy hill if the activation energy becomes high. So in this case, option C is the correct one. You have to remember that we can represent the activation energy this way. If it is the reactant energy, if this is the product side energy, the amount of energy that it requires to avail or to make the reaction happen is called activation energy. Here, as you can see, this one, if I consider a baseline, okay, if I consider a baseline, this is what the activation energy. So I can mark it this way. This is the activation energy. But for a catalyzed reaction, the ER and EP remain same, but the activation energy gets decreased. This is for a catalyzed reaction. So you should know that the catalyzed reaction is capable to decrease or lower the activation energy to make the reaction faster, but they are unable to change the enthalpy, which is determined by ER and EP. We know that delta H equal to EP minus ER. Delta H is the enthalpy, which can be obtained from EP minus ER. That is the product side energy minus the reactant side energy. So as we can see, that activation energy, if gets higher, then the rate of reaction will be low, because this barrier needs to be crossed to converting the reactant into product. Which is the highest rate of reaction? Here we are observing some different reactions, but you have to know that the highest rate of reaction is possible for the zero order reaction. Basically, why? Because it becomes a free radical mechanism reaction that becomes a chain reaction eventually. So in this case, once methane binds to chlorine, it does not stop just becoming methyl chloride. Rather, it continues to add chlorine to become a carbon tetrachloride at the end. And in this case, we can easily mention that this option is the correct one here. The highest rate of reaction is obtained in this reaction. This is a free radical mechanism reaction, and we have to mention that this is a zero order reaction. Why this is a zero order reaction? Basically, is there any way to determine the order of reaction by just looking at the reaction? No. If someone tells you that they can determine the order of reaction by looking at them, they're faking it. Why? Because it's not possible. You have to have some quantitative data according to time to determine the order. Moreover, you may need to have the graphical representation of the change of concentration over time. You at least need to have the rate constant unit, which can be determined from the rate equation. So all these are not available. Yet I have mentioned that this one is a zero order reaction. Why? Because this is the only reaction where order can be determined by just looking at that, which is H nu. You will find H nu, which means that it is coming from sunlight, and the sunlight is responsible for the reaction, not the reactants, not the products. So this one is zero order reaction. Which one is an endothermic reaction? We have solved this question in our earlier lecture, which is basically a heat of formation, but heat of formation usually becomes exothermic. There is an exception to that, which is formation of nitric oxide. This nitric oxide formation is not an exothermic process; it is an endothermic process. And in this case, delta H value becomes plus 180.6 kilojoule per mole. Okay. Now let's move on to the next question. Basically, we have discussed this in our upcoming lecture, where we will be discussing regarding the heat changes in different reactions. And to sum it up, I can still add the mnemonic over here, which is in Bangla. You should know that ghono doi সংলাপ. This is the Bangla mnemonic that can be used to remember all the exothermic reactions. How? Let's find out. With ghono, I have mentioned ঘনীভবন, which is basically condensation in English. So condensation is an exothermic process. Now with do, we meant dohon, which is again a reaction that starts with C, combustion. Usually combustion requires oxygen to generate carbon dioxide and heat. Now with E, this is basically not a reaction, but this is also exothermic. This is the amount of energy released while forming 1 mole of anion, which can also be termed as electron affinity. Now let's come to the Shong part, which is Shongotron in Bangla, and in Bangla it is heat of formation. Heat of formation. La stands for lattice enthalpy. Lattice enthalpy. And the P or Po stands for Proshomon. In Bangla, it is Proshomon when acid reacts with base, but in English, it is neutralization. Neutralization. Okay. Anyway, these are the cases, in fact, where the reaction becomes exothermic. But though it is a type of heat of formation, but it is not included here because it is an exception. Okay, let's move on to the next question. The activation energy of different reaction is given, which will have the highest rate of reaction. The highest rate of reaction would be represented in the case of lowest activation energy, which is option D. Next question is asking that in exothermic process, which is true, internal energy increases. No, in exothermic process, energy is dissipated. So to dissipate the energy or dissipate the energy, you need to lower the internal energy. So the internal energy decreases. Relative rate constant of a reaction measures what? Basically, relative rate constant, it means the rate constant basically, which is basically dependent on the rate of reaction. So the option here would be B, which is rate of velocity of reaction. Okay, the velocity is not a proper term in case of reaction. Why? Because this is not a vector quantity. Rather, we should mention it is as speed of reaction. Okay. Next, move on to the value. Next question, which is the value of the first order. Where it is written that this is a first order reaction. I mean, the value of the first order reaction rate constant is not dependent on which of the following? Is it dependent on temperature, half-life reaction, catalyst, concentration of reactant? Basically, the rate constant value is not dependent on catalyst. Catalyst does not influence the rate constant. Neither it influences the chemical equilibrium also. So in this case, the answer will be C. Rate constant is only dependent on the temperature. Okay, let's move on to the next question. What is the rate of a chemical reaction? What is the rate of a chemical reaction? As we have solved it earlier, we can say that it will be the change of concentration divided by time. And is it the concentration of the reactant or the concentration of the product? Here, the concentration of the product side should have a plus sign. So here the proper answer would be option C. But I can vouch that option D is correct too. But since in our book, I mean in Kobi sir's book, only option C is given as answer, so we should consider the part of reactant. What is the unit of rate constant for second order reaction? We have already determined that, which is mole per liter per second. No, liter per mole per second. Let's move on to the next question. Which one is correct for first order reaction? Unit of rate constant is per second. We have already solved that. Which reaction has the lowest activation energy? I mean, which reaction is the fastest here? As we can see, the rust formation is a very slow process. With this option, you should also learn the formula of rust, which is also important. And in the option B, as we can see, acid is reacting with base to generate salt and water. This is a very rigorous reaction that takes place instantaneously. So this one should be, but with lower or lowest activation energy. The option B is correct here. As you all know, to generate ammonia is not an easy task. I mean, nitrogen and hydrogen reacts in a Haber-Bosch process in a well-controlled environment to generate only 15% ammonia instead of the usual 7% that we get. Anyway, this is a slow process. That's what I meant. And the option D is also slow. Anyway, in the next question, as I was talking about, this is the reaction of Haber-Bosch process. If temperature, this is the exothermic reaction, right? This is the exothermic reaction. Here it is mentioned that if the temperature of this reaction is increased, how it will affect the production of ammonia. See, you have been asked about the production of ammonia. So if this is an exothermic process, we have to apply the Le Chatelier principle here to determine the product of the production of ammonia. For an exothermic process, if we raise the temperature, so we are doing the same thing as the reaction. So the reaction will move backward. If we could do opposite to what reaction does, then the reaction will try to push me towards the forward direction. I mean, it is generating heat. If we try to remove the heat, then it will work forward to generate more heat. That's how it turns, or it wants to create a balance or balance the situation here, which is also known as equilibrium in our chemistry. So in this case, how will it affect the production of ammonia? It will certainly decrease the production of ammonia since the backward reaction will increase. Nitrogen dioxide reacting with carbon monoxide to generate nitric oxide and carbon dioxide. Here, as we can see, the concentration, the rate, in fact, is not dependent on the concentration of carbon monoxide. So since the order, I mean the power is mentioned 0 here, so will it be 0? No. There's a fact, which is you have to determine dC by dt for all of the reactant side. In this case, for nitrogen dioxide, we can write this way, that it is dependent on the partial pressure of, so basically we can express the concentration for liquid or partial pressure for the gas. The partial pressure P of NO2, it is dependent on the P of NO2, but at what degree? Basically, it is directly proportional to the partial pressure of nitrogen dioxide. So here the order should be 1. Now you have to add up all the orders, all the powers together to get the final order of reaction. So the value would be 1 plus 0, which is equal to 1. So the option B is the correct one, not option A. In case of exothermic reaction, the total enthalpy of product will be greater than or less than total enthalpy of reactant. Just consider this. Delta H is equal to EP minus ER. So for exothermic reaction, the delta H value will be negative. So get a negative value, you need to have a higher amount of negative value. So the total enthalpy of the reactant side should be greater than the total enthalpy of product to obtain a negative value. Which of the following indicates the rate of reaction for the reaction AABB? We have solved that already, which is minus 1 by A minus 1 by A d of A by dt. Now let's move on to the next question. The rate of chemical reaction depends on what? The rate of chemical reaction would certainly depend on the concentration of reactant. And from this concept, we get the concept of order. For the reaction AABBCCDD, which indicates the rate of reaction? So option A is not correct. Why it is not correct? Because you have to multiply it with 1 by A. Why this is not correct? You have to multiply with 1 by B. 1 by C minus dC by dt is also not correct because the sign will be plus. And lastly, the option D is the correct one. Now let's move on to the next question. The extent to which a chemical reaction is completed per unit time is called rate. This is a very silly and simple question. Which one indicates the correct rate equation for the reaction A plus 2B? Now, for a rate equation, you have to mention this way, because this is the product side reactant. The product side rate would be, I mean, how will you demonstrate? How will you demonstrate the rate of reaction? The rate of reaction would be equal to, I mean, the rate constant K will be equal to the concentration of the product divided by the concentration of the reactant. Now, with the rate equation, you have to divide the rate constant, I mean, in a shorter phase of time, what will be the change of product? In this case, the option, among all the options, option D is the correct one. Why? Because here the power of A and the power of B is mentioned in the correct order. Let's move on to the next question, where we can see that what is the rate of reaction for dinitrogen tetroxide? Dinitrogen tetroxide becoming 2 moles of nitrogen dioxide. For this reaction, in terms of nitrogen dioxide, we have to add half, but since the nitrogen dioxide is in the product side, the value should be plus. The value should be plus instead of minus. This one is not correct. Why? Because half should be present in front of it. Option B will be correct? No, because the sign would not be positive. And this is written in the correct way in option A. Now let's move on to the next question. The value of the rate constant K is for zero order reaction would be. So let's determine that R is proportional to K. Since it is a zero order reaction, the power above C would be 0. And so we will be saying that R will be equal to K. So the unit of K will be equal to the unit of rate, which is molar per second, that is mole per liter per second. Capital M here represents the mole per liter in short. What is the unit of rate constant for zero order reaction? We have already determined that, which is molar per second, that is mole per liter per time. In addition of solvent affects the reaction such as it decreases the energy. Actually, sometimes if you add proper solvent, it will certainly decrease the activation energy, hence the reaction will move forward or happen. Which of the following is mainly helpful in determining the activation energy required for a reaction? We have already solved that, which is temperature. Now let's come to a very important point, which is catalyst. For catalyst, I would like to mention you that for catalyst, what do you have to know? First, you have to know that the concept of catalysis was proposed by Berzelius. The concept of catalysis, that is, a substance will be in the reaction but will not participate in the reaction, but has the capability to influence the reaction. This is what we know about catalyst. You have to know that catalyst cannot initiate a reaction. You should utter this with me. Say it loudly. Catalyst do not initiate any reaction. Catalyst do not end any reaction. Rather, it just changes the route of a reaction. So it will be able to increase or decrease the activation energy according to their nature. But in most cases, catalyst lowers the activation energy, hence fastening the reaction or making the reaction faster. Now, according to the classification of catalyst, we will find that there are some positive catalysts, there are some negative catalysts, there are some auto catalysts, and there are some induced catalysts. Now, let's look at this question. This is asking already about the negative catalyst. So let's start with that. Negative catalysts can be recalled with these mnemonic pages. What are the pages? P for phosphoric acid, A for anisole, G for glycerin, which is the answer here, which is option B. Again, E for ethanol, S for sodium benzoate, and also sulfuric acid. So these are very important negative catalysts that can appear in your admission test. So try to remember the negative catalyst this way. Okay. Now let's come to positive catalyst. For positive catalyst, basically you do not have to memorize any mnemonic. Why? Because the number of positive catalysts is huge. Rather, we should know that it can be homogeneous in nature. I mean, all the state of catalyst and the reactant and products are same. In that situation, it is called homogeneous. The homogeneous catalyst work by forming intermediate compound. They catalyze the reaction by generating intermediate state, basically which attains the activation energy. But there is a possibility, or in fact which is more in terms of number, is heterogeneous type. It means here either reactant or product or the catalyst will be in different state than the other. So in this case, the method of catalyzing the reaction would be generating what? It would be by adsorption. And you should know that most of the catalysts are heterogeneous catalysts and they propel the reaction by adsorption technique. Now let's move forward to the next question, which is this one. As methane reacts with water, it is a catalyzed reaction generating carbon monoxide and CH2, which is a synthetic gas. Okay, let's. But before that, I should also mention about the auto and the induced one. Basically, auto catalysis happens in very small situation, very limited situation. I mean, for potassium permanganate, when the manganese ion generates, it catalyzes its own reaction. When a product itself make the reaction faster, then it is an example of autocatalysis. And for induced catalysis, it's like that you are trying to study, but you are unable to study properly because you do not have any concentration. But once I send someone to study in your room, then by looking at him or her, if you feel motivated to study, then what will happen? I mean, what has happened? It has happened that you got induced by him or her to study. Similar situation happens in case of chemical reactions. As we can see that sodium arsenite can be induced catalyst for reaction. Actually, I'm not mentioning the whole situation here. You already got my point that sodium arsenite can act as induced catalyst. If you can remember all these examples, then it will be easier for you to answer any question regarding the examples of catalyst. Now let's come back to this question, which is carbon. Methane is reacting with water to generate synthetic gas. This is called synthetic gas. This synthetic gas, now this is asking about which catalyst is used in this reaction. In this case, the option nickel is the correct one. Now I would like to mention you that you have to read the chart from Meditrix as well as the book, as well as Hadari book. You will find the chart of catalyst where you will find different process and the catalyst used in the process in a single table. And you have to memorize that for medical admission test. This question appeared from the chart. Which of the following is a catalyst poison? We have heard about catalysts. Now it's time to know about catalyst poison and catalyst promoter. There are some compounds which promote the catalyst, and there are some compounds which hinder the catalyst. So how will we be able to recall all the catalyst poisons? The catalyst poisons can be memorized with a mnemonic which is O, Sha, Dhu, Bab, Sha, E. Anyway, with Oshadhu Bab, Sha, E, what do we remember? First, arsenic. Arsenic is a catalyst poison. Sha, sulfur, which is in Bangla Gandhok. Sulfur is a catalyst poison. Dhu stands for dhulabali or sand, or also we can say dust particle. For Bab, Sha, E, we need to recall barium sulfate. So these are the 4 or 5 examples that you need to memorize about catalyst poison. So now let's move on to the. With arsenic, I meant a compound of arsenic, which is As2O3. Basically, arsenic with 3+ charge is very toxic. It acts as the catalyst poison here. So the option C is the correct one. Okay, let's move on to the next question, which is not a criterion of catalyst. Which is not a criterion of catalyst structure or total mass does not change after reaction. This is true. Catalyst can initiate or stop reaction. As I have mentioned at the very outset, that catalysts are not responsible for initiating or terminating the reaction. So the option B here is not a criteria of catalyst. In the next question, it is found that which catalyst is used to produce sulfuric acid through contact process. Let's make it clear. There are 2 processes mentioned in our book. One is contact process, another one is lead chamber process. You should know that the reaction that we are talking about is generation of sulfur trioxide from sulfur dioxide and oxygen. This reaction is a reversible reaction, and in this case, for contact process, the catalyst would be platinum or vanadium pentoxide. This contact process represents a heterogeneous form of catalysis because all the components here are gas, but the catalysts are at solid state. But in late chamber process, we find that catalyst as a catalyst, nitric oxide comes to play, which is also gas. That's why we find a homogeneous form of catalysis. So in this situation, late chamber process, nitric oxide is the catalyst, and for contact process, platinum or vanadium pentoxide is the catalyst. Since we have the option vanadium pentoxide here, we got the correct answer. In redox reaction of acidic potassium permanganate and oxalic acid, which works as autocatalyst, the compound that is responsible for working as autocatalyst would be manganese ion. So option B is the correct one. Which one is used as a catalyst in the industrial ammonia production by Haber-Bosch process? For Haber-Bosch process, we use iron as the catalyst and molybdenum and also aluminum oxide as catalyst promoter. What does the catalyst change in a chemical reaction? They only lowers the activation energy. Which is a catalyst for production of sulfuric acid? Certainly platinum by contact process. Oxalic acid is reacting with sulfuric acid, potassium permanganate to generate manganese sulfate, carbon dioxide, and water. Here the manganese. Once you get the manganese, you should say that this is an autocatalyst. But if it is asked about potassium permanganate, if you ask that potassium permanganate is a what? It is not a catalyst. This is basically a positive catalyst. A positive catalyst here. Okay. Anyway, let's move on to the next question. Which of the following acts as a negative catalyst of a toxic phosgene gas production in the oxidation of chloroform? Basically, it is a preservation technique. If we keep the chloroform in a opaque, in a transparent bottle, then there is a possibility to contamination. And for this reason, we just try to preserve this chloroform in a bottle which is not a transparent one, rather it is a brown colored opaque one. And in that case, to be safe about the contamination or to keep it safe, we just add 1% ethanol in the solution. So as we can see, the option B, alcohol, is there. The correct answer will be basically ethanol, which acts as a negative catalyst to slow down the process of phosgene gas formation that usually happens when the preservation of chloroform goes wrong. Which is homogeneous catalysis? For homogeneous catalysis, we have already mentioned that the states of product, reactant, and the catalyst should be same. In this case, option A is revealing that what we have already said. It is the late chamber process and example of homogeneous catalysis. Hydrogen peroxide is dissipating or dissociating into water and oxygen. Which one acts as a negative catalyst? So the negative catalyst here would be glycerin, manganese dioxide, vanadium pentoxide, platinum. These are celebrity positive catalysts. So the option B. How did we remember glycerin? With the mnemonic. What was that? Pages. Go to previous slide if you already forgot what is pages. Which metal is used as catalyst promoter in making ammonia? For catalyst promoter or promotion, we provide molybdenum. Which is used as negative catalyst? We are being asked about the negative catalyst during food and seed storage. During food and seed preservation or storage, we usually use sodium benzoate. Sodium benzoate is a classic food preservative. Anyway, let's move on to the next question, which is homogeneous catalysis. For homogeneous nature, all of the reactants should be same, which is B. Reactant product and the catalyst should be in the same state. Which factor can change the activation energy of a reaction? Certainly catalyst. Potassium chlorate. In presence of manganese oxide becomes potassium chloride and 3 moles of oxygen. Here we found manganese oxide, not manganese ion. Manganese oxide here would certainly act as a positive catalyst, not an auto one. Which reacts as an autocatalyst in a chemical reaction? Basically, potassium permanganate is not the correct answer. Though it is mentioned as the correct answer in the book, the answer should be manganese ion. But potassium permanganate itself is a positive catalyst. But the manganese ion generated from potassium permanganate would act as an autocatalyst. Anyway, since there is no other option as manganese, we have nothing but to mark this one as correct. Which act as a catalyst in the production of methanol industry? In production of methanol industry, we usually use the zinc oxide or chromic oxide. The next question, we are saying that during the preparation of oxygen gas from potassium chloride, which one acts as a positive catalyst? Basically, the answer will be here, option D, manganese oxide, as we have seen the reaction earlier. See, this is the question that we are talking about. To generate oxygen in laboratory, we need to use the manganese oxide. But the option here, in book, you may find phosphoric acid as the answer, but this will not be the case here. The correct answer will be option D. Let's move on to the next topic, which is biocatalyst or enzyme. Regarding biocatalyst or enzyme, only the most latest admission test that carries the question from this topic is 16 to 17 session, which is also long ago. Now, as we can see, that sucrose, we are basically observing the hydrolysis of sucrose, right? The hydrolysis of sucrose can be done in presence of mineral acid. So the option would be C. And this is a form of heterogeneous? No, this is a form of homogeneous catalysis because all of them are in solutions or liquid state. Which is that? This is a urea. Urea is reacting with water to generate ammonia and carbon dioxide. And in this case, the option urea will be the correct. Which one is not related with the appropriate function of enzyme? Appropriate function of enzyme is dependent both on temperature and pH, but it is not dependent on pressure. Also, enzymes are secreted in our body time to time, and it functions in a shorter span of time. That's why we can see that our hunger doesn't stay for a whole day if we do not eat. It goes away after a certain time because the enzyme is washed away, or it stops irritating our stomach. Non-living amorphous complex organic compound containing nitrogen secreted from yeast is called enzyme. What are the enzymes that comes from yeast? The enzymes that come from yeast can be remembered using this easy mnemonic, which is JAMAI. What does it mean? What do they mean? First, Ja for James, A for Imes, not this is not A. This is malt, M for maltase, and lastly E for invertase. Anyway, let's move on to the next question. Ethanol is produced from glucose under the influence of which enzyme present in yeast? Basically, glucose is a substrate of James. Glucose is a substrate of James. How do I remember this? I remember this in this way. There is G, there is Z. You have to remember that Z for G, G for Z. Okay, glucose, so Zymes. Ethanol is produced from glucose under the influence of Zymes. So with this, all the questions are solved. Now you have to practice a lot about the questions from the order, and I assure you that the mathematical problems that are related to order, those which are not possible to calculate without any calculator, should be avoided, because wasting on that would not be the better choice at this very moment. Anyway, you have to practice a lot to find out more time to give in the potential hard questions in the admission tests. Anyway, best of luck, all the best. Assalamu alaikum, dear students. Hopefully, all of you are in good health, I mean, mentally and physically okay, to join this class. I welcome you all today in our today's medical chemistry first paper masterclass, where we will be enjoying the lecture 2 of chemical change, a very vital chapter. If you ask me that what chapter did you prefer or did you like most in chemistry second paper, then I would say in chemistry first paper, then I would say that chemical change. In our time, it was named as chemical kinetics, but the overall topic or concept are similar to what present now. So today we're going to discuss about chemical equilibrium and Le principle. This is very crucial and easy to answer if you grasp the concept. And the next one is law of mass action and equilibrium constant of reaction. Regarding equilibrium constant of reaction, we will find some mathematical problems, but we would only solve some basic ones which will not require any calculator. And some advanced one will be solving in the mathematical portion or mathematical lecture, which will encompass all the mathematical problems of this chapter. Anyway, let's start with the first topic, which is chemical equilibrium and Le principle. In this case, I would like to mention you that regarding Le principle, question appears like this. By increasing temperature, what will be the amount of product? By decreasing temperature, what will be the direction of the reaction? So you need to have the idea how the balance gets restored once the factors influencing the equilibrium gets changed. This is what we call the Le principle. And as we can see, latest admission test which carries the questions from this topic is 2021 to 22 session. Anyway, since it appeared in the recent ones, so we can ignore this topic. Okay, let's start solving the questions. Our first question is on which reaction below there is no effect of pressure at equilibrium? First of all, no effect of pressure will be there if the mole number of reactant and the mole number of product become same. So I should write it this way: if the mole number of reactant is equal to the mole number of product, then the pressure will have no effect at equilibrium. Now, as we can see in our first reaction, the mole number of the reactant and the product is same. So in this case, there would be no effect of pressure. What is the effect of pressure actually? If I write it down, if NR becomes more than NP, I mean for NR and NP, you should consider only gaseous molecules. Only gaseous molecules. No other molecules would be under consideration regarding the effect of pressure at equilibrium. So if this is the case, then for forward reaction, what do you have to do? You have to see the reactant gets decreased, so the pressure will get decreased. So the pressure will get decreased. So in this case, you need to pressurize the environment to fasten the reaction process or to make it to propel it towards the forward direction. So the opposite, if I write down this way, if NP is greater than NR, then what will be the case? Here, for similar for forward reaction, we will recommend lowering the pressure. But you have to remember that all of them is applicable only for the gaseous molecules. Okay, let's move on to the next question. What will be the direction of equilibrium with increasing concentration of reactant at constant temperature? Increasing concentration of reactant would certainly propel the reaction towards the right. Right direction means it will move forward. You should know that. What does to the right mean? To the right means forward reaction. Also, you should know that the product will increase. And also, you should know that rate constant will increase. But there is a twist. If it is due to temperature change, I mean, if the reaction is moving forward because of change in the temperature, then the rate constant will also increase. But if it is moving towards the right direction or the forward direction because of the concentration change or pressure change, then the rate constant will not be applicable. Rate constant means I meant equilibrium constant. Equilibrium constant is only dependent on temperature. Equilibrium constant only dependent on temperature. Nothing else can influence this factor. Anyway, let's move on to the next question. How many moles of ethyl ethanoate is produced in the reaction between 1 mole ethanoic acid and 1 mole ethanol? So this is a ethanoic acid. It reacts with 1 mole ethanol. Since it is an acid, it is an alcohol, it will generate an ester, which is CH3COO C2H5 along with water. Anyway, this is the case here. So in equilibrium, you should know that 0.333 mole. Basically 0.333 mole reactant reacts with 0.33 mole ethanol to become 0.667 mole ethyl ethanoate. So the question is how many moles of ethyl ethanoate is produced in the reaction between 1 mole ethanoic acid and 1 mole ethanol. So at equilibrium, if I say that at equilibrium, the situation will be like this. Before starting equilibrium, we got 1 mole of ethanoic acid and 1 mole of ethanol. But in case of equilibrium, we will find that the 0.667 mole has already gone. 0.667 mole has already gone to generate this 0.667 mole ethyl ethanoate. The residual 0.33 mole is available here. So what will be the answer here? The answer will be D. Next question, which one is not a characteristic of chemical equilibrium? Chemical equilibrium has some basic features, or you must say that some mandatory property to call it an equilibrium. First of all, this is a stable one. So as we are searching for knot, we will find all the properties over here. Like this is stable. I mean, stability of equilibrium is its property. Easy approachability from both sides. So forward and backward, in both way we can approach equilibrium. Rate of reaction. Basically, rate of reaction is not a factor here. Reaction rate can be fast or slow. Rate of reaction is not important. Rather, direction of a reaction. Direction of reaction. Basically, direction of reaction is not important. Another feature that we should inform here, which is no role of catalyst. No role of catalyst. Catalyst play no role in equilibrium. Lastly, the incompleteness of reaction. Since equilibrium is only applicable for the reversible reaction, so the reaction will be incomplete. Let's move on to the next question. Here we can see this is an endothermic reaction. Since the temperature enthalpy change is presented in positive way, so it is endothermic reaction. For endothermic reaction, what is the condition for maximum production? Okay, now there is two factors here. One is high temperature, and one is temperature and one is pressure. For pressure, we may have to consider all of them as gas because no such state is mentioned here that it is solid or liquid. So let's consider all of them as gas. So we can see that in this case, the mole number of reactant is more than the mole number of product. In this situation, as the mole number of reactant is more, so you need to decrease the pressure. Is it? As you can see, the pressure gets lowered in the product side. So you have to increase the pressure to get better outcome or better amount of product. So you have to increase the product. You have to increase the pressure side. Increase the pressure to get more product. Again, as it is an endothermic reaction, we have to increase the temperature as well to get more product. So what will be the case here? High temperature and high pressure to get the maximum production. Now this question is asking that what change will be seen here if temperature increases. Look at this question very carefully. Many of you may mistake or may make mistake here. How? Someone may forget to look at this. They may consider this reaction as endothermic one, but this is not the case here. As you are watching that this is written as a positive number in the product side. If there is no such thing called delta H, then it represents that it is generating heat. So this is an exothermic reaction, not an endothermic one. This is an exothermic reaction. This is an exothermic reaction. Now for this exothermic reaction to take place, I mean, what kind of temperature change should we seek to get better product? Here, as you can see, this is exothermic reaction. If you increase the temperature, that means you are going towards the same direction as that reaction is going. So the reaction will go backward. You decrease the temperature, right? So the reaction will go backward means sulfur dioxide production will be decreased. The answer will be A. Next, which of the following reaction shows no effect on pressure change in equilibrium? No effect on pressure change will be there for any molecules that are not gas. Let's see. Here, aqueous. Since all of them are in aqueous form, they have no role. Pressure have no role over here. So the option B is the correct one. Let's move on to the next question. Nitrogen is reacting with oxygen to generate nitric oxide, and this is an endothermic reaction. There is delta H and there is no sign. That means it is positive. If temperature is increased, as we know, for endothermic reaction, you have to raise the temperature to propel it towards the forward direction. I mean, to generate more product. So in this case, the reaction will move, or the equilibrium will shift towards the right direction. What does it mean by equilibrium at the extreme right? Equilibrium at the extreme right means the reaction is almost complete. If I say that the equilibrium is at the very left side, or at the terminal left side, then it would say that the reaction has not started properly. Anyway, let's move on to the next question. If ammonia is made liquid by exerting high pressure in the following direction, in which direction will the equilibrium point shift? Let's see. There are 4 moles. There are 2 moles. So in the product side, the pressure gets decreased. So if you increase the pressure, then more products will be generated to reduce the pressure. Whatever the reaction does, if you do the same, then it will happen. It will move backward. But if you do the opposite, it will move forward. The reaction lowers the pressure, so you are increasing the pressure. So in that case, you are trying to push its limit to move faster. That's how the equilibrium point will be shifting towards the right direction. So the answer will be C. If concentration of D is increased, where will equilibrium shift in case of the following? If the concentration D is increased, since it is in aqueous state, it is not in solid state, it would have role in equilibrium. If you are increasing reactants product size concentration, then it will move the reaction towards backward direction. So in this case, it will be left side. What is the effect of pressure in the following reversible reaction? There is only 1 mole gas in the reactant side and 1 mole gas in the product side. The mole numbers of reactant and product side is equal, so there will be no effect of pressure. What is the effect of increasing temperature and pressure in equilibrium for the following reaction? Let's see. There are 3 moles of gas. 3 moles of gas. And now we are getting again 3 moles of gas. So there will be no effect of pressure. Again, the enthalpy is negative, which represents that this reaction is exothermic. So if we increase the temperature in an exothermic reaction, the reaction will move backward. So in this case, it will be leftward. Leftward will be the answer. Increasing the pressure will not bring any change here. Only the temperature range will propel the reaction backward. Anyway, let's move on to the next question. What is the optimum pressure in contact process? Contact process means this is the reaction where sulfur dioxide reacts with oxygen to generate 2 moles of sulfur trioxide. This is the contact process where we use normally platinum or vanadium pentoxide as catalyst. In this situation, as you can see, 3 mole gas become 2 mole. Certainly, if you increase pressure, then the reaction will move forward. But fortunately, you do not need a huge amount of pressure to propel this reaction in the forward direction. Only 2 atmosphere pressure. Only in fact 1.7 atmosphere pressure is enough to get highest amount of production. So optimum pressure for this reaction would be 1.7 atmosphere, which is near about 2 atmosphere. That's why the answer here will be A. Okay, let's move on to the next question. Which one is the characteristic of chemical equilibrium? As we know, it does not complete. So in case of incompleteness, it would be incompleteness. Instead of approachability from one side, it will be both sides. Necessity of catalyst, it will be no role of catalyst. Lastly, stability of equilibrium is the thing, or is the concept that is correct, which is option D. Next question is mentioned, is telling us that what effect will increasing temperature have on the production of sulfur trioxide in the following reaction? I mean, the reaction that we have discussed in earlier question, which is contact process. Here, as you can see, this is an exothermic reaction. For an exothermic reaction, increasing temperature will shift the reaction backward or leftward. So the production of sulfur trioxide will decrease. Let's move on to the next question. Dissociation of dinitrogen tetroxide into 2 moles of nitrogen dioxide. Here, the mole number of gas gets increased, right? Mole number of gas is mole number of the product. Mole number of the product side gets increased. So here, pressure is getting increased. In this case, if you increase the pressure, the reaction will move backward. But if you decrease the pressure, the reaction will go forward. Now, the question is about if pressure is applied to this reaction, what will be the case of equilibrium? The equilibrium or the reaction will shift backward to ameliorate or to balance the effect, counterbalance the effect of pressure. Now, as you can see, a solid compound is becoming gas. 5 moles of gas. If the concentration of C is doubled, this is an interesting question. If the concentration of C in equilibrium is doubled, then the concentration is doubled. Then the concentration of B in the new equilibrium in terms of the first equilibrium will be what? Okay. Now let's say that here, as we can see, that the rate of the reaction will be equal to K. Or if we determine the rate constant, actually, it would be like this. That Kc will be equal to, for the first reaction, Kc will be equal to B into C to the power 4 divided by A. Right? This is the first rate constant or the equilibrium constant for the first equilibrium. Next again, Kc2. In this case, the concentration of C gets doubled. So we have B, we have 2C, we have the power, and same as A. Now, you can easily write this in this way, like B into C to the power 4 divided by molar concentration of A into 2 to the power 2 means 4 to the power 2, 8 to the power 2, 16. Not 8 to the power 2, it's actually 8 times 2, which is 16. So this component is basically the equilibrium constant of the first equilibrium. So it will be 16 times more than the first equilibrium. So will it be, the question is, in terms of first equilibrium, will it be 1 by 16 times or 16 times? Basically, if you multiply 1 by 16 with Kc2, then you will get Kc1. So this one is the correct one. Which one of the following is an example of homogeneous and ionic equilibrium? Homogeneous and ionic equilibrium would be B, because here all of them are in aqueous state and similar state. Which reaction is an example of heterogeneous chemical equilibrium? For heterogeneous chemical equilibrium, one of the product or reactant should be at different state, which is option C. If the concentration of one or more reactant is increased, here we are increasing the concentration. If we increase the concentration, in which direction does the displacement of equilibrium will take place? It will move towards the forward direction. Methane combustion reaction, if the pressure is increased. Here, as you can see, the number of gaseous molecule here is 3 mole, and the number of gas generated in the product side is 1 mole, which means the gas molecule gets decreased, so the pressure gets decreased. Now if you increase the pressure in this reaction, pressure gets decreased. So if you increase the pressure, then the reaction will move towards the forward direction, which is right side. So the correct answer here will be option B. Now the amount of A3B at equilibrium for this reaction depends on what? Again, you can see the number of moles in the reactant side and the product side is not equal, so pressure will certainly play a role. Moreover, this is not an exothermic, this is a reaction that will certainly be exothermic or endothermic. So in this case, temperature and pressure both will play a role. The answer here would be A. Again, have a look at this question. As we can see in the equilibrium reaction, 2A plus B reacting to produce 3C plus B. Now they are mentioning that if I take 2 moles of A and 2 moles of B together, what will be the case in case of this reaction? As I've already marked the answer, which is option C, because here, as you can see, 2 moles of A is reacting with 1 moles of B, right? So if you take 2 moles each, then certainly after reacting 1 mole B will remain extra. So in this case, at equilibrium, this 2A will get washed out, reacting with 1 mole B, and only 1 mole B will be there, which is why A will be less than B. Okay, at equilibrium it will be 0, but at equilibrium 1 mole B will remain, as it is not going to participate in the reaction. Next question: which of the following is the condition for the occurrence of exothermic reaction? In case of exothermic reaction, you should know that to form a bond formation releases energy like this, like an explosion. Okay, bond formation release energy. On the opposite direction, we say bond breaking requires energy. Bond breaking absorbs energy. So energy released in forming bond should be greater to make the reaction exothermic. This is written in the option D, which is energy released in making bond or forming bond is more than energy absorbed in breaking the bond. Now, when a system is in equilibrium, if a factor of that state, such as temperature, pressure, basically what is this principle? This is Lars-Ulrich principle. For the reaction, that is 2 moles of hydrogen iodide is becoming 1 mole hydrogen and 1 mole iodine. The delta H is minus 52 kilojoule per mole, which is an exothermic reaction. Under what condition will the reaction equilibrium shift to the right? In this case, there will be no effect of pressure, only change in temperature. Reducing the temperature will propel the reaction to the forward direction. As it is asking about the right side shifting of the equilibrium, so we should decrease the temperature. So the option reducing pressure, adding at least nothing will be okay. This one is the correct answer, option D. Which of the following reaction will produce more product at low pressure? For more product at low pressure, you need to see or you need to have a reaction in which the product side, in the product side, the pressure gets increased. As you can see in the option B, we got 2 moles in the product side and 1 mole in the reactant side. Certainly, this is a reaction where pressure gets increased. So in this case, lowering the pressure would result into, I would say, more production. The answer will be B. If an exothermic reaction is cooled down, in which direction does the equilibrium shift? Exothermic reaction is cooled down, so the equilibrium will shift towards the right direction, that is forward. PCl5 is dissociated to phosphorus trichloride and chlorine. This is an endothermic reaction. What will be the change in equilibrium if the temperature of this reaction is reduced? This is an endothermic reaction, so it is a cool reaction. If you cool it more, then it will go backward. Dinitrogen tetroxide dissociates to form nitrogen dioxide. What will happen if the pressure is increased in the system? You should know that this dissociation looks like this. 2 moles of nitrogen dioxide generates from 1 mole of nitrogen tetroxide. So in this case, pressure gets increased. So if you increase more pressure, then it will move backward. The dissociation rate will decrease. What happens when heat is applied at equilibrium in an endothermic reaction? In an endothermic reaction, if heat is applied, the reaction will move forward. Now, let's have a look at the law of mass action and equilibrium constant of reaction. As we all know, Goldberg and P-Vage generated this law of mass action. It basically states that the rate is dependent on the active masses of the reactants and products. By active mass, we mean the concentration or the partial pressure. In case of liquids, we prefer the term concentration, but in case of gas, we prefer the term partial pressure. Anyway, this question is asking about which one is not applicable to equilibrium constant. Equilibrium constant, applicable to only reversible reaction. This is true. Changes with temperature change is very important. This is also true. Does not change with pressure change. This is also true. So last option should be the correct one because it is saying the wrong information, that is not applicable to equilibrium constant. Provides idea about the speed of reaction. No? A plus B reacts to form 3D. What is the relation between Kp and Kc here? The mole number comes to play here. As you can see, the number of mole in the product side here is 3, and the number of mole in the reactant side here will be 2. So delta N will be equal to 1. So Kp, we know that Kp equal to Kc RT to the power delta N. Since the delta N value is equal to 1, so we can say Kp equal to Kc RT, which is option C. As we can see, that Haber-Bosch process, this is not actually Haber-Bosch process, this is the ammonia production. What is the relation between Kp and Kc? Again, we need to figure out the delta N. As there is 2 and there is 4, so the delta N will be -2. So -2 in this case, option C will be the correct answer. Calcium carbonate dissociates into calcium oxide and carbon dioxide. What is the equation of Kc here? Here, the one important thing you should know that if a concentration is, if one of the reactant or product is solid, then their concentration would play no role in equilibrium. So we can easily avoid the concentration of calcium carbonate and concentration of calcium oxide out of the equation. So in this case, the only applicable thing would be partial pressure of carbon dioxide, which can also be stated in this way. So the correct answer would be C. This is the phosgene gas which will liberate to form, dissociate to form carbon monoxide and chlorine. What is the unit of Kp here? Basically, you should know that there is no unit of Kp. In fact, if there is an option such as no unit here, as you can see, there is an option which is no unit. So you should mark it. But there will be some question. In fact, there are some questions in different writers exercise that what is the equilibrium, what is the unit of Kp Kc here? And no unit is not available as an option there. In that case, you have to figure out the delta N. In fact, you should fix it this way. Basically, if you figure out delta N, and you should mention the partial pressure as atmosphere and the concentration as mole per liter to generate the unit. But if there is an option such as this one, no unit, then you should mark that. Which regulator affects both reaction equilibrium constant and reaction rate constant? Both of them are regulated by temperature only. So the answer will be C. D, option B. In which of the following reaction will Kp and Kc be equal? Kp and Kc will be equal if the NP will be equal to NR. Product and reactant molecules are same in mole number. So the answer will be D. The next question, as we can see, what is the relation of Kp and Kc in this reaction? In this reaction, option B is correct. Why? Because this is basically similar to the ammonia production reaction. What is the equation of Kc here? As we have solved already, this is C. Which has effect on equilibrium constant? Temperature has effect on equilibrium constant. If in this case, see, there is an option that is no unit. So this is the case. If unit of concentration is mole per liter, then what will be the unit of Kc? Again, it is mentioned that this is what kind of reaction. You should know that this is a if a unit of concentration is mole per liter, then what will be the unit of Kc? As there is no unit option is there. None is not available as an option. In this case, we have to do this way. Mole per liter to the power delta N here. The delta N would be equal to 2 minus 4, which is -2. So it will be mole inverse 2 liter square. So the answer will be C. Who gave the law of mass action? The law of mass action was proposed by Goldberg and P-Vage. Phosphorus pentachloride dissociation. Here, unit of Kp at equilibrium would be what? In unit of Kp, first of all, unit of Kp at equilibrium. You should try to mark no unit as the answer, but as there is no option as no unit, so you have to answer this way, like Newton per meter square. This is the unit of pressure, and you have to write down the delta N, which is 2 minus 1. So it is 1. So basically, the answer will be Newton per meter. Sorry, Newton not per meter, Newton per meter square. The unit of pressure is Newton per meter square. So the option C is the correct one. Let's move on to the next question. What will be the unit of Kp here? Similarly, the option A will be the answer, but no unit is the preferred option if it is available. Which of the following reaction has a unit of atmosphere square of Kp? To get such value, the delta N should be 2. In this case, the delta N. Let's find out all the delta n's. This is 0. In this case, the delta n will be equal to minus 2. In this case, the delta n will be equal to plus 2. And in this case, the delta n will be equal to 5 minus 2. That is plus 3. Not 5, sorry. This one is 3. This one is 4 from 2. So it will be 2. Plus 2, right? This is a gas. This is a gas. There are 4 molecules of gas and there are 2 molecules of gas. So 4 minus 2 will be equal to plus 2. 4 minus 2 will be equal to plus 2. So in this case, basically option C and D, both of them are correct. Option C and D, both of them are correct. Okay. Let's move on to the next question. In which reaction of the following Kp equal to Kc? Kp will be equal to Kc where the mole number of product and reactant sites are equal. In this case, unit of Kp will be equal to atmosphere inverse to Y because delta n equal to minus 2. In this case, as you can see, the rate constant of forward reaction is K1, rate constant of backward reaction is K2. So what will be Kc? Kc will be equal to K1 by K2, which is K1 dot K2 inverse 1. For which reaction of the following Kp equal to Kc? You have to have equality in the mole numbers in between product and reactant site. For which change does the value of equilibrium constant change? It is only dependent on temperature. No other factors can influence the equilibrium constant. In which case does the reaction go in the right direction? Okay, let me clarify this. Qc is a quotient at any temperature or at any situation, but Kc is the quotient that you obtain during equilibrium. Since all the reactions' main goal is to attain equilibrium, so we always try to keep the Qc at lower level than Kc because at that moment only forward reaction will take place to propel the reactant towards the equilibrium. In this case, in which case does the reaction go in the right direction? To propel the reaction towards the right direction, you need to keep Qc lower than Kc. So the answer would be A. If Qc is much less than Kc, then the reaction didn't start. Reaction not started. If it is like this, that Qc is more than Kc, reaction will go backward, go forward. Okay. For which reaction Kc equal to Kp RT? So here delta n should be equal to 1. In this case, 2 minus 3, we get minus 1. So this will not be the answer. Here, as we can see, 2 minus 1 equal to 1. So option B is the correct here. Here, option B is the correct one. Why? Because the delta n value, here the delta n value will be equal to 2 minus 3, that is minus 1. Here we get, again, wait, we should not rush this way. Why? Because here it is written intentionally in the opposite way. Normally we find Kp equal to Kc RT delta n, but here it is written that for which reaction Kc equal to Kp RT delta n. So Kc equal to Kp RT delta n. Here the delta n should be minus 1. Here the delta n should be minus 1 to become such. Okay. When Kc will be equal to Kp, just focus. I mean, in this case, for this case, if I write this way, like Kp is equal to Kc RT delta n will be equal to minus 1. If it is the case, we can write in this way that Kc will be equal to Kp RT as mentioned in the question. So the delta n value should be minus 1, and the delta n value minus 1 will be for the option A. So option A is the correct one. Here delta n value is minus 1. Here delta n value will be plus 1. Again here delta n value would be plus 1. Here delta n value would be plus 1. So the answer would be A. Kp equal to Kc for which of the following reaction? For Kp equal to Kc, the reactant and product side molecules or moles will be equal, which is the case for option A. In this reaction, the equilibrium constant in the reaction changes when? If we increase the pressure, it will move in the forward direction. Why? Because the pressure gets decreased in the product side. So increasing pressure, there will actually, it is asking about the equilibrium constant, not about the equilibrium. Equilibrium constant is only dependent on temperature. So if we increase or decrease in temperature, then the equilibrium constant will change. So option D is the correct one. In which of the following reaction Kp is greater than Kc? To get higher value in Kp, I mean, as we have mentioned, Kp equal to Kc RT delta n. So delta n should be positive to get a higher value of Kp. So delta n positive in which case? In the case where product, the mole number of product is more. So as we can see, option A, here the product and reactants are in equal number. Here the number of product is less. Here the number of product is more. So option C is the correct one. Which equation is correct if A is the equilibrium constant of x plus y equal to z and B is the equilibrium constant of z? I mean, if it is the same, as we can, if this is the forward reaction, this is the backward reaction, and this is like K1 and this is like K2. So what should be the correct? Actually, here this constant is the inverse form of that constant. So the answer will be B inverse 1 will be equal to A. Okay. Now let's move to the next question. What is the correct unit of equilibrium constant of Kc? Basically, we do not have any unit of Kc, but as we can see, there are 5 moles, there are 3 moles, so we should go for this technique, which is mole per liter to the power delta n, which is here mole per liter to the power 2. 5 minus 3, 2. So mole square liter inverse 2, which is option B. In this question, which condition when imposed on the given reaction will affect the value of the equilibrium constant? Equilibrium constant can get changed with only influence from temperature. So the answer will be C. You should know that the effect of temperature in equilibrium constant is described by Van't Hoff equation. Van't Hoff equation. We do have 2 equations regarding temperature. One is Arrhenius and another one is Van't Hoff equation. Van't Hoff equation describes the effect of temperature on equilibrium constant. On the other hand, Arrhenius equation describes the effect of temperature on rate of reaction. These two are different variables. The values of Kp and Kc will be equal when the value of delta n of the reaction will be 0. Let's move on to the next question. For which one of the following equation the value of Kp and Kc are not equal? Kp and Kc will not be equal if the Np and Nr is not equal, which is option D. In this case, the value of Kc in the reaction will be C plus, and the product side will be at the top. So in this case, the option D, no, the option basically here, the option D will be the correct one, not D. This is according to the law of mass action. In this case, as we can see, iron is reacting with steam to generate ferric oxide and hydrogen gas. What is the relation of Kp and Kc in this reaction? As you can see, there is 4 moles of gas and 4 moles of gas there. So the Kp and Kc will be equal, which is C. What influences the value of equilibrium constant of Kp and Kc in chemical reaction? I mean, equilibrium constant is only dependent on temperature. In this reaction, what is the value of Kc? The value of Kc is only dependent here on carbon dioxide and oxygen. Carbon plays no role here, so the answer would be option B. In this case, value of Kp in the reaction. Again, we have to determine the delta n. Here delta n equal to minus 1. No, actually here we got 1 mole. Delta n value will be minus 2. For minus 2, Kp will be equal to Kc RT minus 2, which is option B. Now, degree of dissociation of weak acid. Degree of dissociation of weak acid will be root over Ka by C, which is Ostwald dilution principle. Ostwald dilution principle. Ostwald dilution principle. Ostwald's law applies to what? Ostwald's law applies to solution of weak acid or base. because it states that the more the weak acid or weak electrolytes become less in concentration, the more the dissociation gets increased. With this, the questions about equilibrium and Lasher-Taylor principle are finished, but I should say or warn you that apart from this, I mean the exercise portion, there are plenty of opportunities to generate questions from the Lasher-Taylor principle. You should be very careful about two facts. Equilibrium constant is only dependent on temperature, and when you are considering the concentration of solid, you should consider them as zero. I mean, these are not important or these are not applicable for determining Kc. Anyways, if you practice more, then your accuracy will be more. That's my advice, and keep practicing. Best of luck. Assalamu alaikum, dear students. Hopefully, all of you are okay and all right. I welcome you all today in our today's masterclass, where we will going to be solving questions from chapter 4, chemical change, and the lecture will be lecture 5. What will be discussed or what will be solved in this lecture? Two important topics. These are conservation, law of energy and mass, and different types of heat changes. Basically, for admission test, this different type of heat change is crucial for medical admission test. And thermochemical law, though we have solved plenty of mathematical problems for HSC exam, but in medical admission test, mathematical problems about thermochemical law is not that much common. Normally, no such question with bigger reactions ever appeared in our admission test. So I think you have to focus on the different types of heat changes from our today's class. Besides, I will be solving the exercise questions which are possible with the calculator and also which has the potential to appear in the medical admission test. Okay, let's start. Before starting, I have to remind you that in the dental admission test as well as medical admission test, we have found questions from this topic in recent years. Anyway, our first question is asking which process is exothermic. Okay, now I'm going to give you a mnemonic to remember all the heat changes which are exothermic. Which are exothermic? Exothermic heat changes. Exothermic heat changes are, first I write down all of them on the by remembering them according to the mnemonic. The first one will be heat of condensation. The first one will be heat of condensation. 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 Next one will be heat of neutralization. Neutralization. Again, another one can be heat of combustion. Another one can be heat of formation. Heat of formation. So we get condensation, neutralization, combustion, and heat of formation. Besides, two entity can be called exothermic, which are lattice enthalpy and electron affinity. These are also exothermic, but these are not connected or related to the heat changes that we are talking about. Somebody would say, why not heat of solution? Because heat of solution can either be positive or negative. Two such heat are there, which can be exothermic as well as endothermic. These are heat of reaction. I mean, all those discussed here are heat of reaction. So heat of reactions can be exothermic and can be endothermic as well. And also heat of solution. Heat of solution can also be exothermic and endothermic. This too has the potential to become delta H, can be both positive and negative. But for all of these reactions, delta H will be negative. That means rest of the heat changes will be positive, that is endothermic. Now, how will we remember all this? How will we remember all this? The easier approach would go for Bangla mnemonic. The Bangla mnemonic by which I have remembered this is Ghono Doi Shongla. How am I connecting this information with this Ghono Doi Shongla? Let's look at it. Here, as we can see, Ghono means Khoni Bhavan. Khoni Bhavan is the in Bangla of condensation. So with Ghono, we will remember Khoni Bhavan, which is condensation. With Do, I meant Dohon, which is combustion. Again, we can recollect with the letter C. We got 2C, which is Khoni Bhavan and Dohon in Bangla, and in English, condensation and combustion. And now comes E. This E is responsible for electron affinity. And also La is responsible for the lattice energy. And now the Shong in Bangla represents Shongoton, which is heat of formation. Heat of formation. Heat of formation. Lastly, Po with Po, we mean Proshomon in Bangla, which is heat of neutralization. Okay. So with CNF, exothermic. With CNF or C2NF, we can recall all the exothermic reactions. And also, if possible, this Bangla mnemonic is very handy, very useful. If you can remember all this, then it will be easier to determine which one is exothermic. Since the question is asking which one is exothermic, now we will try to find out if there is any option among these options. As we can see, evaporation is not included here, so it will certainly show delta H in positive direction. Also, bond dissociation is opposite to bond formation, which will be endothermic. Fusion is opposite to combustion also. So in this case, it will be positive as well. But last, we can see that condensation, which is in fact the opposite of fusion, this condensation is included here, which will show delta H in negative value. That means condensation is the exothermic process. The next question is asking which one is an endothermic reaction. Okay, now let's find out what type of reactions are those. In the first option, we got combustion. So combustion reaction will be exothermic. Again, this option, if we see, someone will consider that this is heat of formation of nitric oxide, but I would assure that this is an exothermic. This is not an exothermic reaction, rather this is an endothermic reaction with a delta H value of 1.86 kJ per mole. This is an exceptional reaction that needs to be memorized by all of you, because this nitrogen and oxygen binding to form nitric oxide is an exceptional example where heat of formation does not become delta H negative. Here, heat of formation becomes positive. That is, this is an endothermic process. Rest of the options are exothermic. Okay, in the neutralization reaction of a strong acid and base, the amount of heat produced by each mole of water for a strong acid and strong base, 1 mole of hydrogen ion reacting with 1 mole of hydroxyl ion generating 1 mole of water would result into similar heat, and that is 57.34 kJ. We have already read the explanation of this value because we have already answered such questions in our HSC exam preparation, during our HSC exam preparation. That is, the heat of neutralization of strong acid and strong base is constant, which is 57.34 kJ. For this, I have to mention that please read the charts of acid, base, chart of heat of neutralization from the book. Why? Because heat of neutralization chart would show you the difference in heat of neutralization when acid and base strength varies. When you react weaker acid with stronger base, then the heat of neutralization goes up. Similarly, if you react both weak acid and weak base, then the heat of neutralization will go down. Anyway, let's move on to the next question. What is the heat of fusion of water? This is something that you have to memorize. There is no other way but to memorize this. What is the heat of fusion of water? It is actually plus 6 kJ per mole. If it is asked in the opposite direction, like what is the heat of condensation of water, it would have been minus 6 kJ per mole. Anyway, two dilute solution of two different salts are kept together, but no reaction took place in between them. Which one of the following is correct? If there is no reaction between them, then there would be no change in temperature. And also, I mean, that is the option here, which is correct. Which of the following temperature is needed for the following reaction to occur? Here, calcium carbonate is dissociated to form calcium oxide and carbon dioxide, and it is a classical question where the temperature is almost known to all, that is 550 degrees Celsius. Which of the following values is always negative? We have studied already from the Conjugation formula for C square NF. With C, we remember heat of combustion. So A will be the correct answer. Heat of reaction can either be positive or negative, and heat of formation can always be negative, but there is a twist. There is an exception. Which exception was there? What is that? Formation of nitric oxide formation from nitrogen and oxygen, right? This was an exception. That's why this is not the better answer. The better answer is A, because any combustion reaction will be exothermic in nature. Which of the following is exothermic? Again, I need to find out which one is condensation, because condensation is the exothermic one. Condensation means when liquid becomes solid. Condensation means when gas becomes liquid, right? When gas becomes liquid. When gas becomes liquid, let's see if there is an option. Yeah, this one is condensation. This one is heat of condensation. Then what are the others? From liquid to gas. From liquid to gas is evaporation. From solid to liquid, this is melting. From solid to gas, from solid state to gas, this is actually sublimation, which is not applicable for water. Anyway, let's move forward. What is the heat of neutralization for strong acid and strong base? It has already been answered, which is minus 57.34 kJ per mole. Which of the following acid has the highest neutralization heat with sodium hydroxide? To get the highest neutralization heat with sodium hydroxide, we need to make it react with hydrogen chloride. Okay, the value is almost 68.4 kJ per mole. Okay. Which has the highest rate of reaction? In this case, the highest rate of reaction will be for sodium hydroxide and hydrofluoric acid. This neutralization reaction will generate maximum amount of heat among the other neutralization reaction. Which has the lowest heat of neutralization? Here, the answer will be for weak acid and weak base combination. So this is the correct answer, as it is a weak acid and this is a weak base. Again, this is the heat of atomization that we are talking about. Heat of atomization, heat of atomization, heat of atomization. These are delta H negative. No, it is not actually heat of atomization. It is heat of ionization, the opposite of heat of atomization. Heat of atomization is endothermic. But heat of ionization, specifically, this is an electron affinity. This is representing the electron affinity of fluorine, which is delta H negative. And now, what can it be called? Exactly, it can call this electron affinity. It can also be called as a heat of reaction. It can be both. So basically, it can be both. But why we are not choosing D? Because it is not certain that here, since it is in the gaseous state, since there is 1 mole, heat it is mentioned as kilojoule per mole. So answer can be both. Basically, it is heat of reaction as well as electron affinity. It can be both. But better answer is heat of reaction, because all heat of reactions are not electron affinity. Anyway, let's move on to the next question. Formation reaction is what? Formation reaction is certainly exothermic reaction. We just read it earlier. In decomposition reaction, heat is absorbed. Apart from other reactions that were discussed with C square NF, other reactions would be endothermic. So to become endothermic, they need to absorb the heat. And in this case, heat is absorbed. Which of the following thermochemical reaction is correct? Okay, let's have a look. Here, as I can see, this one, dissociation of water would not result into such amount of heat. Rather, heat of formation of water would be delta H negative. Again, carbon and oxygen reacting with carbon dioxide. This one is correct. 1 mole carbon reacts with 1 mole oxygen to generate 1 mole carbon dioxide, and minus 393.5 kJ per mole is the correct delta H, or change in enthalpy. So the correct answer will be B. Okay, let's move forward. Which value on the right side of the following is the heat of atomization? Heat of atomization would be this one, plus 121.1 kJ per mole, which should be positive. If 32 gram CH4 or methane is burnt and 980 kJ per mole heat is released, what is the heat of combustion of methane? So just calculate this way. CH4, the mass of CH4 will be what? 16 gram. 16 gram will react with oxygen to become carbon dioxide totally along with water. This is the combustion reaction, right? So to make that happen, I have got this reaction, and I can easily say that if burning 32 gram generates 980 kilojoule per mole, then what would be the case for 16 gram? For 16 gram, the energy would be 980 divided by 32 into 16. So we have to divide 980 with 2, which is 490 kilojoule per mole. So basically, it can be answered easily without any calculation, because 980 is relevant to only 2 options, A and B, and B is the more correct version, because there is a chance of dividing with 2, because they have asked for heat of combustion of methane, whose atomic molecular weight is almost half of the molecular weight provided here. Anyway, let's jump on to the next question. How many moles of carbon dioxide is needed to burn 1 mole? 1 mole ethanol completely. So if I write down the reaction, this is an ethanol, 1 mole ethanol, and we need. It is asking about how many moles of carbon dioxide is needed to burn 1 mole ethanol completely. Let me clarify one thing. Carbon dioxide only needed to burn ethanol. Rather, oxygen will be needed to burn ethanol. Now, let's see how many moles of carbon dioxide is produced here. In this case, if we consider the product will be carbon dioxide and water. And in this case, what will be the number of water? Since the number of hydrogen is 6, so the number of water molecule will be 3. And as we can see, there are 3 oxygens over here. So total to generate, actually we have to, if we add it up, 2 carbon dioxide, then we will get 2 carbon, but we have only 3 oxygens left. Total number of oxygen here would be 4 plus 3 equal to 7, right? So here we do need 3 moles of oxygen molecule to sum it up. To equate the equation, chemical reaction, I have to say that 3 moles of oxygen needed to burn 1 mole ethanol completely to generate 2 mole carbon dioxide along with 3 mole water. I think in this way the equation is balanced. Anyway, the question should be asked in this way, that how many moles of carbon dioxide is formed in burning or in combusting 1 mole ethanol completely. The answer should be 2 mole. And if it was asked that how many moles of oxygen is required to burn 1 mole ethanol, then the answer would have been 3 mole. Now this is a question where I can say that hydrogen reacts with chlorine to generate 1 mole hydrochloric acid gas, and the delta H, since it is a heat of formation, delta H is negative. Again, hydrochloric acid is dissociated in the opposite direction to that reaction. According to Laplace law, it will be the same. It will be of the same value, but with the opposite symbol. So the answer will be A. Again, which one of the following has the maximum value of bond dissociation energy? Okay, here the bond dissociation energy will be maximum in case of iodine, because here the size of an ion gets larger. And that's why the bond dissociation energy would release more energy. You should know that bond formation is exothermic. Bond dissociation will certainly be endothermic. Okay, bond formation will be negative and bond dissociation will be positive. Okay, so the answer is D here. Next question, what is the heat of vaporization of water? Heat of vaporization of water is equal to plus 40.6 kJ per mole. We have seen it earlier. How much kJ per mole is the average bond enthalpy for carbon-carbon bond? This is also something that you need to memorize, which is 335 kJ per mole. The combustion heat of methane is minus 890 kilojoule per mole. Okay, how many kilojoules of heat will be generated if 88 gram of carbon dioxide is produced in this reaction? So it's a very easy question. How? Without even calculation, we can guess the correct answer because the answer will be related to 890 kilojoule per mole. 44 gram carbon dioxide will be produced if 890 kilojoule per, to generate 44 gram carbon dioxide, 890 kilojoule per mole heat is liberated. So to generate 88 gram carbon dioxide, we need to double the amount of it, and if we multiply it with 2, then we will get the correct answer, which is minus 1780 kilojoule per mole. The next question is asking ethanoic acid is reacting with ammonium hydroxide to generate ammonium ethanoate along with water. What is the heat of neutralization reaction for this? As it is a weak acid, it is a weak base, so the heat of neutralization will be much lower than the 57.34 kilojoule. Here the answer will be 50.4 kilojoule per mole. The next question is asking how many moles of oxygen is needed to burn 1 mole of acetylene. Okay, let's see. If it is an acetylene, the formula would be C2H2, and it will be reacting with oxygen. And for combustion reaction, the result will be carbon dioxide and water. Anyway, let's find out the number. As there are 2 hydrogen atoms, I can assume the number of water molecule written here is correct. Now there is 2 carbon atoms, so I can put 2 in front of carbon dioxide. Hence the number of oxygen becomes 5 in the product side. So to balance the equation, I have to write this way: 5 by 2. Okay, so I can easily say that 1 mole acetylene will require 5 by 2 moles of oxygen to burn out completely or to complete the combustion reaction. In the next question, we will find that atomization of chlorine will liberate my plus 121 kilojoule per mole energy, which is an endothermic reaction. Here, what is the type of heat change? The heat change here will certainly be heat of atomization. Which of the following gases has the highest fuel efficiency? You have to know that the value of gas depends on few factors. One of the major contributing factor here is methane. The proportion of methane determines the value of the fuel or the burning capacity of that fuel. Once the methane percentage hits like 95% or more, we can label that fuel as good. So in this case, the fuel efficiency determining factor should be methane. In which reaction heat is absorbed? Okay, let's find out. This is the heat of formation of ammonia, which should be delta H negative. In fact, we do remember the value too because it's a celebratory reaction. Again, this reaction is a combustion reaction, so it will also be exothermic. Sulfur dioxide formation, since it is a sulfur dioxide formation, it will also be delta H negative. But last option is not a typical heat of formation, as we have mentioned earlier. This is an exception to the typical heat of formation. Instead of being exothermic, it becomes an endothermic. Which reaction of the following refers to the ideal enthalpy of formation? Ideal enthalpy of formation is represented here. The heat of formation usually describes the heat required to generate 1 mole of any substance or any compound. The next question is asking 1 joule equal to what calorie? So the answer is 4.24 calorie. On the other hand, 1 calorie is equal to 4.18 or 4.2 joule. At STP, what will be the volume of oxygen needed to burn 16 gram methane? We have already discussed as we can see, for burning methane, you would require 2 moles of oxygen, right? Is it 2 moles of oxygen? No. Yeah, actually it is 2 moles of oxygen. Okay, let's move back a bit. In one of the questions, we have already burnt that methane. No, it was ethanol actually, so we don't have to go back. Let's move back to our discussing question, which is here, this one. As we can see, methane is reacting with 2 moles of oxygen to generate 1 mole carbon dioxide and 2 moles of water. Now 16 gram methane would require 2 moles of oxygen at STP, which would be 1 mole oxygen would occupy 52.4 liters, so 2 mole would occupy 44.8 liters, which is T. This is a reaction. Actually, this is a neutralization reaction. This reaction, so simple question. I wish such easy question at calcium addition test too. Which indicates combustion of propane. Combustion of propane. Okay, let's find out. C3H8 is a reaction of propane, but for combustion you need to react with oxygen. But which one is the correct one? Since the number of carbon is 3, we should consider that 3 moles of carbon dioxide will be generated. So the proper answer here would be this one. The option D is the correct answer because 3 moles of carbon dioxide has generated in this reaction. Now let's move on to the next question, where 35, which is the exothermic process. The exothermic process, we have already memorized the reactions with C2NF, where F stands for heat of formation. The next question is asking which process can be both exothermic and endothermic. As I have mentioned earlier, heat of reaction and heat of solution can both be positive and negative. So in this case, the answer will be C. Which is endothermic process? Which is endothermic process apart from C2NF? Combustion, condensation, neutralization, formation. What are the options left here? Solution can be endothermic as well. So the remaining portion is atomization, which can never be exothermic. This is endothermic reaction. Neutralization heat is constant in case of strong acid and strong base. So the option C will be correct. In this case, methane will result ultimately from carbon tetrachloride, and which bond energy value is not needed to determine delta H of the reaction. Actually, here the initial reactant are carbon hydrogen bonded methane, and another reactant is chlorine. So there is a possibility to determine the bond energy of carbon hydrogen, and also there is a possibility to determine the bond energy of chlorine. But is there any scope to determine the bond energy of carbon? No. So there is the correct answer, which is option A. And you may be wondering where HCl comes from. Basically, when the initial reaction takes place, it becomes like this: C, H, 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 and at the other hand, it becomes CCl. So there is a possibility, and it also generates HCl. Okay, so there's a possibility to connect or calculate the bond energy of hydrochlorine or hydrochloric acid, but there is no scope to determine the bond energy of carbon. The next question is asking that 16.39 kilojoule of heat released by burning 0.5 gram of carbon is absorbed in 250 gram of water in calorimeter. Okay, what is the heat of combustion of carbon? Basically, this is not relevant. You just have to remember the heat of combustion of carbon is minus 395. It is actually minus 393.36. This is something that you have to memorize. You don't have the scope to calculate it in the exam hall, which is this one is easier. So you should just read this question. What is the heat of combustion of carbon in kilojoule per mole? The answer would be minus 393.36 kilojoule per mole. Okay, let's move on to the next question, where it is asked that which reaction increases the volume, increases the value of entropy. Okay, to determine the entropy increase in entropy, which is delta S, to become positive. To increase entropy, you have to know that number of molecules reactant side will be higher than number of molecules in the product side. Total number of molecules in the reactant side should be higher than the total number of molecules in the product side. So let's calculate that. As we can see, here is 3 mole, here is 1 mole. So entropy will decrease. Here there is 3 mole, there are 5 moles. So entropy is increasing. Here entropy is increased. Again, here is 7, here 2. So entropy will be decreased. Again, 3 and 1. So entropy has decreased. So in this question, it is asking for the increasing value of entropy. So the answer will be option B. Okay, the answer will be option B. Natural rubber is damaged by exposure to ozone because rubber contains which bond? Rubber contains carbon-carbon double bond, which gets destroyed by the ozone. When a chemical bond is broken, the bond energy is positive, which because the heat is absorbed. Okay, that's true. Bond energy positive means heat needs to be absorbed. Negative means heat is liberated. Heat of solution, the heat required from the solution. No, actually it is the heat generated or absorbed because we already know that heat of solution can both be exothermic or endothermic. It depends on the solvent. Magnesium. 1 gram magnesium is combusted in a sealed container containing 0.6 gram of oxygen. What amount of magnesium will be extra in the container? Okay. since the reaction would look like this, magnesium will be reacting with oxygen to generate magnesium oxide. Here, half mole oxygen is enough to combust 1 mole magnesium. So the molar atomic weight of magnesium is 24.3. So if we consider 24.3 gram, then we can easily say that it requires 16 gram of oxygen for total combustion. So we can write in the opposite direction that 16 gram will require 24.3. So 1 gram, actually not 1 gram, we can directly write 0.6 gram oxygen will be able to combust 24.3 divided by 16 into 0.6. Let's make it simple. Instead of considering 24.3, we should rather consider 24. If we consider 24, then we will get 4 into 6 will be equal to 24, 4 into 4 will be equal to 4. So 6 into 6, which will be 3.6, right? 6 into 6, it will be 3.6, 3.6 if we divide by 4, then we'll get 0.9. So as we can see, 0.9 gram magnesium will be combusted by 0.6 gram oxygen. Here we have 1 gram magnesium. So if we subtract 1 gram from 0.9, then how much will we get? Will this be 0.12 or will this be 0.09? Because the amount of magnesium is more. We have considered that 24, but it's actually more than 24. That is 24.3, somewhat more. That's why the amount of magnesium that is combusted will be more than 0.9. If it is more than 0.9, then the residue will never be 0.12. It would rather be less than 0.1, which is 0.09. The correct answer is here, option A. The next question is asking when a chemical bond is broken, the bond energy is positive because the heat is absorbed. Yes, certainly. Which of the following is a complete thermochemical reaction? The complete thermochemical reaction should mention the gaseous state as well as the temperature or enthalpy change, which is B. Which acid-base reaction has the least negative change in its standard utilization kit? So least negative change means which one shows less heat of utilization, right? In this case, the least value would be possible for weak acid and weak base combination, which is here, option C. How many moles of oxygen are required to completely burn 2.2 gram of propane to form carbon dioxide and water? Okay. As we know, propane reacts with oxygen to form carbon dioxide and water, and it will certainly generate 3 moles of carbon dioxide and 2 moles of water. So total number of oxygen would be 4 mole, right? So 3 into 2 equal to 6 plus 2. So I think it's balanced right now. In this case, as I have mentioned, C3H4, the molecular weight, the molecular weight of propane will be 3 times 12, 36 plus 4, which is 40. So 40 gram propane reacts with 4 mole of water, or 40 gram propane requires 4 mole of oxygen, right? We are being asked about the moles of oxygen, so it is possible from here. We can say that 2.2 gram propane will require 4 divided by 40 into 2.2. Okay, so how much will it be? If we calculate this way, this one is 1, this one is 10. Then if I divide 2.2 with 10, it would be 0.22, and 0.22 is close to 0.25. So this will be the answer. What is the sublimation heat of graphite in kilojoule per mole? This is something you have to memorize, 770.02. And now thermochemical law. What is the atomization enthalpy of oxygen? This is also have appeared in the admission test, plus 249.2 kilojoule per mole. When delta H equal to delta E in a chemical reaction, it means the volume is constant. When the volume does not get changed, then the energy and enthalpy change becomes equal. If here carbon combustion heat will be delta H1. So if I write it down in this way, it can be presented this way, like carbon plus oxygen reacting to form carbon dioxide. It can be demonstrated as delta H1. And for combustion of hydrogen, we will require half mole oxygen to generate 1 mole water, which can be represented with delta H2. And the methane combustion here will require 2 moles of oxygen because it will generate 1 mole carbon dioxide and 2 mole water. Here the delta H can be represented as delta H3. Now if I consider delta H3, it can be written in this way. We have to add up the heat of formation in the product side and subtract it from the reactor side. So heat of formation of carbon dioxide, which is delta H1. Again, we can add up 2 delta H2 because here 2 moles of water is there, so it will be 2 delta H2. Now we have to subtract what? Subtract the reactant side. We have to determine the heat of formation of methane, and the remaining portion will be 0 because heat of formation of a molecule with no other atoms in it would be 0. In this case, we can easily determine the heat of formation of methane in this way: the delta H1 plus 2 delta H2 minus delta H3. Okay, as we have this option as answer, this one is the correct answer. Okay. What is the relationship between enthalpy change and internal energy? This is a thermodynamical equation, which is delta H equal to delta E plus B delta V. According to the law of thermodynamics, we get this equation. The last question here, as we can see, the heat of combustion of methane is 902.5 kilojoule per mole. On the other hand, how many grams of oxygen will be required to generate 2050 kilojoule of heat? This is a question that requires calculator, but still we can assume or we can predict without calculator. How? Actually, it's quite difficult to predict because the options are very close to each other. 145, 147, 150, 140. All of them are really close. In this case, the good approach will be to leave the question if such close options are there, because it will waste your time and the probability of correcting that or making that correct is very low. But what will be the approach for this question? I should say that the heat of combustion of methane is 902.5 kilojoule per mole. So we know to combust methane, we require 2 moles of oxygen. So to generate 902.5 kilojoule, we require 2 mole. So how much oxygen will be required to generate 2050 mole? It would be like this: 902.5 into 2050. So if I try to divide it, what would be the answer? If I try to divide 20 with 9, we will get 2 point something. Suppose it is 2.2. Suppose if it is 2.2, then the answer will be 4.4 mole. And now you have to calculate what 4.4 mole would be. 1 mole is 32 gram. So 4.4 mole. So 4 times 32. If we get it 4 times 32, it will be 4 into 2, which is 3 times 4. Which is 2. 128. It's nowhere near to that. Basically, rest of the 0.4 would also come in consideration. I mean, if it is 4.5, let's have it considered 4.5. Then the value would become 4 into 32 plus 16, in fact, right? So the answer would be 128 plus 16, and 128 plus 16 is almost near to 143. Okay, anyway, the proper answer is 145.3. It is quite difficult to predict without any calculator. So I just brought this question in solution only to show you which you don't try to answer. The question in which options are very close to each other and the calculation is very complex, you should leave that question, because leaving sometimes do better. I mean, you can save at least 0.25 marks and you can attain some other marks instead of marking this one indirectly. Anyway, with this, our lecture came to an end. Hopefully, you have enjoyed the class and do practice more to get better numbers. Best of luck.
Assalamu alaikum, dear students. I welcome you all in our today's masterclass. Today we are going to discuss on chapter 4, chemical changes, lecture 4. As you all know, in our lecture 4 we will be discussing pH of solution and buffer solution. This is a very important topic. I mean, apart from the mathematical problems, what kind of questions that may come from this topic? Let me first clarify on those things. First of all, you have to have knowledge about the numerical values regarding pH. I mean, what is the pH of gastric juice, what is the pH of urine. These are some information that will be available not only in chemistry book but also in zoology. So you have to have the knowledge of both subject together. I think it is my suggestion to note down all the numerical value of pHs together and keep it in a single page and stick it somewhere else so that it can be stayed visible, or it can be easily recognized. I mean, when you read something voluntarily, that result into a long-term memory. Anyway, apart from numerical value, you have to know the comparisons of pH. Comparisons of pH, I mean, what will be the strength of an acid if its pH is lower? What will be the strength of a base if its pH gets higher? So the comparison, and also the concentration of hydrogen ion in terms of pH. I mean, if you change pH by 1, then the concentration of hydrogen gets increased or decreased by 10 times. That's how it works, and you have to have the knowledge about the comparison. Moreover, you have to know how to determine pH, without the use of calculator. Today we are not going to discuss on those because we are going to solve all the mathematical problems together, but today we will be focusing on the basics of the pH of solution. Moreover, regarding the buffer solution, you have to have the knowledge regarding types of buffer solution. Recent times we are getting such questions that which one is an acidic buffer, which one is a basic buffer. I mean, such questions are easily answerable if you have the basic. So you have to know what are the types and how does acidic and basic buffer forms. Anyway, apart from buffer solution types, we have to know specifically about blood, because blood contains a lot of buffer that's for those keeping us alive. Without blood buffers, we won't be alive today, because the pH of blood is very sensitive, it's very important. If it fluctuates by more than or less than 0.5, then our life will be jeopardized. So we are continuously experiencing lots of things that might hinder the change in pH, and that might compel blood to change its pH, but it is not possible, or it is not made possible because of the presence of buffer solution. So we have to know about blood buffers and their pKa. Blood buffers and their pKa. And I think other than those, we have to have idea regarding the Henderson-Hasselbalch equation, with which we can determine the pH of a buffer solution. All these are important issues that we are going to focus. We are not going to discuss all, but we are going to solve the questions along with the solving of question or solution of question. The discussion will be continued. As we can see in the latest admission test, we have found questions from this topic, so it simply tells about the importance of this topic. So let's move on to solving questions. Our first question is, what or which pair is used to make basic buffer? See, such question appeared in the admission test for 3 times. It is very important to know how a basic buffer is made up. Well, let me clarify on this. Buffer solution is a solution which hinders any change in pH. While we add some acid or add some base, the pH needs to change, but the change in pH is hindered or obstructed or prevented by the buffer solution. Buffer solution can be of 2 types. What are those? Those are one acidic buffer and another one can be basic buffer. So what makes an acid buffer? To make an acid buffer, you have to use a weak acid. So you can easily say, to generate a basic buffer, you have to get a weak base. See, these are the comparison. You need to have a weak acid and you need to have a weak base. That's the first rule. Next, you have to have a salt that is generated from a neutralization reaction between that weak acid and another strong base. If you get a salt that is formed from a neutralization reaction between a weak acid and strong base, and along with a weak acid, that combination will be an acidic buffer. As for example, if we look at the options, we will find it. Suppose this is a weak acid, right? Ethanoic acid is a weak acid, and when ethanoic acid reacts with a stronger base like sodium hydroxide, it generates the salt part, which is sodium ethanoate. So this combination, since it got a weak acid, it will not be a basic buffer. Rather, it will be an acidic buffer. Okay, so that fills the criteria for acidic buffer. And what happens for basic buffer? Along with weak base, you have to have a salt that is composed of, that is basically generated from a neutralization reaction between a weak base or between that weak base and a strong acid. See, this is the reverse or opposite of the acidic one. So I think if you get the point, like for acidic you need to have an acid which is weak, for base you need to have a base which is weak. I think that would lead to the ultimate solution, because once you can remember this, then you will find, or it will be easier to recall that the salt portion would be this way, like weak acid and strong base combination, and again it can be this way, weak base and strong base combination reaction. Anyway, so let's determine what are those. Sodium hydroxide and sodium chloride. See, sodium hydroxide is a strong base, so it does not fall into the criteria of a buffer. A buffer should have a weak acid or weak base, so this is not a buffer. Now let's move on to the next option. Sodium sulfate and sulfuric acid. Here, as we can see, sulfuric acid is a strong acid. Strong acid we do not call a buffer if it contains strong acid. So this one is not at all the answer. So the remaining option, or the last option left, is the correct answer. Without hesitation we can tell that, but still we should apply the theory. As we can see, this is the weak base, right? And this one is a salt. This one is a salt that is the result of a neutralization reaction between weak base and strong acid. The strong acid is hydrochloric acid and the weak base is ammonium hydroxide. The resultant salt is ammonium chloride, which is a acidic salt. Anyway, this pair is used to make a basic buffer solution. Okay, so the correct answer will be this one. Let's mark it this way. This one is the correct answer. Okay, now let's move on to the next question. Which chemical is used to increase the pH? See, by increasing pH, you are decreasing the concentration of hydrogen ion, so it is becoming more basic. Now you have to determine how we can increase the pH or change the acidic nature of a soil and turn into a basic soil. Without lowering the pH without increasing the pH of an acidic soil, it will be difficult to cultivate any beneficial or any essential crops. So let's move on to the options. As we can see, phosphate. If you think about phosphate, think about phosphoric acid. If you think about nitrate, you will think about nitric acid. If you think about nitrate again, you will be thinking about nitric acid. So all of them will generate nitric acid and phosphoric acid when goes to soil and reacts with water. So in that way, they will lower the pH. On the other hand, calcium carbonate would rather generate calcium hydroxide. So calcium hydroxide is basic in nature, and thus they will increase the pH. So here the answer will be calcium carbonate. What is the clue to answer such questions? You need to know that phosphate, nitrate, such fertilizers. I mean, if we mark a territory like carbonate or hydroxides or oxides, if we demarcate this territory between different types of fertilizers, then we will find that such fertilizers that contain phosphate or nitrate, they tend to lower the pH. So they decrease the pH. On the other hand, carbonate, hydroxide, and oxide containing fertilizers increase the pH. So these will be suitable for, this is suitable for what? This is suitable for acidic soil. This is applicable to acidic soil, and this should be administered in the basic soil. And thus we will get the optimum pH for better cultivation. Next question, which of the following is used to prepare basic buffer solution? See, as we have solved already, it will be easier for us to determine. First option, again, this one will not be the answer. Second option, third option, I mean, this is the whole questions that we have solved already, so we do not waste our time anymore. The answer will be option D. Okay, now let's move on to the next question. Which one is used to increase the pH of the soil? So increasing pH as we have already mentioned, that increasing the pH is the responsibility of carbonates or oxides or hydroxides. As we can see, we got an oxide, which is calcium oxide, that will result into increasing pH. Which of the following solution has the highest pH? So we have to think that which one is basic. I mean, 0.01 molar hydrochloric acid, nitric acid. I mean, we are observing all the options as acids, so it is now our responsibility to determine the weakest one, because the weakest one will show the highest pH. So hydrochloric acid, nitric acid, sulfuric acid, all of them are traditional or conventional strong acids. On the other hand, the carbonic acid is a conventional weak acid, so it is easier to determine the or say the answer, because without calculating the pH, actual pH or hydrogen concentration, we can easily tell that the highest pH will be demonstrated by the carbonic acid because of its conventional weak nature. Okay, which buffer solution is present in human blood? As it appeared 2 times, we should be very careful. I mean, you have to know that. So let me discuss a bit more on this. Suppose it is a blood vessel. It is a blood vessel, and in blood vessel or within the blood vessel, you know that there are red blood cells. In compared to blood vessel, the red blood cells are not that huge, but I just demonstrated that to make it clear. Moreover, there are lining epitheliums that lines the epithelial cells of the blood vessels. Okay, these are the lining epithelium of the blood vessels. So at first, let's demarcate some territory. Suppose this is a cell, right? This is the blood corpuscle or blood cell. So within the cell, the fluid that stays within the cell is called intracellular fluid. Intracellular fluid, which in short expressed as ICF. On the other hand, all the bloods, I mean the plasma portion of the blood is extracellular fluid because that stays outside the cell. So this one is certainly ECF. What does it mean by ECF? Not expressed from. It is extracellular fluid. It is intracellular fluid. It is extracellular fluid. Very good. And now, what are the fluids about the lining epithelium cells? I mean, there are some fluids in between the cells. That is called interstitium. That space is called interstitium. I mean, the fluid within the cells are also included in the intercellular fluid, but the interstitium is between, it is the space between the tissue or between the cell. So that interstitium also contains some fluid, which can also be represented as intercellular fluid. So as you can see, there are fluids everywhere, extracellular, intracellular, intercellular. So you have to have buffers in all the segments to keep the pH unchanged. So as you can see, for ECF, since it carries a major amount of blood, which is plasma, we have bicarbonate buffer and plasma proteins that act as extracellular buffer. On the other hand, in the intercellular fluid, we got some different buffers, which are hemoglobin buffer. Okay, hemoglobin buffer, which is a protein that stays within the red blood cell. And regarding the intercellular fluid, we got phosphate buffer. So we have already demonstrated all the blood buffers in this picture. I think with this, you have got a clear visualization how blood buffer acts or how blood buffer is located or distributed among the different components of the fluid. So which buffer solution is present in human blood? As you can see from the discussed option, like this one, and this one. These are the blood buffers. So let's find out if there is such any options in the given options. This one is not present. This one is not present. This one is also not present. This one, I mean, phosphate buffer is present within the blood. But here actually option A and option B both are correct, since bicarbonate and phosphate, all of them are present in blood. But there is a but. What is the twist? The twist is you need to determine the better answer. You have to know that the best buffer, I'm encircling the option here, this bicarbonate buffer is the best buffer. You have to have that knowledge regarding bicarbonate buffer. Which one is the best blood buffer? Basically, bicarbonate buffer system works on the basis of, works with 2 components. One is carbon dioxide that is excreted or exhaled through our respiratory system, and another one is bicarbonate ion, which is usually reabsorbed or excreted through our renal system. Since 2 systems are involved in continuing or maintaining the pH, we can easily say that bicarbonate is the best buffer solution of the blood. So since this one is the better answer, we have to mark this one as the correct answer here. Okay, but you have to know that the phosphate buffer is also present within the blood system. What is the pH of pure water? The pH of pure water is very known to us, which is 7. Anyway, let's move on to the next question. We wish such questions come repeatedly, because such question will either delight you with shock, or appearing in such question is sometimes tragic, because such easy questions sometimes may drag your concentration away or deviate you from real thinking. Sometimes people get awestruck with very easy questions and then gets less time for some other questions that are really difficult. Which one is used to reduce the pH of alkaline solution? Again, to reduce the pH or to lower the pH, we need to have nitrate or phosphate. So as we can see, yes, we have the option nitrate here. Which of the following substances, if added to a solution, pH of 7.4, will decrease? So here the conditions will decrease. Lowering the pH, again, we have to find out what? We have to find out some acids, right? Alcohol, this one, what is this? C3H6O. It can be represented as CnH twice N, which is an aldehyde, right? So propanol or propanone can be this way, and this one is butanol. So sorry, this one is ethanol. So all of them are neutral. Only ethanoic acid is an acidic one, so it will lower the pH. Okay. If pH of blood is 6.9, this condition is known as acidosis. You have to know that our blood pH is normal blood pH is within the range of 7.35 to 7.45. Any pH less than 7.35 will be termed as acidosis. Be very clear. Now, you don't have to lower your pH more than 7 to say it is an acidosis. For blood, you have to say that any pH lower than 7.35 can be termed as acidosis. Okay, and any pH more than 7.45, not more than 7, more than 7.45 would result into alkalosis. Actually, acidosis or alkalosis is not the condition of the blood. It is rather the condition of the body. With acidosis, we mean some symptoms that appear during low pH of blood or lower pH of blood. Again, alkalosis is a condition, that is a cluster of symptoms that appear during higher pH. Okay, we know that blood is slightly alkaline. Yeah, blood is slightly alkaline because of that 7.35 to 7.45 pH range. But when it still remains alkaline, I mean 7.2 or 7.1, it's still alkaline. Yet the condition that arises within the body because of such pH is acidosis. If you add a little acid or base, which solution's pH does not change? Okay, now we have to determine which one is a buffer, right? This question is asking that which one is a buffer. Basically, all the options are not buffer solutions or something different. This is a very easy question. The answer is C, buffer solution. Which buffer doesn't control pH of human blood? Okay, to control pH of human blood, you have to know the buffers of blood. We have already discussed it. Bicarbonate is there, protein is there, phosphate is there, but acetate is not there. So the option D will be correct. Which one is right about pH? Regarding pH, if the pH of a solution is 7, then it is neutral. This one is the correct answer. If the pH is more than dash, the fertility of the soil is destroyed. Okay, you have to know that to grow or to facilitate the growth of the microorganism in a soil, the pH needs to be within 6 to 9.5. Other than that, the microbacteria will not, microorganisms will not be able to grow, and without them, there will be no decomposition, there will be no humus formation, as well as there will be no enough nutrition for the plants to grow. So in that case, the fertility of the soil would be decreased if it is more than 9.5. Okay, you have to memorize it. Very crucial. It is very, very important. I'm writing it down because after a few questions, we got some question that you may fail to answer correctly. If you do not recall that perfectly, you are bound to answer it wrong. So you have to memorize it. Each acid has pK 3.74. This is also something numerical that you need to memorize, which is formic acid. And also you have to know that the pKa of acetic acid is 4.74. More than which pH change endangers human life? I mean, this is an ill-worded question. Actually, it's asking that what is the range of pH? What is the minimum change? What is the minimum change in pH that endangers human life? To endanger human life, the minimum amount to change the pH is by 0.5. Which of the following solution has the highest pH? Again, we have to find out which one is least acidic. We have already solved it, which is D, 0.01 molar by carbonic acid. For which of the following pH value does hydrogen ion have the highest concentration? Okay, for hydrogen ion will be highest in concentration if the pH is the lowest. So answer will be D, 2.3. The pH of two acidic solution are 3 and 6 respectively. How many times more acidic is the first solution than the second? You have to know that the difference in pH will be power to 10. Okay, so acidic solution, it got a pH of 3. So it will now be converted to 6, or there are another solution which got a pH of 6. So the difference is 3. Difference is 3, and it will be the power of 10. So 10 to the power 3, which is 1000 times. So the first one is 1000 times more acidic than the second one. pH of solution is 6. If more HCl is added, it becomes 3. What will be the increase of concentration of the hydrogen? Similar question, which is 1000 times. What will be the pH of aqueous solution of ferric chloride? Okay, so as you can see, ferric chloride is a salt, and it will be the byproduct of ferric hydroxide, and hydrochloric acid, right? So if hydrochloric acid reacts with ferric hydroxide or ferric oxide, then it will generate such ferric chloride salt. As you can see, this metallic hydroxide is not that strong base than like the acid here. Here hydrochloric acid is very strong, so that's why the salt will be acidic in nature. The salt will be acidic in nature, and in that case, the pH will be lower, which is less than 7. What is the range of pH? We have already discussed it, so option D will be the answer. What is the normal pH of blood of human? If there is no range, the answer will be 7.4. If the pH of human blood is 7.45, then the condition can be called as alkalosis. What is the biological pH range? The biological pH range is within 6.9 to 7.4. Why? Basically, it is written in the book, and there is a potential that you may fail to answer this question. I am writing VVI in the corner of some questions. Be very careful about those because such questions are a bit tricky. You may fail to determine it. Okay, you may wonder that if it is 6.9, then it should be 7.9 as well. I mean, you have to add 0.5 as well to get the actual range, but this is not the case here. The biological range of pH should be 6.9 to 7.4. This is something that if you know, you can answer. What is the pH of tear? The irony is the pH of tear is similar to the pH of urine, so both are of similar value. You have to know that. Anyway, 6.6 to 7.6 is the correct answer. Next option, as we can see, which is used to reduce the pH value of soil. As we can see, to lower the pH value, you have to have either nitrate or phosphate. As we have the option here, phosphate is the correct answer. Which pair creates acidic buffer solution? Similar questions we have solved already. To say something acidic, we have to find out a weak acid. This one is not correct. This one is the correct option. No. Why not? Because it got a weak acid, but this is not the salt or the compound that we are looking for. Okay, so this is a weak base. Weak acid, weak base combination is not a buffer. So this one is wrong. This one is wrong as well. This one is also wrong. Why? Because here we have weak base, not weak acid. So the last option will be the correct option, which is ethanoic acid and sodium hydroxide. Basically, none of them should be correct. But why sodium hydroxide can be stated correct? Because this is a strong base that would react with this acid and generate the salt, which is ethanoate, sodium ethanoate. That's why we can still say that this one is the correct answer. Let's move on to the next question. Which buffer solution is present in human blood? We have solved that already. The answer will be option A. Yeah, we have got phosphate buffer too, but better answer is option A. What is the correct formula for determining pH of acidic buffer solution? This is Henderson-Kesselbach equation. We will solve some mathematical problems about this equation in the mathematical segment of our lecture. I mean, not today's lecture. There will be a separate lecture of mathematical portions. You should go through that, and you have to know that this equation is pH equal to pK plus log salt, concentration of salt divided by concentration of acid. Which of the following aqueous solution has the highest pH value? As we can see, aqueous solution to show the highest pH value, it needs to be basic in nature. Ammonia is basic. Sodium hydroxide, ammonium chloride, ethanoate. This one is not. This one is a bit basic, but which one is the strongest base here? I mean, without any sort of knowledge regarding pH, pK, still we will be managed to determine or find out the better answer here, because we all know sodium hydroxide is a strong base. So this one is certainly the answer. Let's move on to the next option. Which of the following is incorrect? Regarding all the options, as we can see, the first one, pH of 10 to the minus 2 molar, hydrochloric acid will be 2. This one is correct. Again, pH of 0.01 molar sodium carbon solution is more than 7. Why? Because sodium comes from sodium hydroxide and carbon comes from carbonic acid. One comes from strong base, one comes from weak acid. So which one will take the upper hand? The strong base or the stronger one? That's why the solution pH will be more than 7. pH of 0.01 molar sodium hydroxide solution is 12. Yeah, it is simple because 10 to the minus 2 is the concentration. So if you determine the pH of 10 to the minus 2, it will be actually pOH of 10 to the minus 2, it will be 2. And if you subtract it from 14, you will get the answer, which is 12. So this one is also correct. Last option. It is bound to be wrong. Let's see how it is wrong. 10 to the minus 9 molar hydrochloric acid solution pH will not be 9. This is an important message you have to know. What is that? An acidic pH or the pH of an acid will not get higher than 7. In fact, it will not be 7. It will be very close to 7, but not 7. Why? Because once you dilute a strong acid or any acid to an extent that it shows numerically the pH can be lower or higher than a 7, but it doesn't happen that way because of the presence of hydrogen ion of the water itself. So along with the 10 to the minus 9 molar hydrochloric acid and 10 to the minus 9 molar hydrogen ion, I mean, if you get a pH, 10 to the minus 9 molar hydrogen ion, you have to add the 10 to the minus 7 molar hydrogen ion along with this. So in together, the concentration would be a bit more. And I mean, it's like 10 to the minus 7. 10 to the minus 7 is the concentration of hydrogen ion, and you are adding some very negligible amount with that. So which one will prevail, or which one will be the main determinant of the pH? It will be the 10 to the minus 7. So the answer will be very close to 7, but not more than that. Because if you, I mean, this is absurd. Like you are diluting an acid and eventually it became a base. No, it doesn't happen this way. It's a life lesson also. Like you may not correct someone to an extent that he becomes the opposite one. I mean, you cannot rectify a criminal to a saint. He will be a less criminal, I think, but he will never be a saint. There would be something left in him, or I mean, it's possible for once, but still, that was a metaphor that I used to explain this. Let's move to the next question. Which of the following substance, if added to a solution, pH 7.4, will decrease its pH? So, regarding decreasing pH, we have to have, we have solved it already. This one is already solved, which is ethanoic acid. Reaction between weak acid, it is a HX, should not be weak acid anyway. HX, I mean, we think this is halo acids, but this is said, I mean, it can be hydrofluoric acid. Anyway, Weak acid and sodium hydroxide, the resultant salt is sodium X or sodium halide. In this case, what will be the possible pH in the aqueous solution? Okay, this is a very easy question now because this one is weak acid, this one is strong base. So the basic or the stronger nature will prevail. So the solution, the aqueous solution of the salt will be basic in nature. So the pH will be more than 7. If the pH value of blood bicarbonate buffer is 7.4, what is the ratio of bicarbonate to carbonic acid buffer? The ratio of bicarbonate to carbonic acid buffer is 20:1. This one is also very, very important. Why? Because you may fail to recollect this. This comes handy when determining the pH, of blood with application of bicarbonate buffer using the the pKa of bicarbonate. pKa of bicarbonate is somewhat 6.1 or something. So you need to add up 1.3 to get the 7.4 pH. So it is actually let me clarify this. Which one is an ideal buffer? What is an ideal buffer? Ideal buffer is a buffer solution whose pKa value is within the plus minus 1 range of its target pH. I mean, if my target pH is 7.4, if it is my target pH, then what will be the ideal buffer for this solution? The ideal buffer may range from 6.4 to 8.4. Any buffer that shows pKa between 6.4 to 8.4 can be a good buffer for what? 7.4 pH. Okay. So as I have said already, a bicarbonate buffer shows a pKa value of 6.1. 6.1. This is huge. And for 6.1, I mean, if you say this way, pH equal to pKa plus log salt, concentration of salt, divided by constant concentration of acid. Okay. The pH here is 7.4 and the pKa here is 6.1. So you have to get additional plus 1.3 to make it 7.4. And how will we get 1.3? If we get log of 20. So this is the ratio of bicarbonate, which is salt, and carbonic acid, which is acid. And the ratio is 20, and by using logarithm on 20, we will get 1.3, and that's how we get the 7.4. Okay, the answer option here is D. And now you are wondering how this ratio can be maintained. This ratio is very crucial because the numerator is dependent on the excretory system or renal system. On the other hand, the denominator is dependent on the respiratory system. Two systems are involved. When an acidic situation comes or basic situation comes, both systems work together to modulate this fraction and hence result into maintenance of pH. Anyway, let's move on to the next question. Which aqueous solution has the highest concentration of hydronium ion? Hydronium ion means which one is more acidic. So here, as we can see, the lowest pH is shown in option B. So option B is the correct answer. Which is buffer solution? Milk, honey, blood. Certainly blood. What will happen if 1 drop of hydrochloric acid is added to pure water? The pH will be lower than 7. Which is the alkaline buffer? Somebody may say that hydrochloric acid already contains hydrogen ion concentration. Water contains hydrogen ion concentration. So how the pH gets low if the hydrogen gets increased? Basically, it doesn't happen this way. The compound ion effect takes place. Which is the alkaline buffer solution? The alkaline buffer solution should have a weak base. Yeah, this one is the correct answer. Why? Because it got a weak base and a strong acid. With combination, it will generate a salt, which is ammonium chloride. Which one has the lowest value of pH? Lowest value of pH for higher or highest concentration. If pH equal to 11 for soil at a particular place, what should be applied there to produce crops? Crops means dead body. So to produce crops, you have to lower the pH. And for lowering pH, as we have already said, like recall, what fertilizers do we need to lower pH? Is it nitrate or phosphate? Either of them. So we have to find if there is any nitrate or phosphate. And we got phosphate at first option, which is triple superphosphate. pH of solution is 5, pH of solution B is 8. How many times more acidic solution A than solution B? I mean, it's a bit funny because all of the questions that are like this comparison, I mean, this solution got that pH, this solution that got that pH. What's the difference between the hydrogen concentration? In maximum cases, the answer becomes either 1000 or 10 cube. I mean, you can think different. I mean, you can frame different question. I don't know why all the writers keep on repeating 1000 as the answer. If you add a little acid or base, which solution? Solution's pH does not change. Same question we have solved already. Which one is related to the mechanism of buffer solution? La-Chatelier principle is applied because La-Chatelier principle states about balance, states about keeping the equilibrium unchanged. When you change the factors, then the equilibrium shifts in a way so that the factor's effect gets neutralized. That's how the buffer system works. Which one of the following solution has more pH? More pH means more acidic or base. More pH means more basic. So this one will not be correct answer. This one will not be. We have a strong base, so this one will be the answer. Which one of the following will act as a buffer solution? As we can see, for a buffer solution, you have to have either a weak base or weak acid. This is not correct because you have to have methyl formate. This one, ammonium hydroxide and ammonium carbonate will not be correct because it would be correct if it was ammonium chloride. Hydrofluoric acid, a weak acid, and it reacts with sodium hydroxide, but this one is also not correct because this is not an ideal buffer. The last option, I think we could answer that at the first instance, but I clarified all the other options to give you a clear idea about the basic. Which cell of the human body is weakened by acidosis? Blood cell is very vulnerable to pH change. The fragility of blood cell is very significant. It is so much dependent on pH. I mean, if you lower the pH, sometimes blood cell gets disrupted. The structure gets disrupted, so the vulnerability is very prone to, RBC is very prone to change in pH. Which one is not an acidic buffer? Acidic buffer must have a weak acid. So this one got a weak acid. This one also got a weak acid. This one is actually not a weak acid. I mean, with the weak acid, you have to have a salt that is a result of neutralization between weak acid and strong base. This does not happen this way. So this is not an acidic buffer. Okay. All of them are weak acid, but this is not an acidic buffer because of bicarbonate and something containing a basic portion should be there to become an acidic buffer. The aqueous solution of which salt has a pH more than 7? To get a pH more than 7, you have to determine in such question, what will be your approach? Just separate the components of the salt. Like sodium came from sodium hydroxide, chlorine came from hydrochloric acid, so it will be neutral. Both of them are strong. Ferric hydroxide, hydrochloric acid. Here, hydrochloric acid will take upper hand, so this one will be acidic. This is alkaline. Why? Because sodium came from a stronger base and carbonate came from a weak acid. Last, ammonium came from a weak base, chlorine came from a strong acid, so strong acid will prevail. Which system is neutralized? The system that gets neutralized. Which system is neutralized? Lime water, sodium chloride neutralization. I mean, the question is which one is a neutral option? This is neither acidic nor basic. We get a neutral condition when we react a strong acid with a strong base. Then the resultant salt will be neutral, which is option B here. Which is buffer solution? Buffer solution, to have a buffer solution, you need to have a weak acid or weak base. Weak acid, but that is not a weak acid related salt. Again, this is a strong acid, so it will not be the answer. This one is a weak acid and a strong base that would react. The proportion of the weak acid. Why this option A will not be correct? Because the proportion is not correct. It is 10 centimeter cube, 1 molar bicarbonate, carbonic acid, formic acid, and 10 centimeter cube of 0.1 molar sodium hydroxide. This will not be the case here. Here, important issue is the amount should be higher also for the weak acid portion because weak acid will react with the excess weak acid will react with the base to generate the salt. Anyway, as you can see, the option C will be the correct answer. Let's move on to the next question. Which is alkaline buffer? For alkaline buffer, you need to have a weak base, which is bicarbonate. pH range of formic acid and sodium formate buffer system. Since it is a weak acid, it is an acidic buffer, it will change, it will act better within this pH range, 3.7 to 5.2. Acidosis occurs when blood pH is less than 6.8, but basically it is wrong. This is wrong. Acidosis occurs, this is the wrong question, wrong answer. The correct answer should be less than 7.35. This one is wrong answer, and the correct answer will be less than 7. No, not less than 7, it will be less than 7.35. Which part of our body has an alkaline pH? Small intestine, because bile comes into play. Bile lowers the pH of small intestine. The juice that is liberated from small intestine is succus entericus, and that gets a lower pH because of the bile. A weak acidic solution, again see 3 and 11. Okay, thank God that we got different pH comparison. When mixed in equal volume, the value of pH of the mixed solution will be what? This is not some mathematical calculation like 11, 3. If you multiply, if you add, it will be 14, and so the neutral condition will be available in neutralization. No, this is not the case. pH of 11. pH of 11. When mixed in equal volume, the value of pH of the mixed solution becomes. Okay, let's determine. For pH 3, the concentration will be 10 to the power minus 3. 10 to the power minus 3 molar hydrogen ion. This is the hydrogen concentration for pH 3, and the hydroxyl ion concentration for pH 11. This is for pH 11. This is for pH 3. Okay, the concentration would be 10 to the power minus 14 minus 11, which is actually this way, 14 minus 11, 10 to the power minus 3 molar. Okay, the hydrogen ion concentration, basically it will not be this way, not minus. The concentration would be 10 to the power minus 14 minus, let's make it simple. If this pH is 11, then POH will be what? POH will be 3. 14 minus 11, which is 3. So for 3, hydrogen concentration, it will be 10 to the minus 3 molar. Now, this weak acid solution, someone may be wondering, I mean, if it is 10 to the minus 3 and 10 to the minus 3, then the resultant solution would show 7 pH. But you have to focus on the word before the pH, which is weak. And here it is written as strong. Any neutralization reaction that takes place between a weak acid and a strong base will result into a stronger basic solution. Why? Because the stronger one will take upper hand. Here, basically, hydrogen concentration will not 10 to the minus 3 molar. With that, you need to multiply the dissociation constant of the acid. Okay, and that's how the hydrogen gets much more lower. So the basic quotient will prevail. So the option D will be the correct answer. How many times the solution of pH equal to 1? Again, see, the difference is 1000. I mean, difference will be 3, and it will be powered by 10. Then the 3, which is 1000. If the pH of the soil is less than 3, then the agricultural production will rapidly decrease because of this institutional microorganism of the soil. This one is the correct answer. Next, the pH of the soil needed for microbe to survive should be more than 3 and less than 10. This is an information from Gover's book. Which buffer maintains the pH of blood in human body? The bicarbonate is the most correct one. Nature of aqueous solution of ammonium bicarbonate. Ammonium bicarbonate. See, ammonium is a weak. Ammonium came from weak base. Bicarbonate came from a weak acid. So what would be the condition? It would be neither acidic nor alkaline. The pH of an aqueous solution is 2. If it is diluted 100 times by adding water, what will be its new pH? Okay, pH of an aqueous solution is 2. 100 times means the power of 10 is the portion that power will be added to the pH. That power will be added to the pH and it becomes 4, which is a set of amphoteric substance, but dual nature. They can provide hydrogen ion when needed. They can provide hydroxyl ion as well. So you need to have both of them to become an amphoteric one, and we have to find out which one is amphoteric or which is a set of amphoteric. As you can see, bicarbonate is a amphoteric, phosphate is an amphoteric, but this one is not amphoteric. Why? Because it doesn't contain oxygen, so it will not be able to provide hydroxyl ion. Again, similarly, options that contain only hydrogen will not be answered here. Okay, and why this option is not correct too? Option B and option D, out of option B and option D, which one should be the correct answer? The correct answer is option D. Why not option B? Because of what? Water is basically a neutral, though in some book it is written as amphoteric, but it is basically a neutral oxide. Rather, we are considering about buffer solutions that can act as a buffer. So the option D will be correct. Which is relatively more acidic. Human's first morning urine sample should be acidic. Cow's milk is not acidic; it is rather alkaline. Human night urine sample, black coffee. Basically, this one is acidic. All of them are a bit acidic, but we have to know that black coffee shows the lowest pH. This is also VVI. Why? Because you may fail to answer this correctly. Black coffee, caffeine-rich, caffeine-containing any drink, it causes acidity. Why? Because it itself is acidic. Which buffer solution is present in human blood? I mean, we have solved this question, around 4 times, I guess. Here, the option A is the correct answer. Option D is also correct, but better answer will be option A. How many times less acidic is a solution of pH 5 compared to pH 2? Again, that 1000. That ghost never left us. Which has the lowest pH? The lowest pH will be shown by the highest concentrated acid, which is option A. What is the optimum pH of fertile soil? Optimum pH of fertile soil should be 5 to 6. Which of the following solution has a pH greater than 7? pH greater than 7 will be demonstrated by acidic solution. This is acidic, but sodium carbonate has a pH greater than 7 means alkaline, right? Sodium came from sodium hydroxide, carbonate came from carbonic acid, so this will be a stronger base. The solution will be basic. What is the pH of 0.1 molar sodium potassium hydroxide? 0.1 molar. That means 10 to the power minus 1. 10 to the minus 1 means pH will be 1. POH will be 1 and pH will be 13. 40 minus 1 will be equal to 30. What is the value of POH in 0.001 molar sulfuric acid solution? See, this one is 10 to the minus 3 molar. So the pH will be 3, right? No, why not? Because it is sulfuric acid. To determine the pH of sulfuric acid, you have to add or multiply with 2. Because why? Because hydrogen is sulfuric acid donates 2 hydrogens. So it will be the concentration 2 into 10 to the minus 3 molar. Now, if you determine the pH minus log into 10 to the minus 3 molar, what will be the approach? See, we can easily write this way. 3 minus log 2. 3 minus log 2. Okay, and they're asking for the POH, which is 14 minus 3 plus log 2. Okay, 14 minus 3 will be equal to what? 11. And you need to add something at least with 11. So without determining the value of log, we can easily answer that answer will be more than 11 and it will be something. And by this we have already learned that log 2 will be equivalent to 0.3. We will show you how to memorize the logarithm value of 1 to 10 without any calculator. We will show the trick, but I'm showing this problem here because this one does not require a trick to answer. This is very, very simple math. Which of the following compound has the highest pH? Highest pH will be demonstrated by stronger base. pH of 0.01 molar acetic acid. Here it is mentioned that 12.5% dissociation of that acid at C concentration. Okay, let's find out. You should know that pH of weak acid should be determined using the concept of phosphor dilution principle. Here, the concentration of hydrogen ion is a product of its provided of its concentration into alpha. Concentration into alpha, that is degree of dissociation. Degree of dissociation. This concentration can be demonstrated as C. So C into alpha. Again, alpha can be represented as C into root over Ka by C. So we can simplify this and write as root over Ka into C. So to determine the pH, we have to determine minus log root over KaC, which can be demonstrated as minus half log KaC or minus log alpha C. These are the two options that we have to determine the pH of weak acid. As you can see, we have a dissociation degree, so we will apply the first option or the second one. So let's see here, minus log alpha or degree of dissociation is 12.5, which is 125 into 10 inverse 3, because percentage means 10 to the power minus 2 and point, so I'm making it simple. And here the concentration given is 10 to the power minus 2. Okay, now let's make it simple. Minus log 1 5 cube into 10 inverse 5. Okay, I think it's much more simple. So we can say that 5 minus log 3 log 5. 5 minus 3 log 5. But in this question, as we can see, not all the options are more than 5, or not the majority of options are more than 5. So we have to pinpoint calculate the answer. And in this case, the mnemonics or the trick to remember all the logarithm value will come handy. Okay, let me demonstrate that. First, make a box to isolate them. Okay, now let's write it down. Log of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we know that log 10 value is 1. Again, we know log 1 value is 0. So what we can say, that all the values between logarithm 1 and logarithm 10 falls under the decimal section. That is, it will be something point. Now, how will we recall? Write it down with myself. Repeat with myself. Repeat with me. 0.3 for 2. 0.3 for 2. 0.5 for 3. It should be 0.4, but it is 0.5. Again, just add up. 0.6, 0.7, 0.8. Now, if you write 0.9, then you will not get anything to write for 9. So here, it is 0.85. It is 0.9. Again, it is 0.95. These are very closest to the actual value that we get from calculator. So if we use this value, then we can solve the question. See, logarithm 5 got a value of 0.7. So 5 minus 3 into 0.7. 5 minus 2.1. So the answer will be 2.9. See, that's how accurate we have calculated. This is the approach that we will be following. What is the pH of boiling water? The pH of boiling water, you should know that the higher the temperature, hydrogen ion concentration is proportional to the temperature. Why? Once you increase the temperature, the degree of dissociation will be more. If you increase the concentration, then the pH will be less. So it will be slightly less than 7. But it's a matter of debate that whether it can be termed as acidic. No, this one will not be acidic. I mean, if you eat a boiled water, it will not be an acidic solution that you are eating. Rather, it will be neutral at that temperature. Which one is incorrect? The pH of 10 to the minus 2 molar, HCl solution is 2. No, I mean, we have solved this, I think. Here, the pH of 10 to the minus 9 molar solution will not be 9. We have solved it already. Sodium hydroxide is 100% ionic in a 0.01 molar normal sodium hydroxide solution. What's the pH of the solution? Anyway, if the equivalent number is 1, then the normality and the molarity does not get different. We know that N equal to SE, right? Or opposite, I think. It should be molarity will be equal to normality multiplied by equivalent number. Anyway, here for sodium hydroxide, the equivalent number is 1. So the normality and molarity will be the same. For 0.01 molar sodium hydroxide, the POH should be 12. Sorry, POH should be 2 and pH should be 12. This one POH. What is the pH of 10 to the minus 7 molar sodium hydroxide solution? 10 to the minus 7 molar sodium hydroxide solution will show a pH more than 7, not 7 or less than 7. What is the pH value of 0.001? Again, 10 to the minus 3. So the answer will be 3. What is the pH of an aqueous solution of neutral salt? This one will be 7, neutral means 7. What is the pH of 0.2 molar hydrochloric acid solution? 0.2 molar hydrochloric acid solution. See again, 2 into 10 to the power minus 1. So if you place minus logarithm, you can write 1 minus log 2. So it will be less than 1, right? It will be less than 1. And the option here is option C. What is the pH of an aqueous solution of sodium chloride? Aqueous solution of sodium chloride will be neutral, which is 7. The concentration of hydronium ion in a solution is 25 into 10 to the minus 4. What type of solution is it? Hydronium ion is very much in the solution, so this will be acidic. Which of the following element does not participate in the buffering action of blood in the human body? Does not participate, okay? So phosphate participates with the amino acid portion. This is amino acid. Amino acid, that is a component of proteins. Protein is a buffer. Sulfate does not come in any action regarding the maintenance of pH as a buffer. What is the soil pH limit for soil microorganisms to survive? We have already said it should be more than 3 and less than 10. What is the pH of air here that makes it look shiny and fresh? 4.1. 4.1. Again, this is something VI. I mean, this is not very important, but it is something that you may fail to recollect in exam hall. Which is an example of alkaline buffer? Sodium, ammonium hydroxide and ammonium chloride combination. What is the name of blood buffer? Yeah, bicarbonate carbonic acid blood buffer. This one is the best buffer. What is the pH of the toothpaste used to prevent tooth decay? The pH of toothpaste should be higher because the wall cavity pH is lower. To neutralize, you need a basic solution. So the option D will be the correct answer. Which one is used to reduce the pH of alkaline solution? pH of alkaline solution should be reduced by a fertilizer that contains phosphate or nitrate. So the option D will be correct. If the pH of the soil increases excessively, which one should be used to control it? Again, we need something to lower the pH, which is nitrate or phosphate. So all of them are nitrates, all will be the answer. What is the pH of soil in pottery? pH of soil in pottery should be 6 to 6.5. Which compound is used to increase the pH of acidic soil? To increase the pH, we need to add oxides or carbonate. So option D will be the correct answer. In which solution does blue litmus turn red? Blue, ABR. Acid turns blue litmus to red. So which one? Option B, A. What is the hydrogen ion concentration of digestive juice of stomach if the pH is 4.74? Okay, let's move backward. The pH is 4.74. It can be demonstrated as, you should know that this trick is applicable for to determine the hydrogen ion concentration from pH. Okay, this one is the way to determine concentration of hydrogen ion from a given pH. So once you get the pH, you will show that as a subtraction from its immediate whole number. That is 5 minus 0.26. Okay, 5 minus 0.26. Okay, and now if if you try to write down in the logarithm fashion, what will be your approach? As you know, 0.2 is the value of log 2, and log 3 shows a very higher value, which is, sorry, it should be 0.3. Log 2 shows 0.3 and log 3 shows 0.5. So it will be near to 2, which can be 2.1. Sorry, it will not be 2, it will be less than 2 because log 1 is 0. Log 1 is 0. It will be less than 2, but very close to 2. So we can say for 0.26, it can be log of 1. Near to 2, I mean 1.8. Okay, if it is 1.8, then we can say that it can be 1.8 into 10 to the power minus 5. The concentration can be 1.8 into 10 to the power minus 5. Why? Because it can be represented this way, that minus log 1.8 into 10 to the power minus 5. See, we got the correct answer. Option C is the correct answer. We got 1.8, we got a larger number, so we can easily say that option C is the correct one. So this is the trick that we should follow regarding determination of hydrogen concentration from pH. You need to just work backward. With this, our today's session got to an end. You should practice all the mathematical problems of the pH very carefully and sincerely so that you can manage to answer the correct one in the exam hall as well. Best of luck for everyone, and do ask your questions in our Q&A section to get your doubts clear. Anytime, anywhere, 24/7. All the best. Assalamu alaikum, dear students. Welcome to our today's class. Hopefully, your admission preparation is going smoothly. And today we are going to discuss or solve the questions from chapter 4, chemical changes, and it's going to be lecture 3. So, what are we going to be discussing in our today's session? As we can see, ionic product of water, which is auto-ionization of water, this is comparatively less important, and one of the most important topics for the admission test will be discussed or will be solved today, which is intensity of acid and base. Prior to solving the questions, let me clarify what kind of questions are you going to face in the exam hall from this topic. I should say that regarding ionic product of water, you may find easier questions like what will be the ionic product of water at certain temperature. There is a chart in your book from which you will get all the data that may come in the exam hall. Apart from those, you should have clear idea regarding the conjugate acid bases. Those conjugate acid base, the theory of conjugate acid base comes from Bronsted-Lowry concept. And Bronsted-Lowry concept also states that the counterpart, I mean the conjugate acid of a base, if the base is stronger, then the conjugate base will be weaker. So there's a question that comes in our mind that how much strong or how much weak will that be? In this case, we get the help from ionization of water. Since we all know Ka into Kb will be equal to Kw. So once we get a dissociation constant of a conjugate base or the acid itself, then we can determine the dissociation constant of the other by dividing with or by 10 to the minus 14. Anyway, we will solve it accordingly. Moreover, regarding the ionic product of water, there are some numerical information as I have said already, not just the 1 into 10 to the minus 41. Moreover, besides 55.5 molar water, how much molecule gets dissociated in certain temperature, such numerical information are also there in the book. So numerical informations are also our priority. And regarding the acid base strength, I recommend you to know the tricks, how to determine the strength of a acid or base. I mean, we do not have to determine the Ka or Kb. Rather, we have to determine the comparative analysis. I mean, which one is stronger or which is the correct order. In this case, I recommend you to know the technique to determine the strength. Technique to determine strength. You need to go through that, and along with this, you have to practice ample questions so that you can easily, without any wasting time, you can easily mark the right answer. So here, I also recommend that you should go for the Ka-Kb chart that is available in your book. So once you get to learn all this, once you manage to finish all this topic, then you will be able to answer all the questions that may come from this topic. Anyway, let's start solving the questions from our first topic, which is ionic product of water, that is auto-ionization of water. As we can see in the medical admission test 19, 20, 21, 22 session, we got it repeatedly, and there is a potential to be appeared in your exam as well. Anyway, what is the ionic product of water at 25 degrees Celsius? In this case, the answer will be what? The answer should be 1 into 10 to the power minus 14. This is a very easy question. I think it doesn't require any explanation. Let's move on to the next question. In our next question, as we can see, this is the reverse question. What is the ionic product of water is actually? Kw is mainly equilibrium constant, no. Solubility product, no. Rate constant, no. It is actually ionic product. So this also doesn't require any other explanation. As we move to the next question, we can see that what is the value of hydrogen ion in pure water? This is also a derivative question from the ionic product of water. I mean, we know 10 to the power minus 7 will be the concentration of hydrogen ion and hydroxyl ion. If we multiply them together, then we will get 10 to the power minus 14. So in this case, the answer will be 10 to the power minus 7 mole per liter. And this is a very important information in some other regard, because once you get to determine the pH of an acid of a very dilute concentration, I mean, this is very weak. Once you get to solve that or get to determine the pH, then you may find that more than 7. In fact, actually, no pH of an acid can be more than 7, because more than 7 will be alkaline at room temperature, right? In this case, we have to add up the hydrogen ion concentration of the water itself to make it less than 7. Anyway, you know about that. Let's move on to the next question. What is the pH of pure water at 25 degrees Celsius? Pick up the question appeared itself, which is 7. Okay, anyway, this is quite easy, I think. If we move on to the next question, we can see what is the value of Kw in 298 Kelvin. I mean, how many times you have to face that same questions in a different way? It's like presenting the child of a crocodile repeatedly. I mean, I think you have already remembered that story. Anyway, this is what it is. It is 10 to the power minus 14. If someone, I mean, by instinct or by impulse, mark this one option D as correct, then he or she may lose the number. Anyway, let's move on to the next question. What is the pOH of pure water? The hydroxyl ion concentration of pure water would be 10 to the power minus 7, so the pOH would be 7. Anyway, what is the pH of pure water? The pH of pure water is not more than 7, not less than 7. It will be only equal to 7. But there's a but. If there was a temperature more than 25 degrees Celsius, then the number should not be equal to 7. Then the number would get decreased. Why? Because at higher temperature, the dissociation gets increased. And the increased dissociation could result into lower pH. But that lower pH doesn't signify that the solution becomes acidic. Rather, it signifies that the pH at that temperature is the neutral pH. I mean, if I can recall you that at 100 degrees Celsius temperature, the pH of a pure water becomes 6.53. So at 100 degrees Celsius temperature, that 6.53 is the neutral pH. If we get below that, it would be acidic. If we get above that, then it would be alkaline. Let's move on to the next question. Which one is the unit of ionic product? The unit of ionic product, actually, any constant that starts with K, Ka, Kb, Kw, all of them are unitless. This is to be remembered always. KCKP, even KCKP are also unitless. But there are some questions where you may find that unitless or no unit is not an option. In that case, there is a way to determine that unit, and we have already talked about that. And the question here, as we can see, ionic product of a water, there should be no unit. Yet there is no option such as no unit. So how should we approach? As we know, the concentration unit is mole per liter. Since we are multiplying two concentration here, as we can see, for hydrogen ion, as we can see, the ionic product of water will be represented this way. It's not like hydrogen ion; it is expressed in this way: hydronium ion. Okay, H3O plus, along with that hydroxyl minus. In this way, it is represented. Anyway, if we represent the ions in this way, then we will find that the concentration would be 10 to the power -7 for hydronium ion, and the concentration of the hydroxyl ion would be 10 to the power -7. All of them are expressed in mole per liter, mole per liter. So if you multiply mole per liter along with another mole, by another mole per liter, what will you get? You will get mole square liter inverse 2. And we found our answer in option B. Okay, next question. As we can see, ionic product of water increases when? I've already stated that when hydrogen ion concentration gets higher, then the ionic product of water would increase, right? Any of the concentration, hydrogen ion or hydroxyl ion, if gets increased, then the ionic product will increase. But there is a but. Once you get more hydrogen ion, then the hydroxyl ion would tend to decrease that increasing concentration and make it balanced. So in that case, the pH does not change significantly, or the ionic product doesn't change significantly. When the ionic product of water gets changed significantly, that's when the temperature comes to play. So when temperature is increased, when you increase the temperature, then the concentration or the dissociation of the ions gets increased. As a result, the ionic product gets increased. As I have said already, at 100 degrees Celsius temperature, the product would not be 1 into 10 to the -14, it would be much more than that. Which is right about pH of water? pH of water depends on pressure? No, doesn't depend on pressure. I mean, if you say depends on pressure, if you say this one is incorrect, then the other one should be correct, right? But here is a twist. Actually, it is neither dependent nor independent of pressure. I mean, it is not related to pressure. Rather, we have to mention that the pH of a water basically depends on the temperature. The term should not be heat. It should be temperature. It should be temperature. And here, option C will be the answer. Let's move on to the next question. What is the molarity of pure water? As I have said already, if you heard closely, I mean, I think you have already listened that I have mentioned the molarity of pure water would be 55.5 molar. Actually, in this case, I have to mention a few more points in this regard. The pure water, molarity of pure water is very high, which is 55.5 molar. What does it signify, or what does it tell? It tells that out of 5,555 lakh molecules of water, only one molecule gets dissociated. I mean, this is the actual representation of the dissociation of water. I mean, if you get to learn about this fact, then you will agree that water or pure water dissociates in a very less amount. We have already mentioned that one molecule out of 5,550 lakhs molecule. So, as we have mentioned, the equilibrium sign, what will be the position of the equilibrium? The position of the equilibrium would be to the extreme left. As we all know, if the position of equilibrium is at the right side, then we say that the amount of product is higher. If we mention that the position of the equilibrium is in the opposite side, which is left side, we say that the amount of reactant is higher. But if the amount of reactant is significantly high, I mean, the reaction hasn't started actually. In that case, we say that the dissociation is very low, and also we say that the position of equilibrium at the extreme left of the extreme left of the side. Anyway, in this case, you have to remember that the dissociation is very negligible, and that is the reason why water is a non-conductor. Pure water doesn't conduct electricity. You may wonder that if we capture anything wet, or if we hold something wet, then it has the potential to conduct electricity. But you need to know that when water mixes up with any other thing, then there are some contamination in the water, and in that case, the water gets the conducting capacity. Otherwise, in pure state, it does not conduct any sort of electricity. So, in our next question, we are saying that what is the molar concentration ratio of hydroxyl ion and hydrogen ion in pure water? The ratio will be 1. This is a very easy question. I mean, we are wasting our time. Next question, what is the pKw value of water? Again, similar question. If you are asked about Kw, the answer would be in terms of chemical something. But if you are asked regarding pKw, then the answer will be in whole number, which is 14 here. Now, let's move on to our next topic, which is intensity of acid and base. Anyway, I should also add in terms of autoionization of water. I mean, who proposed the autoionization of water? Autoionization of water was described by two scientists who are Kohlrausch and Headwheeler. And I don't know if the pronunciation is spelling is correct, but the pronunciation is all right. The Kohlrausch and Headwheeler proposed the autoionization of water, and law of mass action is applied here to determine the concentration. Anyway, let's move on to the next topic, which is intensity of acid and base. In the dental admission test, we found questions in 2021 session, and in medical admission test, we got questions in 1920 session. What are those? The question will be which one is a strong acid, which one is a stronger acid, which one is a weak base, which one is a weaker base. That's it. Or which is the correct order of the strength of an acid or base. Okay, let's start solving question. Which of the following is not a strong acid? See, as I have told you already, this is the question. Hydrochloric, nitric, sulfuric acid. If you get such options along with ethanoic acid, it is not difficult to mark the weakest one. As we all know, ethanoic acid is a weak acid. If you don't know, or if you don't recognize the weak acid at once, you should go through your book. All the organic acids are somewhat weak, and the inorganic acids, I mean, the halo acids and the oxo acids are very much stronger. There's a comparison between them. From out of these three, hydrochloric acid should be the strongest one because of the higher Ka. You should know that the strength of an acid is dependent on some factors. What are those? Let me describe one by one. The first one should be Ka. Ka is proportional to the strength of an acid. So the higher the Ka becomes, the higher the strength becomes. If we say that the term pKa, then it would be inversely proportional to the strength of an acid. Why? Because pKa is the negative logarithm of the Ka. The lower the pKa, the higher the strength. Unfortunately, we do not recall all the dissociation constants of different acids. It's quite difficult. To some extent, it's impossible. So what would be our approach in other cases? Now, if I say for halo acids or hydro acids, which is HX, in this case, we have to look at the size of halide. Size of halide is proportional to the strength. So which one will be stronger, hydrochloric acid or hydroiodic acid? Certainly, hydroiodic acid will be stronger. Why? Because of the higher or greater size, iodine does not want that hydrogen ion in. That's why the hydrogen ion gets dissociated easily, which results into the higher dissociation constant as well as low pH, which is also an expression of higher strength. In our next approach, I mean for oxo acids, what will be our approach? For oxo acids, we need to determine the oxidation number of central atom. Oxidation number of central atom. Oxidation number of central atom. Oxidation number of central atom is directly proportional to the strength of an acid. Okay. So nitric acid and sulfuric acid are oxo acids. Now, which one will be stronger? As you can see here, the oxidation number of nitrogen will be +5. How did I determine that? The oxidation state of oxygen is -2. 3 times -2 will be -6, and along with them we should add up +1 for hydrogen. -6 +1 will be equal to -5. So the central atom would show +5 oxidation state. Similarly, we all know how to determine the oxidation state of sulfur in case of sulfuric acid, which is +6. So the strength of an oxo acid, if the question was asked in this way, that which is the weakest oxo acid here, in that case the answer will be C. The higher the oxidation state, the higher the strength. What if the oxidation state becomes similar? What if both of them are +5? In that case, you have to look for what? You have to look for the constant size of the central atom. For nitric acid, this is +5. For H3PO4, phosphoric acid,
you know 4 times minus 2 will be equal to minus 8 and plus 3, which is also resulting into the oxidation state of phosphorus S plus 5. Both of them are equal. Now, what will be our consideration point? If both of the oxidation state is equal, then we have to look at the size of the central atom. In this case, we have to look at the size of the central atom. Here, you should know that the size of the central atom is inversely proportional to the strength, of an acid. So nitrogen is smaller than phosphorus, so we can easily say that the nitric acid will be stronger than phosphoric acid. Now you should wonder also about that if there is an exception to this rule. Actually, there is. If you think about phosphorus acid, which is H3PO3, the oxidation state of phosphorus here will be minus 6 plus 3, which is plus 3. Just considering the oxidation state, you will certainly tell that phosphoric acid is stronger than phosphorus acid. But the matter of fact is, this is not true. This is not true. Here, the dissociation constant of phosphorus acid is more than the dissociation constant of phosphoric acid. That's why phosphorus acid is stronger than phosphoric acid. The value of the dissociation constant will be available or is available at your book in the KAKB chart. The Ka chart of different acids are there. You will find the concentrations of phosphorus and phosphoric acid. So this is an exception to the rule. This is an exception to the rule. You should note it down carefully in your copy so that you do not do any mistake in our upcoming weekly or daily exams. Let's move on to the next question. In this question, as we can see, the question is which of the following is stronger base? Here, as you have seen, sodium is positively charged, potassium is positively charged. The charge is higher in case of calcium hydroxide and ammonium hydroxide. Actually, ammonium hydroxide is a weak base. We all know about that. In terms of sodium hydroxide, potassium hydroxide, calcium hydroxide, which one will be stronger? Stronger base will show better dissociation. From Fajan's rule, we know all ionic compounds are not 100% ionic. There are some covalent nature of every ionic compound. Sodium hydroxide, if we talk about it, the charge plus potassium, similar charge. Then how will we compare the polarization nature? It would be dependent on the size of the cation. We know that sodium ion is smaller than potassium, so it would result in higher polarization. Higher polarization means higher covalent nature. Higher covalent nature means less solubility in water. So in this case, the sodium hydroxide will be less soluble than potassium hydroxide. Why are we not considering about calcium hydroxide? Because we already know high charge means high polarization and high polarization means high covalent nature. So here the answer will be option B. How did we determine the answer? The answer was based on Fajan's rule. Let's move on to the next question. Strength of acid depends on what? We have already solved that. Strength of an acid dependent on potassium, no, dependent on degree of dissociation, which is Ka. Which acid has Ka equal to 5.5 into 10 to the power minus 2? This is such a question. This is a question that is either you know or no, not know. If you know, you will be able to answer. From where this question came, you have to look at your book, the Ka chart. Ka chart of your book. The answer will be dichloroacetic acid. In this regard, I would recommend you to learn that chloroacetic acid is 80 times stronger than the acetic acid itself. And we also know about the Ka of formic acid and acetic acid. We know that 1.8 into 10 to the power minus 5, here it will be 1.8 into 10 to the power minus 4. This is quite known to us because we have already determined we are going to determine the pH of the weak acids. And the benzoic acid is, I think, 3 point something into 10 to the minus 8 or whatever. Let's move on to the next question. Which is stronger? Acid. We have already solved similar type of question. Now let's solve it again. Plus 5, plus 5, plus 7, plus 6. I think you got my point. The oxidation state is higher in case of perchloric acid. The answer will be C. Which one of the following is the weakest? Again, let's move on. Plus 7, plus 6, plus 7, plus 5. So all of them are big shots here. Now even nitric acid seems weaker. The answer will be option D. Which is a pair of conjugate acid base? You should know that if you remove the hydrogen ion from an acid, it becomes the conjugate base. If you add up a hydrogen ion, along with base, then it becomes conjugate acid. So water is a base. So water, along with water, if you add a hydrogen ion or proton, it becomes a hydronium ion. So if it is a base, then it is its conjugate acid. If it is an acid, water will be its conjugate base. So the answer will be option B. What is the conjugate acid of ammonia? To determine the conjugate acid, you have to add a proton. So the answer will be ammonium. What is the basicity of phosphorus acid? How do we determine the basicity? In this case, I recommend you a trick. For oxoacids, you have to know that if the central atom is its highest oxidation state, let me clarify once again. For oxoacid, if the central atom's oxidation number is in its highest state, I mean, we know that the highest oxidation state of phosphorus will be +5. So if, as we can see in phosphoric acid, highest oxidation state is available. So in this case, all the three hydrogen atoms will be possible to be dissociated. That's why it will be able to neutralize 3 bases. I mean, 3 moles of monohydroxylic base such as sodium hydroxide. In this case, the basicity corresponds to the number of hydrogen atom present within the molecule for the highest oxidation state. What happens when the oxidation state becomes low, like H3PO3? Here the oxidation state becomes +3. For a reduction in the oxidation state, there will be reduction in basicity, and in case of instead of 3, the number will be 2. And what happens for this? As you can see, the oxidation state gets decreased further, which is +1. In this case, the number of hydrogen atom, I mean the basicity would decrease a bit more, which is 1. Okay, so the lesson is very clear. For oxoacid, if the central atom is in its highest oxidation state, then the number of hydrogen atom will correspond to the basicity. Once the oxidation state gets decreased, the basicity will decrease or will get decreased accordingly. So the answer will be 1. Next question, what is the acidity of aluminum oxide? This is very crucial. You have to memorize it. Okay, for aluminum oxide, acidity and basicity, you have to memorize it. Acidity will be equal to 6, basicity will be equal to 2. Just memorize it. But how did we determine that? The technique to determine acidity and basicity, you have to react with acids and base. If we write up the reaction, we will find that aluminum oxide will be able to react with 6 moles of hydrochloric acid. On the other hand, aluminum oxide reacts with 2 moles of sodium hydroxide to produce sodium aluminate. That's how we have determined the acidity and basicity. Moreover, there is a trick to determine acidity, which is total charge of the metal. Here, as you can see, aluminum is the metal. There is 2 atoms of aluminum. The charge is +3 for each atom. So total charge will be +3 into 2, which is +6. That corresponds with the acidity. But for basicity, no such trick works. There is a plain trick, which is react with sodium hydroxide. And if you get to write the balance equation, then you will find the answer. The answer will be here. What will be the answer? The answer will be 6. What is the conjugate acid of sulfate, hydrogen sulfate? To get a conjugate acid of hydrogen sulfate, you have to add a hydrogen. So the answer will be sulfuric acid. Which is the conjugate base? Similar question. Just instead of acid, we got base. To get a base, we have to remove the hydrogen ion. So the answer will be sulfate ion. Which of the following is amphoteric? Amphoteric means it got dual nature. It can be acidic in times, it can be basic in times. Which one is amphoteric? Regarding amphoteric substance, you need to know that if central atom shows highest oxidation number, then you have got to understand that the oxidation state can get higher than that. That means, hey, this is the turn to get reduced. So once a molecule gets reduced itself, it oxidizes other. So at highest oxidation state, a molecule acts only as oxidant. On the other hand, or similarly, we can write down that lowest oxidation state molecule will act as reductant only, because they are at the lowest level, they are not going to be reduced anymore, so they will be oxidized. The molecule that gets oxidized acts as a reductant. So what happens if the oxidation number comes in between highest and lowest? If it is in between highest and lowest, then it got the dual nature. But in this case, are we focusing on the dual nature or duality of the acid and base? To some extent, yes. But in this question, the oxidation number is not important. What is important, that to get a conjugate acid, you have already learned that to get a conjugate acid, you have to add a hydrogen, which is easy. You can add a hydrogen from anywhere. But to get a conjugate base, you have to remove the hydrogen. So for removing hydrogen ion or hydrogen atom, you need to have the hydrogen in the molecule. So we have to look at all the agents here. You may find that hydronium ion is amphoteric. No? For hydronium ion, you cannot just add up one more hydrogen, it becomes H4O2+. No, it doesn't happen this way. For carbon, there is no hydrogen, so you will not get any conjugate base. For ammonium, you may get NH4+ and NH2-, but this is not stable. On the other hand, a more stable version is available for bicarbonate. Why? Because if you just add up hydrogen ion, it becomes carbonic acid. If you remove that hydrogen, it becomes carbonate, which is also stable. So the answer will be option B. Here, bicarbonate gives the dual nature. In fact, this is the basis of one of our most fundamental buffer in our blood system, which is bicarbonate buffer. Bicarbonate got the potential to neutralize slight addition of acid and base. That's how it acts as a buffer solution. Not just only bicarbonate is there. Bicarbonate is also present along with carbonic acid. Which of the following is amphoteric? Here the answer will be option C. Water is amphoteric. Which of the following is amphiprotic? I mean, if you do not read carefully, then you may read that amphoteric too. So that would result into a disaster. Amphiprotic means it got does it actually say something different? No. Amphiprotic and amphoteric are quite similar actually. So there will be no disaster. In this case, the answer will be hydrogen sulfate, since it has got the potential to become a conjugate acid and conjugate base is Ag. Which of the following is the dissociation constant of hydrochloric acid at 25 degrees Celsius? This question also appeared from the pKa chart that I have mentioned. pKa chart of your book. So you have to go through that, which is 2.5 into 10 to the power 7. Very high pKa. Not pKa. It is actually Ka. This is Ka. Which one of the following is the weakest acid? Since all of them are oxo acid, we have to find out the lowest oxidation state to get the lesser, or I mean, weaker acid. We know for boric acid it is +5, right? No, not +5, it will be +3. +3. Here we get +5. Here we get +3. Here we get 4, +3. But there's a but. Since you get all of them +3, then what will be our next decision turning point? The next point of consideration will be the size of the central atom. As we can tell from it here, like chlorine would be greater than phosphorus and boron. In fact, all of them are within the same period. I think not phosphorus. Phosphorus is in the fourth period, third period, and boron is in the second period. Anyway, phosphorus and chlorine is larger than boron. This is the decision point. That's why we are going to mark option A as the correct answer. Here, boric acid is the weakest one. What is the basicity of sulfur dioxide? To determine the basicity, you have to react that with what acid? Not 6 actually. You have to react that with hydrochloric acid. If we react that with hydrochloric acid, we will get what? To get H2SO4. H2, actually not basic. We are sulfur dioxide is an acidic oxide. Why we are going to react with acid? Rather, we will react with base. If sulfur dioxide reacts with sodium hydroxide, we'll get sodium sulfate plus water. To balance the equation, we have to add 2 sodium. Okay, that's how the equation gets balanced. So we can easily tell from the equation that one sulfur dioxide molecule reacts with 2 moles of sodium hydroxide. That's why the basicity will be option A. Which of the following acid will be the strongest acid? Here, again, we have to determine the central atom's oxidation state. Here, the answer will be 3 times -2 -6 -2 plus -6 plus 2 will be equal to plus -4, which is +4 here. +6 +7 +7. Now, between parturic acid and para-iodic acid, which one is stronger? Central atom size comes to be lower in terms of chlorine. So parturic acid will be stronger acid here. So option C is the correct answer. Acidity of ferric oxide, Fe2O3. As we have learned already, to determine the acidity, we can quickly calculate the total charge. Since iron is 3 times positive, 3 positively charged, and total number of iron here is 2, 3 times 2 will be equal to 6. The answer will be option C. Which is the conjugate acid for H2O? To get a conjugate acid, you have to add a hydrogen, which is hydronium. Which is the conjugate base? To get a conjugate base, you have to remove a hydrogen, which is hydroxylium. What is the acidity of calcium oxide? Again, to determine acidity, we have to find out the total charge, which is +2. Which is the conjugate acid for hydroxyl? Similar question, conjugate acid, so add hydrogen, it becomes water. What is the basicity of M2O3? Here, there's a twist. To determine the basicity, you need to react with what? You need to react with a base. Suppose M2O3 is reacting with sodium hydroxide. If M stands for aluminium, the answer would have been 2 sodium MO2 plus water. The answer would be like that if M was aluminium. Instead of aluminium, if it is another 3 positively charged metal, in that case, the number of molecules that is required to get this neutralization reaction done would become 6. So there is a twist. There's a doubt whether we are going to mark option A as correct or option C as correct. In our book, option C is mentioned correct, but I'm clarifying everything once for all, which is if the question was about aluminium oxide, the answer would have been 2. Okay, if it was aluminium, the answer would have been 2. Since the metal is not mentioned here, there is a possibility of getting a basicity of 6. So the answer will be 6 if the identity is not disclosed. Which will dissociate more in solvent? Certainly, stronger acid will dissociate more in solvent. Here, the stronger acid will be parturic acid. Why? Because bromine and chlorine would show similar oxidation state, but chlorine is smaller than bromine. Which is right in case of hydrogen sulfate. Its conjugate base will be sulfate. True, because to get a conjugate base, you have to remove the hydrogen. The answer will be option A. What does the intensity of hydroxide depend on? Hydroxide depends on the size of the halogen, size of anion. Which of the following is the strongest acid? Strongest acid will be hydrogen iodide. Conjugate base. To get a conjugate base, remove the hydrogen. So the answer will be carbonate. What is the correct order of intensity of acid? This is a question that puzzles our head in the exam hall. We get puzzled with this greater than less than sign and eventually fall in the trap of the wrong answer. So to solve this type of question efficiently, we need to focus on a single option. Let's go for option A since it appeared on the top. +6 +5 +7 +7. But there's a but. Both of them shows similar oxidation state, but the parturic acid is stronger than boric acid because of smaller size of central atom. So we have to get an order that starts with parturic acid showing highest dissociation or highest intensity. And in this case, out of all the options, we found option B is the correct one because here the parturic acid starts the order. Which of the following is the strongest acid? This is a question that needs to be memorized. This acid is called par-fluoro antimonic acid. Par-fluoro antimonic acid. This is a very strong acid. In fact, out of all these 4, this is the strongest one. Par-fluoro antimonic acid is a very strong acid. Note it down in your copy. Which one is strong acid? Again, we have to determine the oxidation state, which is +3 +5 +4 +6. So answer will be option D. Which acid has more strength? Carbonic acid is a weak acid. Forget about that option. Out of these 4, these 3, option D will be correct because of higher oxidation state. Which one is the relation between degree of dissociation and concentration of weak electrolyte? Before jumping into the options, big options, let's remind ourselves regarding the Ostwald dilution principle, which is alpha will be equal to √Ka/C. That means degree of dissociation of a weak electrolyte is inversely proportional to the square root of its concentration. In simpler terms, the less the concentration of a weak electrolyte, the higher will be its dissociation. So degree of dissociation will be inversely proportional to the square root of concentration, which is present in the option D. Which oxy acid has more strength? We have already solved that because of higher oxidation number, right? You may be wondering, this is +5, this is also +5. Then why nitric acid is stronger? Because it is smaller in size. Which is monoalkaline acid? The basicity is 1 for which acid? We have already solved this question. It's option B. What is the alkalinity of aluminum oxide? We have clarified that earlier. If you are asked about the basicity, the answer will be 2. If you are asked about the acidity, the answer will be 6. Which one of the following acid has the highest value of Ka? Highest value of Ka means highest strength. So in this case, parturic acid will be the strongest one. If the concentration of a solution of a weak acid is C and the dissociation constant is Ka, then the concentration of hydrogen ion in that solution will be equal to √Ka into C. Why? Because hydrogen ion concentration will be equal to alpha into C. So alpha is equal to root over Ka by C. So if you multiply them, then you will get root over Ka into C. That's it. Which aqueous solution has the highest pH? Highest pH means lowest strength or least strength. Potassium nitrate, ammonium chloride, sodium carbonate, or sodium bicarbonate, or sodium carbonate. Which one? Which aqueous solution has the highest pH? To get the highest pH, you have to consider about the salt that is made up of. Potassium came from potassium hydroxide, nitrate came from nitric acid. Both of them are strong. So potassium nitrate will be neutral in nature. Ammonium hydroxide, hydrochloric acid. So here the acidic part will predominate. That's why ammonium chloride is an acidic salt. This is an acidic salt. Sodium bicarbonate, sodium hydroxide, carbonic acid. Again, there is sodium hydroxide, there is carbonic acid. But as you can see, here the charge of sodium ion is less than this, because the total charge is here plus 2. One single sodium atom plus 1, but 2 atoms, so plus 2. Anyway, in this case, if we dilute this salt with water, then we will get 2 moles of sodium hydroxide. On the other hand, if we dilute the earlier option, we will get 1 mole of sodium hydroxide. So which one would result into higher pH? Certainly 2 moles of sodium hydroxide. That's why option D is the correct answer. Which has the highest proton affinity to show the highest proton affinity? What is proton affinity actually? We know that according to Bronsted-Lowry concept, if any molecule accepts a proton, it becomes a base. So which one is a stronger base? Ammonia or phosphine? Such question already appeared in our book. As an explanation, we have learned that the size of nitrogen is less than phosphorus, and the electronegativity is higher in case of nitrogen. That's why the possibility to gain a proton, or also the possibility to donate the lone pair electron, is higher in terms of ammonia. That's why ammonia shows highest proton affinity as well as higher strength than phosphine. For which is Ostwald's law applicable? Ostwald's law is applicable for weak electrolytes. Ammonium chloride is not a weak electrolyte. Ammonium carbonate is a weak electrolyte. But will that be the answer? No, actually, not only just weak electrolyte. It rather implies on weaker acids or weaker base. So salts are not going to be discussed in this section. Ostwald's law will be applicable for weak acid or weak base. Since ammonium hydroxide is a weak base, the dissociation will be based on Ostwald's law dilution law. This question, which of the following is a cationic acid? Actually, this is a not poorly formulated question, because for an acid to be said as cationic acid, it needs to have a positive charge. There is no such option here. But in our book, option C is mentioned correct, but this is the wrong question. I'm repeatedly saying this is the wrong question. Actually, such as ammonium ion. Ammonium ion is a cationic acid. Ammonium ion will be a cationic acid because it got a positive charge. Anyway, let's move on to the next question. In this question, out of this acid, among this acid, the number of diabasis acid will be what? If we look at this, for sulfuric acid, the basicity will be 2. For phosphoric acid, the basicity will be 3. For phosphorus, the basicity will be 2. But here, the basicity will be 1. In this case, for carbonic acid, the basicity will be 2. For boric acid, the basicity will be 1. For carbonic acid, the basicity will be 2. For sulfurous acid, there is a twist. As we have already mentioned, that the higher number of oxidation state in the central atom would result into the higher number of basicity. I mean, the number of hydrogen atom will correspond with the basicity. But in this case, for sulfurous acid, the basicity does not get decreased along with decrease in the oxidation state of sulfur. Here, even though the oxidation state of sulfur is low, but the basicity of sulfurous acid will be 2. For oleum, the basicity is 2. So among these acids, the number of diabasis acid will be 1, 2, 3, 4, 5, 6. Option B will be correct. Which is diabasis acid? Again, such a question. Here, the basicity will be 1. The basicity will be 1. So option B is the correct one. Which is the strongest base out of these 4? As we all know, according to Fajan's rule, smaller the size of cation, higher the polarization. So larger cation, less polarization, so more ionic. The answer will be cesium hydroxide because of its larger structure. Out of bicarbonate, ammonia, hydrogen sulfate, phosphate, hydrogen phosphate, hydroxyl, and hydrogen phosphide, how many will act as both Bronsted acid and base? To act as both Bronsted and acid and base, you need to have both positive charge, and there should be a hydrogen atom as well as negative charge. We get 1, 2, 3, 4, 5. We got 5. So the answer should be 5, is it? How many will act as Bronsted acid base? Bronsted acid and base. If we remove that hydrogen atom, then it will become what? If we remove that hydrogen atom, it will become an acid, conjugate base. It will become a conjugate base. But if we add up a hydrogen, it will become H+O7, which is sodium. It will be a conjugate acid. But for hydroxyl, if we remove the hydrogen, it will become O2 minus. O2 minus will not exist in such a case. So we can out of these 6 options, hydroxyl actually will not act as both Bronsted acid and base, because we can add hydrogen, but removing that single hydrogen would be difficult from this atom. So the answer will be basically option C, which is 4. Ammonium hydroxide is a weak base. It is more weakened in the presence of what? We know that according to the common ion effect, to decrease concentration of a certain ion, we need to add that ion. So in this case, the option D will be the correct answer. Due to common ion effect, concentration of the ammonium ion will get decreased. So along with that, the hydroxyl ion dissociation will also get decreased. So it will be weaker. Neutralization reaction that follows Arrhenius law. According to Arrhenius law, we know that acid provides hydrogen ion and water, hydroxyl ion is provided by the base in a aqueous solution. So for Arrhenius law, no gaseous state will be applicable, no solid state will be under consideration, only aqueous. So option C will be the correct answer. Which is the conjugate base of sulfuric acid? To get a conjugate base, remove the hydrogen. It will become hydrogen sulfate. Which of the following is a Lewis acid? Lewis means electron. Which provide lone pair electron is a Lewis base. Which gets that lone pair electron, that is, which is an electrophile, is a Lewis acid. Here, hydrogen ion is a Lewis acid because it is capable of gaining that 2 electrons, since it got no electrons. The degree of dissociation of acid A is to the concentration of the solution. Actually, we have already solved this question, which is inversely proportional to the square root. Which of the following acid has the highest pKa value? Highest pKa value means lowest strength or high strength. It shows highest strength. So, highest pKa value means lowest strength. Highest pKa value means high strength. So in this case, the weakest acid will be ethanoic acid. As we have already mentioned, the chloroethanoic acid is 80 times stronger than ethanoic acid, and dichloroethanoic acid is more stronger than chloroethanoic acid. If the value of pK is 4, it is of which class of acid? If the value of pK is more than 3, so it will be medium strong. If it is less than 2, it will be very strong. Maximum dissociation occurs in concentration of what? Maximum dissociation is possible in case of more dilute or more or negligible concentration of a weaker electrolyte. So in this case, the most dilute version is option A. That's why there will be most dissociation. Which of the following acid has the highest Ka value? Again, this will be the correct answer because this is the stronger one. Which one is Lewis acid? To become a Lewis acid, it will act as an electrophile. Which one got? Actually, you have to remember that the group 13 compounds mostly act as an electrophile. Which conjugate acid is stronger? Conjugate acid becomes stronger in terms of what? Because in terms of presence of that hydrogen ion and the possibility to donate that hydrogen ion. And in this regard, hydronium ion is the stronger conjugate acid. You have to remember that the strength of a conjugate acid is inversely proportional to its mother base. I mean, if the base is strong, the conjugate acid will be weak. If the base is weak, the conjugate acid will be strong. water is a very weak base. I mean, it's a neutral compound. It is not either acid nor base. So the conjugate acid will be very strong, and the conjugate base will also be very strong of water. Anyway, let's move on to the next question. Aqueous solution of sodium carbonate is what? Aqueous solution. So for sodium carbonate, if we determine its parent, I mean parent compound, which is sodium hydroxide and carbonic acid, we can easily assume that sodium hydroxide will predominate over the carbonic acid. So the aqueous solution will be basic. Addition of water to sodium chloride forms what? Addition of water to sodium chloride would result in dissociation of sodium chloride. So with that, our questions, all the questions of the two topics, that is ionization of water and intensity of acid and base, were solved from different letters of your main book. What is my suggestion? That is, try to solve these questions without without any more explanation. Just try to solve those questions as quickly as possible. As you all know, from this topic, there is a potential to get acid-base integrated question that's common from the exercise questions. So you have to focus on solving those questions, especially from the Gonzaga book, because those were a bit complicated. The rest of the books provided easier questions. Anyway, best of luck for your preparation. Allah Hafiz.
Assalamu alaikum, dear students. Hopefully, all of you are safe and well. Today, I welcome you all in our masterclass, which is on chapter 4, chemical change, and it will be lecture 6 today. Today, we are going to discuss or solve important mathematical problems from this chapter. What sort of mathematical problems do appear from this chapter? Let's clarify on that at first. There are some pH-related maths. Those pH-related mathematical problems are very crucial for medical admission test because we do have a tendency to get pH-related problems more often. Instead of the usual KAKB-related maths, these KAKB-related maths appear less often than pH-related maths. So we will also solve KAKB-related math, but we should focus more on pH-related math. And regarding pH-related math, there are some subtypes. Like you have to determine the concentration from pH. You may have to determine pH from concentration. And this too is both applicable, will be both applicable for strong acid, strong base, as well as weak acid, weak base. Okay. Moreover, you may have to determine pH of buffer solution. pH of buffer solution. With Henderson-Silva equation, we usually solve or determine the pH of buffer solution. These are the all probable mathematical problems that may appear from pH section. Besides, KAB related math is usually dependent on the molar, ionic product of water. Sometimes you will get Ka, you have to determine the Kb. Ka into Kb equal to Kw. From that formula, you may derive the answer. Besides Ka, Kb related math, we may also find Kp, Kc related math. Kp, Kc related math. And also, there are some problems that are related to equilibrium related math. So, if I prioritize the sections according to your medical admission tests requirement, then I should say that you should give utmost importance to pH-related math, and rest of them are your secondary consideration. First, you should prioritize on solving all the pH-related maths at once, and all the mathematical problems that appeared in your exercise we will solve today, and also you should try to solve at your own after this class. With that, you will be able to solve it quickly in a very short span of time. When these questions are mentioned in your book in exercise section, they thought that you will get calculator to solve it because the book is designed for the HSC exam. But last few years, we see that we got to see that there are direct appearances in our medical admission test from the exercise section, and they do not think that whether it is going to be solved. It is going to be solved with the help of calculator or not. They don't bother about it. They just give what it is. So you have to be prepared enough to solve those problems without any calculator. Okay, let's focus on our first question. Before going to first question, let me show you that in recent times there are appearances from this section. So you should be very careful regarding this. These questions are difficult ones, and if you can manage to answer it properly or mark it correctly, then you will have the better chance to do better in the admission test. Anyway, our first question is, what is the molar concentration of hydrogen ion in the digestive juice of a stomach when pH is 1.4? See, this is the type. Let's say this is type 1, where for strong acid, strong base, you have to determine concentration from pH. Okay,
you should note it down in your copy and you will make a note out of today's class so that you will get all the types together in your copy. So this is our first step. Okay, let's see how we can solve this. Before jumping to solution, we have to know that to determine the pH value of something or to determine the concentration from a pH value, we must know at least logarithm value of 1 to 10. And I will show you how you can easily do that. Let's make a box again to keep all the logarithms and their values together. Okay, let me write one by one. Suppose this is log 1. We know this is equivalent to 0. And at the bottom, I have written log 10. We all know which is 1. So we do know log 1 equal to 0 and we do know log 10 equal to 1. So we can easily assume that all other logarithm values from 2 to 9, it would be decimal because it will be more than 0 and less than 1. So let's write down all the logarithms right now. Log 2, log 3, log 4, log 5, log 6, log 7, log 8, log 9. See, you may be wondering that why did I write down all those logarithm values in a congested fashion? You may be wondering or you may be thinking that it would have been better if I could write log 10 a bit lower or if I take the box a bit higher, isn't that? But I actually did that on purpose. Why? Because it will show you a bit, it will give you an idea about the logarithm value itself. How? Let me clarify that. The logarithm values of the upward section like log 1, log 2, log 3, these values range higher than the higher values of logarithm. I will show you how the picture itself demonstrates the value changes. To recall all the logarithm values, we will use a trick right now. What is that? Just repeat with myself, repeat with me, repeat louder. For log 2, we will write for log 2, 3, 2, 3, 3 for 2, 2, 3. So what will be 3? It would not be 4, it would be 5. Skipping that 4, we will go to 5. 3.5, log 4, it would be 0.6. See, we again get a chronology. For 3, we get 5. For 4, we get 6. This is already, you should remember that it will be in decimal. For 5, I know you got it right, which is 0.7. For 6, I know you are again correct, which is 8. So 3 for 2, 5 for 3, 6 for 4, 7 for 5, 8 for 6. If we go this way, then we will get end up within 8. Because for 7, if we get 0.9, then we will end up at 1 at logarithm 8. But we have to go to log 10. That's why we have to be a bit careful right now. For 7, it would be 0.85. For 8, it would be 0.9. For 9, it would be 0.95. I know if you use calculator, it would not be the same as it is mentioned here, but it is very near to the actual value, and that's what it would be required to solve it accurately. I mean, if you predict or if you presume the values as such, you will get a correct answer. You will get a very correct answer, which is almost nearby the actual result. So it would not be difficult for you to determine or find out the correct option if you use these values. So as I have said earlier, see, log 1 is 0, log 2 is 0.3. The range is huge. Log 3 is 0.5, range is almost 0.2, and range is 0.1. See, 0.3, 0.2, 0.1. The range is getting diminished. The range is getting diminished, and that's what actually happens when you mention or when you determine the values using the calculator. You'll find that when the logarithm value goes up, I mean log of 8, log of 9, the range or the difference between them gets low. Okay, that's what I wanted to demonstrate, keeping this congested fashion. Anyway, let's move on to our next, into solving this question. Here we got a pH of 1.4. Now we have to go a bit backward. What would be our step? We will try to solve this way. Like if it is pH 1.4, then what we can write? We can write this way. Like it would be 2 minus 0.6. Okay, it can be written this way. Any pH is given to you, you will express it as a subtraction from its immediate whole number. So from that, we can write 2 minus log 4. We got 0.6 for log 4. So it can be stated as 2 minus log 4. And if you are very clever, then you will easily understand that this can be written in this fashion, which is logarithm of 4 into 10 inverse 2. See, we got the concentration. As you have seen that this is the digestive juice of the stomach. This is the digestive juice of the stomach. You already know that this is hydrochloric acid. This is hydrochloric acid and this is a monoprotic acid. Since this is a monoprotic acid, we do not have to divide this concentration with any number. We can just answer the correct one by finding it 0.04 molar. And we have already seen the option here, which is option D. Suppose this is not digestive juice. Suppose instead of digestive juice, the question asked about concentration of sulfuric acid. If for the same condition, if you have to determine the concentration of sulfuric acid, then you have to divide this 4 into 10 to the power minus 2. 4 into 10 to the power minus 2 with 2. Why? Because sulfuric acid provides 2 protons, and while determining the pH, we had to multiply the concentration with 2 to get the pH. That's why to get the accurate value of concentration, we have to divide that again by 2. So for sulfuric acid, the answer would have been 0.02 molar. I hope all of you got understood what I meant to say. So that's the approach regarding determination of concentration from pH. You have to represent this way. You have to represent the pH value as a subtraction from its immediate whole number, and then you will express that according to the logarithm fashion. And in many cases or in plenty cases, you will find it easier to solve it this way. The difficult ones, I will also show you how you can do that without a calculator. Let's move on to the next question. Here we can see what is the pH of decimolar ethanoic acid. They are asking pH of decimolar ethanoic acid, and they provided Ka. Okay, so this is another type. Let's say this is type 2. Here we have to determine the pH from concentration for weak acid and weak base. We have to determine pH from concentration for weak acid and weak base. So let's see how we can solve this. We all know for strong acid and strong base, we represent this way. pH, P of H is equal to minus logarithm of hydrogen ion concentration. That's how we represent pH for strong acid and strong base. But for weak acid and weak base, we know that the concentration is not enough. Here, hydrogen ion concentration is actually a product of their concentration and their dissociation degree, which is alpha. According to Ostwald dilution principle, again we can say that alpha is equal to root over Ka by C. This is according to Ostwald dilution principle. So we can write it down again this way, root over Ka into C. Because C is a square root of square root, right? That's why by dividing with root C, we will get root over Ka dot C. So either we have to use this Ka or we have to use the degree of dissociation to determine the pH of weak acid or weak base. So what would be the final formula look like? The final formula for weak acid, the pH can be determined using this formula minus logarithm alpha into C or minus half logarithm Ka C. Okay, that's how we determine this pH value for a weak acid and weak base. Now let's focus on this question. As we can see, the K is provided here, so we will use this version for this question. Okay, we will use this version. So if I use this version, what can I write? Suppose we have to determine the pH, so I have written down the pH. Now minus half log 1.8 into 10 inverse 5 into decimolar. Decimolar means 10 to the power minus 1. Okay, decimolar means 0.1. Centimolar means 0.01. We all know that. So we have to multiply with 10 to the power minus 1. Okay, let's simplify this a bit, which will be minus half log
1.8 into 10 to the power minus 6. So again, it can be written as 3 minus half log 1.8. I hope you already understood why I have written down this 3, because log 10 to the power minus 6 would be equal to 6, because log 10 is equal to 1, but multiplying with it with half, we will get 3. So after that, now here it is a problem, because we do not know about the logarithm value of 1.8. Instead, we know logarithm value of 2. Log 2 is equal to 0.3. Log 1 is equal to 0. So a value less than 2. I mean, for logarithm 1.8, the value would be less than 3. And we can assume that the value can be 0.26. You can also predict that it is 0.28. The difference would be very minimal. So you can assume what you want, but you have to keep it near to 3. So we can say that it would be 0.26. Let's consider this 0.26. So the answer will be 3 minus 0.13. The final answer would be 2.87. So this is our final answer. Okay. Now let's see if it is an option. Yes, this is present in option 3. So we can easily solve a problem related to pH without any calculator. This is the difficult one that you can solve without any calculator. I hope all of you got to understand this. Our next question is asking 20 ml 1.5 molar sodium hydroxide solution gets mixed with 1.5 molar, 1.5 ml 2 molar, 1.5 ml 2 molar sodium hydroxide. Then what is the concentration of the mixture? What will be the concentration of the mixture? So for this we have to use a formula for mixture, which is SM into VM, which is molarity of the mixture and the volume of the mixture. And it can be stated as this way, which is equal to the component 1 plus component 2. Since all of them, I mean, the components of the mixture are same, that's why we do not have to use the equivalent number. We can just keep it simple this way, because this is about the same compound, which is sodium hydroxide. So for this, if I determine the concentration of the mixture, it would be like this: V1S1 plus V2S2 divided by V of M. Now let's put down all the values. We get 20 into 1.5. Again, we have 1.5 into 2, and at the bottom, we can say 20 plus 1.5. So if I write it after calculation, we will get 33. For 20 into 1.5, it will be 30, and it is 3. So 33 divided by 21.5. Okay. Now let's think. If you multiply 21, not 21, actually, let's assume that it's 22. If you multiply 22 with 1.5, what would you get? Then the value would be like this. The value would be like this one. 15 divided by 10. So it would be like 2.2 into 15, which is 33. To some extent, it would be equal to 33. Okay. So if we multiply 22 with 1.5, then we will get 33. So if I divide 33 with 1.5, we will get a value of 1.5 something. I mean, a bit more than 1.5. So the most accurate answer will be 1.5. If we calculate with calculator, then we will get 1.53. But just I try to show you how we can simplify the solution without using calculator. What is the value of hydrogen ion in pure water? This is something you have to memorize, which is 10 to the power minus 7 mole per liter. What is the pH of 0.00, which is 5 into 10 to the power minus 2? This is very simple. This is the type 3. This is the type 3, where for strong acid and strong base, you have to determine concentration, not concentration actually, you have to determine pH from concentration. Okay. So determine the pH from concentration. See, let's say for sulfuric acid, the molarity is 0.005, which can be written as 5 into 10 to the power minus 2. But for sulfuric acid, you have to multiply it with 2. So it will eventually be 10 to the power minus 1, because 5 into 2 is equal to 10. So if you multiply 10 inverse 2 with 10, you will get 10 inverse 1. And the logarithm value of 10 inverse 1 is equal to 2, right? You have to know that actually this is not 10 to the minus 2. This is 10 to the power minus 3. That's why the value became 10 to the minus 1 actually. It was incorrect. This one is the correct one, 10 to the power minus 3. Now you have to multiply it with 2, then you will get 10 into 10 to the power minus 3. So you will get 10 to the power minus 2. And if we logarithm it, then we will get 2. For log 10 inverse 1, we will get 1. But for log 10 inverse 2, we will get 2. The answer will be option A. pH of a solution is 6. If more HCl is added to the solution, pH becomes 3. Such question appear numerous time in our HSC exam and in our exercise. We have to be very careful about this type of question. This is very simple. Change in pH. Change in pH should be expressed as the power of 10. Okay, so the pH got changed by 3. So the concentration or the increase of concentration of hydrogen will be 10 to the power 3, which is 1000 times. Option A is the correct one. At which temperature hydrogen and dark purple colored iodine react to form hydrogen iodine close continuum? This is not a mathematical problem. This is basically a memory type question, which is 450 degree. Okay, this is not a mathematical one. What is the pH of 0.05 molar H2SO4 solution? Again, we have solved this type of question, which is here, as we can see, 10 to the power minus 2 into 5 into 2. So the logarithm value would be 1. Why? Because we get 10 to the minus 1 here. Minus log of 10 to the minus 1 will be equal to 1. What is the pOH of 0.1 molar HCl? This is also very simple. For 0.1 molar HCl, you have to know that for a monoprotic acid, if the concentration tends to end with 1 after decimal, you have to count the digit after decimal. The number of digit will resemble the pH value. Like we got only one digit after decimal and it ended with 1. So we can easily say the pH is 1. pH is 1. So what will be the pOH? pOH will be 13. 14 minus 1 will be equal to 30. So the answer will be D. What is the pH of 1% sodium hydroxide solution? You should know that from percentage, we have to determine molarity. This is the formula to get molarity from percentage. As we can see, we got 1%, which can be expressed as 1 by, if it is 1, then what will be the molarity? Molecular weight. Here M stands for molecular weight, and we know molecular weight of sodium hydroxide is 40, and we got 10 here. So what will be the molarity? The molarity will be equal to 10 by 40 or 1 by 4, which is 0.25 molar. But instead of using this 0.25 molar, we will solve it from this. We will determine the pH from this value 1 by 4. How? Let's see. If this is the concentration, then minus log 1 by 4 is its pH. This is not pH, this is actually pOH because it is a base. So to get a pH, we have to subtract it from 14. Okay. So to get a pH for a base, we have to subtract it from 14. Now let's write it down. 14 minus log 1 plus. Why plus? Because if it is in division within the log, then it would be log minus something, but minus and minus will become plus. So log 4. Now let's write down the value from out of our memory. For log 1, we get 0. For log 4, we get 6, which is 0.6. So 14 minus 0.6. It would have been 14 minus 0.6, right? So will it be 14.6 or 13.4? Actually, this value there's a problem here, which is log 1 by 4. If I write it down, let's keep it simple. I think there is a bit wrong here. Let's solve it again. For sodium hydroxide, if we determine the P of H, what would be the case? It would be minus log 1 by 4. 1 by 4. Okay. So as we know, it can be stated this way: minus log 1 minus log 4. Right? So it will be plus log 4. Basically, this is log 4 because log 1 is equal to 0. So log 4 value would be equal to 0.6. Now we have to subtract it. We have to subtract it from the 14. To get a pH, we have to subtract the 14 minus P of OH. That's why the value would be 13.4. Okay. If I try to solve it quickly, keeping the 14 within the minus, then it will be wrong because here the whole value, basically minus logarithm value is the value of the pOH itself. You have to put a minus before pOH. So instead of minus, we had to give it plus for the earlier phase. Instead of giving that, we got to get the wrong answer. We got 14.6 at the first time, but I showed it deliberately because that's where you do mistake as well. That's why you have to be very careful regarding calculation of pH from pOH. You should try to solve it separately. If you do it together, then you have to keep your eye on the minus value because pOH, within the pOH, there is a minus, and if you put a minus before pOH, then the minus and minus will become plus. Okay, that's where you have to be paid. Anyway, we got our answer, which is option D. What is the pOH of semi-molar sodium hydroxide solution? Okay, let's solve it again. This is the type that we have solved already. So it is the P of H equal to minus log semi-molar. Semi-molar, by semi-molar, it means 0.5, which is 5 into 10 inverse 1. So it can be demonstrated as 1 minus log 5. As we all know, the logarithm 5 value is 0.7. So the P of H would be equal to 0.3, and the answer is option C. Which of the following is the closest pH of 10 to the power value of 10 to the power minus 9 molar sodium hydroxide? Closest pH value of 10 to the power minus 9 molar sodium hydroxide. We can solve it with a calculator. Why? Because if you dilute an acid in a very negligible concentration, you will not get a base. The pH will not be higher than 7. That is also applicable for the base or the alkali. If you dilute it, if you lower its concentration, then it will not decrease to a point where it becomes an acid. So after dilution of sodium hydroxide to a level of 10 to the minus 9 molar, we will get a pH nearby 7, but it would not be lower than 7. Okay, what is the pH of 0.01 molar sodium hydroxide? We have solved it already, right? For P of H, we have to determine the pOH first, which is minus log 10 to the power minus 2, which is 2. So pH would be equal to 12. The answer will be option C. If the molar concentration of hydrogen ion is 1 into 10 to the power minus 9, this is the molar concentration of hydrogen ion, which is 1 into 10 inverse 9. What will be the molar concentration of hydroxyl ion? Okay, here we have to use the formula of Kw. Kw equal to Ka into Kb. So here the hydrogen ion concentration, that is equivalent to Ka, which is 10 to the power minus 9, and hydroxyl ion concentration is equivalent to Kb. So Kw is equal to 10 to the minus 14. So what will be the answer? Kb will be equal to 10 to the minus 5. Okay, so the option C will be the right answer. In a buffer solution, there is a halide and there is an acid, right? Okay, same concentration. If Ka is 10 to the power minus 8 for Hx, what will be the pH of the buffer solution? Anyway, let's see. For pH of a buffer solution, we use this formula pKa plus log salt concentration by acid. Okay, both of them are of same concentration, so the value would be equal to 1. And we have to determine the pKa, which is minus log 10 to the power minus 8 plus log 1. So what we get? We get the value of 8 because log 1 is equal to 0. This is not a very difficult question. Some students may find that such Ka value is frightening to them. Anything above 10 to the power minus 2 is frightening for some of the students. Do not get frightened. Try to think simple. You will get the answer simply. If pH equal to 8.45 of a solution, what will be the concentration of hydrogen ion? So again, we got a pH. So what will we do? We will represent the pH as the subtraction value from immediate whole number, which is 9.45. We get 9.9 minus 155. Now let's see. If it is 9, we can write down this way, like log 0.5 is the value for log 3, right? We all know log 3 we get 0.5, and for log 4 we get 0.6. So any value of 0.55 would be between log 3 and 4, which is let's assume that it is log of 3.5. Let's assume that. Okay. So what will be the case here? Minus log 3.5 into 10 inverse 9. Okay. See, we got our answer. Just assuming the value is near about 3.5, just assuming that we got our answer, which is option B here. If the initial concentration of one reaction is 0.1 mole per liter, this is the initial concentration. Okay, let's write it down. This is the initial concentration, 0.1 molar, and the final concentration is 0.05 molar. Okay, and this is after 20 seconds. Then what will be the rate of reaction? So what is the difference? The difference is 0.05. Now you have to divide it with 20. We have to find out the rate of change of concentration. So we will get 5 divided by 20 into 10 inverse 2. So what we get? 1 by 4 into 10 inverse 2, which is 0.25 into 10 inverse 2. Okay, and we can write it down this way: 2.5 into 10 inverse 3. This one is available at option B or here. So the correct answer will be option B, which is 2.5 into 10 inverse 3 mole per liter per second. If a solution has an OH concentration of 3.4 into 10 inverse 1, what is the pH of the solution? This is the type we have already solved. From concentration, we need to determine pH. So let's write it down simply: minus log 3.4 into 10 inverse 1. See, this one will be P of OH, not pH, because it is the concentration of hydroxyl ion. Let's determine that first. We get 1 minus log 3.4. See, we got it earlier. Like for log 3, we get 0.5. For log 4, we get 0.6. So it would not be 0.5, it would not be 0.6, it would be in between. Let's assume that it would be log 1 minus log 1. The value would be equal to 0.54. Let's assume if it's 0.54, then the value would be 0.44. What is that? This is the P of OH. So then what would be the pH? The pH would be 140 minus 0.44. So the final answer will be equal to 13.54. Okay. So we got the correct answer, which is option D. Okay. If the value of pOH for an aqueous solution is 8, here they mentioned that the pOH value is 8, then what will be the ionic concentration of hydrogen ion? So if pOH is equal to 8, then pH will be equal to 6. By subtracting it from 14, we can get that. So the ionic concentration of hydrogen ion would be 10 to the power minus 6. The option D will be the correct answer. The concentration of hydrogen ion in an aqueous solution, as it is 0.001 molar, we have to count the digit after decimal, which is 3. The answer will be 3. What is the pH of 0.1 molar HCl? We have already solved that, which is 1.
What is the pH of sodium hydroxide solution of centimolar, which is 0.01 molar? Since sodium hydroxide is a monohydroxylic base of equivalent number 1, so we can easily say that the pOH value will be equal to 2 pOH. But for pH, the value would be equal to 14 minus 2, which is 12. If pOH is equal to 5, what is the concentration of hydrogen now? If pOH is 5, then pH will be equal to 9. See, so the hydrogen concentration will be 10 to the minus 9. Okay. If the pH of blood is 7.4, what is the concentration of hydroxyl in mole per liter? This is very important. We have to determine the pOH. So pOH will be equal to 14 minus 7.4, which is 6.6, right? We get 6.6. Now we have to determine the concentration from this pOH. As it is 6.6, we can write it down this way, 7 minus 0.4. It can be stated again, 7 minus log, what? For log 2, we get 0.3. For log 3, we get 0.5 instead of 0.4. Let me clarify this here. For log 2, the value is 0.3. For log 3, the value becomes 0.5. So instead of 0.4, it becomes 0.5. So what would be the value of what? I mean, by logarithm means by using logarithm on which value we will get 0.4. It will be it will be a value in between 3 and 2. So let's assume that it's log 2 points. It's log 2.4. Let's just assume that log 2.4. If it is log 2.4, then we can say the concentration can be expressed this way, minus log 2.4 into 10 inverse 7. Okay. So what is the most approximate value near to 2.4 into 10 minus 7 in these options? As we can easily say the most nearby or the nearest value would be equal to 2.5 into 10 minus 7, and this is the answer here. So just repeat with me. If we have to determine any hydroxyl ion, or I mean, if we have to determine hydrogen concentration from pH, we have to go backward. And in case of determining the logarithm value, we have to assume a bit, and we will get the right answer if we assume correctly. In this reaction, as we can see, this is the reaction of Haber-Bosch process, which is production of ammonia. Here, as we can see, what will be the K1 for this? The concentration of the product. How do we determine the Ka? We just write down the product's concentration divided by the reactant's concentration, right? So we can write down this way that reactant by product. If we write it down this way, then it would be like N2 into H2. The power will be 3, and at the denominator we will get ammonia. The power will be 2. The coefficient becomes power in the equilibrium constant equation. For K2, we can write this way: N2 to the power half, H2 to the power 3.5, ammonia to the power nothing, right? See, this is the K2 value, this is the K1 value. If we square root K1, then we have to multiply the power with half. So it will become 3 by 2, it will become half, and if we divide 2 by 2, we will get 1, which is nothing. So as you can see, we just got this. So root over K1 will be equal to K2. So the answer will be K2 equal to root over K1. Option C is the correct answer. If the concentration of hydrogen ion in a solution is 10 to the minus 4 mole per liter, then what is the pOH of the solution? Very easy question. If it is 10 to the minus 4, then the hydroxyl ion concentration should be 10 to the minus 10. Why? Because the summation of the product should be equal to 10 to the minus 14. So if it is 10 to the minus 10, then what will be the pOH? The pOH will be C, which is 10. What is the pH value of 4% sodium hydroxide solution? Again, a similar type of question which we solved earlier. Percentage equal to molar Sm by 10. So we can say that 40 by 40 is equal to S. So the molarity is 1. The molarity is 1. So what will be the pH value of sodium hydroxide solution? The pH value will be 0, right? No, the pOH value will be 0. The pH value will be 14. This is the pOH value, and this is the pH value because this is the base. The answer will be option D. Which pH of the following is applicable for 1 molar hydrochloric acid solution? Similarly, for 1 molar hydrochloric acid solution, we will get a pH of 0. What is the pH of 1% HCl solution? Again, 1%. 1% equals molarity into molecular weight. It's almost 37.5 and 10. So we get 10 by 37.5 as molarity. Now we have to determine the pH. Now, if we think about it, it is 37.5. Let's see, minus log 10 divided by 37.5. Okay. So what will be the case here? Minus log 10 plus log 37.5. This is the case. And minus log 10 will be equal to 1. What will be the value for 37.5? For log 37.5, I mean, we can easily simplify this a bit. How? Let's see. Let's make it a bit simple without doing unnecessary calculations. We can write this way. Suppose this is minus log. This is 1 by 3.75. Right? We can easily write that. So what will be the case here? This is actually minus. Sorry, the value will be plus because minus log 1 minus log 1 minus it will become plus. So minus it will be log 3.75. Now, as we know, for logarithm value of 3, we get 0.5. But for logarithm value of 4, we get 0.6. So it will be closer to 0.6. So we can think as it is like 0.56 or 0.57. Let's consider that it is 0.56. Okay. If it is 0.56, we got the answer. The answer will be option A. Any other option is nowhere near to 0.56. That's why this is the correct answer. Okay, in this question, it's asked that a first order reaction has a rate constant of 1 into 10 to the power minus 2 per second. What is the initial rate of the reaction if the initial concentration of the reactant is similar? As we know, for first order reaction, R will be equal to K C to the power 1. This is the case because of the order of the reaction is 1. So here, the rate constant is 1 into 10 inverse 2. And the initial concentration is decimolar, that is 10 inverse 1. So what will be the rate? The rate will be equal to 1 into 10 inverse 3. So the option D is the correct one. The concentration of a reactant becomes 0.4 molar after first day, starting with initial concentration of 0.8 molar. At the end of 4th day, its concentration stands at 0.05 molar. What is the half-life of the reaction? What is half-life? Half-life is the time it takes to become the half of the concentration of the initial one. So the initial concentration, the concentration reactant becomes 0.4 molar after first day, starting with initial concentration of 0.8 molar. So from 0.8 to 0.4, it took 24 hours, right? So if it is 24 hours, then the half-life should be 1 day. Okay, let's move on to the next question. Okay, in this question, the initial concentration of reactants A and B are 2 molar and 1 molar. So the initial concentration is 2 molar and 1 molar for A and B. That will become C and D at equilibrium. The concentration of A is 1.6 molar at equilibrium. So let's say it is 2 minus 0.4. It should be 1 minus 0.4. Because to become 1.6, you have to disseminate 0.4. So the concentration of C and D would be 0.4 and 0.4 as well. So what will be the concentration of B and D at equilibrium? So the concentration of B will be
0.6 and D will be 0.4, which is option B. Okay, in this question, as we can see, dinitrogen tetroxide dissociates to form 2 moles of nitrogen dioxide. Here it is mentioned that 5 mole of dinitrogen tetroxide is heated to a certain high temperature and 20% of it dissociates. Now we have to determine the 20% of 5 mole. To determine the 20% of 5 mole will be equal to 5 into 20 divided by 100, which is 1 mole. Okay, so what would be the result if 1 mole dinitrogen tetroxide dissociates? It will generate 2 moles of nitrogen dioxide. So the correct answer will be option B. Okay, if the pH of an aqueous solution is 5, then what will be the molar concentration of hydroxyl ion? If the pH is 5, then the pH will be what? 9. So the molar concentration will be 10 to the power minus 9, which is option B. What is the molar concentration of a monobasic acid solution pH minus 1? See, minus 1 is also possible. If it is minus 1, then we have to consider that the value of the molar concentration should be minus log 10. Okay, so the concentration would be equal to 10. What is the pH of decimolar solution of a weak acid of 10% dissociation level? Okay, so if it is a decimolar solution, we have to express the concentration as 0.1 and the dissociation level as 10%, which is 0.1 as well. So the concentration basically 10 to the power minus 2. So what will be the pH? The pH will be 2. I have done that or solved it simplified way because we have already solved such questions. What is the pH of an acidic buffer solution if the concentration of acid and salt are equal? If the concentration of acid and salt are equal, then you get P of H equal to pKa plus log 1. Why? Log salt by acid will be equal to log 1. So you do not have to bother about that portion. It is basically pH equal to pK because log of the concentration of acid and salt are equal. So what will be the pH? It will be equivalent to pK, which is 3.8. If the pH of a solution is 1.5, what is the molar concentration of hydrogen ion? Again, 1.5 can be expressed this way 2 minus 0.5. So it can be demonstrated as 2 minus log 3. So it can be 3. It can be this way minus log 3 into 10 inverse 2. So this one is the concentration. So this one will be the concentration, which is option A. What is the pH of decimolar methanoic acid if its dissociation level is 10%? Anyway, if we consider the dissociation level, then again we have to multiply 0.1 with 0.1 since it's a decimolar. So the pH value would be equal to the pH value 10 to the power minus 2. The pH value would be nearby what? Near to 2. But since we do not have such option here, we get 2.37, 2.45. So we need to mark the one which is very near to 2. In that case, we will get the correct answer. But if you want to get the most accurate one, we have to go through the Ka version. How we can do that? That is minus half log Ka into C, which is 10 inverse 1. Okay. So what would be the case here? Minus half log 1.8 into 10 to the power minus 5. I mixed it, I multiplied that together. So we will get 2.5, 5 divided by 2, so 2.5 minus half log 1.8. Log 1.8. 2.5 minus half log 2 equal to 0.3. So log 1.8 will be equal to 0.26. So it will be 0.26. So if we write it down, 2.5 minus 0.13, right? So it will be equal to 2.37, the accurate one. Okay. Using the alpha C version, this one is alpha, this one is C. Using the alpha C version, we may not get the correct answer, but using the Ka version, we will certainly get the correct answer. So here it is. What is the pH of the molar concentration of diacetic base? Diacetic base means you need to multiply that concentration with 2 before calculating pH. Now you are going to calculate the pH, so you can write minus log 10 to the power minus 1. So the value would be 1. Okay, but the value would be 1 for what? This is actually pH or POH. This is POH, right? POH. So to get the pH value, you will have to subtract it from 14, which is 13. If the hydroxyl ion concentration of a solution is 3.5 into 10 inverse 4, then what is the pH? Before calculating pH, we will calculate the P of OH, which is minus log 3.5 into 10 inverse 4. Okay. Now it will be 4 minus log 3.5. Now, as we all know, for log 3 we get 0.5. For log 4 we get 0.6. So log 3.5 would get a value between 0.5 and 0.6, which is log of which is around 0.55. So if it is 0.55, then we can write 3.45. This is the POH. So what will be the pH? The POH will be equal to 40 minus 3.45, which is again 10.55. Yes, we have that answer, which is option B. Okay. This is a reaction given from dinitrogen pentoxide. We got 4 moles of nitrogen dioxide and oxygen. The concentration of nitrogen dioxide in the reaction increases by 3 into 10 to the minus 3 mole per liter in 6 seconds. What is the reaction rate? Okay. Here's a twist. Basically, to determine the rate, we have to what? We have to just divide the concentration change with the time. But when the reaction is given, then we get to see the mole number. So this one will be the value for all the 4 moles of nitrogen dioxide. But for 1 mole, we have to divide it with 1 by 4. Okay. So what will be the case here? 1 by 4, and the change here is 3 into 10 to the power minus 3, and the time period is 6. So 1, 2. So it is 1 by 8 into 10 inverse 3. Okay, which is 1.25 into 10 inverse 4. If you calculate, you can do that. 1.5, 1.25 into 10 to the minus 4. How much 0.01 molar HCl solution is required to change the pH value of 10 ml of 0.01 molar sodium hydroxide solution? Okay, you have to know that HCl is a monoprotic acid, and on the other hand, sodium hydroxide is a monohydroxylic strong base. So they would usually, 1 mole would usually replace another mole of the counterpart. So since the molarity are same, then to neutralize the 10 ml value, you need to have 10 ml. So the answer would be 10 ml. But they have said that how much 0.01 molar HCl solution is required to change the pH value by 1 unit. So basically, we have to change the pH value by 1 unit only. It's not by we do not want to change the pH value by much more. To change the pH value of the sodium hydroxide solution by 1 unit, we have to add up at least 9 ml of 0.01 molar HCl, because in that case the concentration would decrease by an extent, so that the pH becomes lower and it will be lowered by 1 unit. So the answer will be option B. What is the pH of 0.02 molar sodium hydroxide solution? Again, simple question. 2 into 10 inverse 2 is the concentration, so it will be log of minus 2 minus log 2. 2 minus log 2, so 2 minus 0.3, which is 1.7. And now if you have to determine this is P of OH or pH, you have to subtract it from 14. So we will get 12.3. The answer will be option C. pOH and pH of 0.01 molar hydrochloric acid solution are what? For 0.01 molar HCl, the pH will be equal to 2, so the pOH will be 12. The answer will be option C. What is the pOH of a solution of hydronium ion having a concentration of 0.01 molar? pOH would be 12 because the pH here is 2. What is the pH of a 0.1 molar ethanoic acid solution? Again, since we do not have any dissociation constant, we have to apply the Ka minus half log K. What is the K? 1.8 into 10 to the power minus 4, right? Or 10 to the power minus 5 actually.
Methanic acid is stronger than ethanoic acid. Here it is 1.8 into minus 5, and the concentration is 10 to the minus 1. Now let's determine that. So it will be 3 minus half log 1.8. So 3 minus half 0.26. So 3 minus 0.13, we get 2.87. This is the pH. Okay, we got the correct answer. Dinitrogen tetroxide is into 2 moles of nitrogen dioxide. For this equilibrium reaction, Kp equal to Kc when the temperature T is basically Kp equal to Kc RT to the power delta N. Okay. Now, how would we determine to become Kp equal to Kc? To become Kp equal to Kc, you need to multiply RT to the power delta N to become 0. Here, delta N value is, for this reaction, the delta N value is 2 minus 1, which is 1. So basically, Kp equal to Kc RT. Now, if T is basically, if T is equal to 1 by R, if T is equal to 1 by R, then from this equation, we can say that Kp equal to Kc. Okay. Now, if we divide the molar gas constant, if we divide 1 with the molar gas constant, we will get 12.18 Kelvin. Okay. So here, in this way, we can solve this question. Let's move on to the next question. Okay. In this question, if the initial rate of reaction in a solution is 0.2 mole per decimeter cube, the solution's initial concentration, initial rate should be 3 into 10 to the power minus 4. Let's write down this as C and let's write down this as 4. R. What is the rate constant? We don't know the order of the reaction, but we can easily assume from the units of the rate constant available in the option. Per second will be for what? Will be for the first order reaction. As we know, R will be equal to Kc. Okay. As R will be equal to Kc, here the R is initial rate, which is 3 into 10 to the power minus 4. And what is the concentration? Concentration is 0.2. So what will be the K? The K will be equal to 3 into 10 to the power minus 4 divided by 0.2. Why is this the case? Because all the options here is in per second, and per second is the unit for the first order reaction. Okay. So if we divide 3 by 2, we get 1.5 into 10 inverse 3. 1.5 into 10 inverse 3. So the option A will be the correct answer. Now in this reaction, Kc is 3.8 into 10 to the minus 3. What is the value of Kp at 250-degree temperature? Okay. This is the question where you have to use that technique, Kp equal to Kc RT delta N. But do not get alarmed by thinking application of the temperature. As we can see, the mole number is equivalent both sides. I mean, the number of product is equivalent to number of reactant. Kp will be equal to Kc as delta N is equal to 0. So we have already solved the question. We have solved anything. That is 3.8 into 10 to the minus 3. With this, our mathematical portions came to an end. You have to practice a lot to be more efficient with the calculator. Best of luck.